Welcome to Simplilearn's AWS full course. AWS or Amazon Web Services is the leading cloud platform used by businesses of all sizes. From startups to large operations, one of the most exciting and in-demand roles in this field is that of an AWS solution architect. As a solutions architect, you will be responsible for designing and managing cloud solutions that drive businesses' growth and success. In 2024, the demand for AWS solution architect is booming, and with that comes impressive salaries. On average, you could earn over $13,000 a year with even more potential as you gain experience. If you are seeking a career that's both fulfilling and secure, becoming an AWS solution architect is a great choice. This course will take you through the process step by step, giving you the skills needed to excel in this field. Let's get started.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
Before we begin, if you are interested in getting certified in cloud, check out Simplilearn's Cloud Architect Certification Program. Build expertise in AWS, Microsoft Azure, and GCP with our Cloud Architect Certification course. Plus, we have included an exam voucher for any Azure course, so you can get certified hassle-free. Gain access to official AWS authored self-learning content and master this ins and outs of cloud architectural principles. The course link is mentioned in the description box and in the pinned comment. So let's get started.
Meet Rob. He runs an online shopping portal. The portal started with a modest number of users, but has recently been seeing a surge in the number of visitors. On Black Friday and other holidays, the portal saw so many visitors that the servers were unable to handle the traffic and crashed. Is there a way to improve performance without having to invest in a new server? Wondered Rob. A way to upscale or downscale capacity, depending on the number of users visiting the website at any given point? Well, there is. Amazon Web Services, one of the leaders in the cloud computing market. Before we see how AWS can solve Rob's problem, let's have a look at how AWS reached the position it is at now. AWS was first introduced in 2002 as a means to provide tools and services to developers to incorporate features of Amazon.com to their website. In 2006, its first cloud services offering was introduced. In 2016, AWS surpassed its $10 billion revenue target. And now, AWS offers more than 100 cloud services that span a wide range of domains. Thanks to this, the AWS Cloud Service Platform is now used by more than 45% of the global market. Now, let's talk about what is AWS. AWS, or Amazon Web Service, is a secure cloud computing platform that provides computing power, database, networking, content storage, and much more. The platform also works with a pay-as-you-go pricing model, which means you only pay for how much of the services offered by AWS you use. Some of the other advantages of AWS are security. AWS provides a secure and durable platform that offers end-to-end privacy and security. Experience. You can benefit from the infrastructure management practices born from Amazon's years of experience. Flexible. It allows users to select the OS, language, database, and other services. Easy to use. Users can host applications quickly and securely. Scalable. Depending on user requirements, applications can be scaled up or down. AWS provides a wide range of services across various domains. What if Rob wanted to create an application for his online portal? AWS provides compute services that can support the app development process from start to finish. From developing, deploying, running, to scaling the application, up or down based on the requirements. The popular services include EC2, AWS Lambda, Amazon Lightsail, and Elastic Beanstalk. For storing website data, Rob could use AWS storage services that would enable him to store, access, govern, and analyze data to ensure that costs are reduced, agility is improved, and innovation accelerated. Popular services within this domain include Amazon S3, EBS, S3 Glacier, and Elastic File Storage. Rob can also store the user data in a database with AWS services, which he can then optimize and manage. Popular services in this domain include Amazon RDS, DynamoDB, and Redshift. If Rob's businesses took off and he wanted to separate his cloud infrastructure or scale up his work requests and much more, he would be able to do so with the networking services provided by AWS. Some of the popular networking services include Amazon VPC, Amazon Route 53, and Elastic Load Balancing. Other domains that AWS provides services in are analytics, blockchain, containers, machine learning, Internet of Things, and so on. And there you go. That's AWS for you in a nutshell. Now, before we're done, let's have a look at a quiz. Which of these services are incorrectly matched? 1, 2, 3, 4. We'll be pinning the question in the comment section. Comment below with your answer and stand a chance to win an Amazon voucher. Several companies around the world have found great success with AWS. Companies like Netflix, Twitch, LinkedIn, Facebook, and BBC have taken advantage of the services offered by AWS to improve their business efficiency. And thanks to their widespread usage, AWS professionals are in high demand. They're highly paid and earn up to more than $127,000 per annum. Once you're AWS certified, you could be one of them too.
Hello everyone, let me introduce myself as Sam, a multi-platform cloud architect and trainer, and I'm so glad and I'm equally excited to talk and walk you through this session about what AWS is and talk to you about some services and offerings and about how companies get benefited by migrating their applications and infra into AWS. So what's AWS? Let's talk about that. Now, before that, let's talk about how life was without any cloud provider, and in this case, how life was without AWS. So let's walk back and picture how things were back in 2000, which is not so long ago, but a lot of changes for better had happened since that time. Now, back in 2000, a request for a new server is not an happy thing at all, because a lot of money, a lot of validations, a lot of planning are involved in getting a server online or up and running. And even after we finally got the server, it's not all said and done. There's a lot of optimization that needs to be done on that server to make it worth it and get a good return on investment from that server. And even after we have optimized for a good return on investment, the work is still not done. There will often be a frequent increase and decrease in the capacity, and even news about our website getting popular and getting more hits, it's still an bittersweet experience, because now I need to add more servers to the environment, which means that it's going to cost me even more. But thanks to the present day cloud technology, if the same situation were to happen today, my new server, it's almost ready, and it's ready instantaneously. And with the swift tools and technologies that Amazon is providing in provisioning my server instantaneously and adding any type of workload on top of it and making my storage and server secure, creating a durable storage where data that I store in the cloud never gets lost. With all that features, Amazon has got our back. So let's talk about what is AWS. There are a lot of definitions for it, but I'm going to put together a simple and a precise definition as much as possible. Now, let me iron that out. Cloud still runs on an hardware, right? And there are certain features in that infrastructure, in that cloud infrastructure, that makes cloud, or that makes AWS a cloud provider. Now, we get all the services, all the technologies, all the features, and all the benefits that we get in our local data center, like, security and compute capacity and databases. And in fact, we get even more cool features like content caching in various global locations around the planet. But again, out of all the features, the best part is that we get everything on a pay-as-we-go model. The less I use, the less I pay, and the more I use, the less I pay per unit. Very attractive, isn't it? Right? And that's not all. The applications that we provision in AWS are very reliable because they run on a reliable infrastructure, and it's very scalable because it runs on an on-demand infrastructure, and it's very flexible because of the designs and because of the design options available for me in the cloud. Let's talk about how all this happened. AWS was launched in 2002 after the Amazon, we know as the online retail store, wanted to sell their remaining or unused infrastructure as a service or as an offering for customers to buy and use it from them, sell infrastructure as a service. The idea sort of clicked, and AWS launched their first product in 2006. That's like 4 years after the idea launch. And in 2012, they held a big-sized customer event to gather inputs and concerns from customers, and they were very dedicated in making those requests happen. And that habit is still being followed. It's still being followed as reInvent by AWS. And at 2015, Amazon announced its revenue to be 4.6 billion. And in 2015 through 2016, AWS launched products and services that help migrate customer services into AWS. Well, there were products even before, but this is when a lot of focus was given on developing migrating services. And in the same year, that's in 2016, Amazon's revenue was 10 billion. And not the least, as we speak, Amazon has more than 100 products and services available for customers and get benefited from. All right, let's talk about the services that are available in Amazon. Let's start with this product called S3. Now, S3 is a great tool for internet backup, and it's the cheapest storage option in the object storage category. And not only that, the data that we put in S3 is retrievable from the internet. S3 is really cool. And we have other products like migration and data collection and data transfer products. And here we can not only collect data seamlessly, but also in a real-time way monitor the data or analyze the data that's being received. That there are cool products like AWS Data Transfers available that helps achieve that. And then we have products like EC2, Elastic Compute Cloud. That's an resizable computer where we can anytime alter the size of the computer based on the need or based on the forecast. Then we have simple notification services, systems and tools available in Amazon to update us with notifications through email or through SMS. Now anything can be sent through email or through SMS if we use that service. It could be alarms or it could be service notifications if you want, stuff like that. And then we have some security tools like KMS, Key Management System, which uses AES 256-bit encryption to encrypt our data at rest. Then we have Lambda, a service for which we pay only for the time in seconds it takes to execute our code, and we're not paying for the infrastructure here. It's just the seconds the program is going to take to execute the code. If it's a short program, we'll be paying in milliseconds. If it's a bit bigger program, we'll be probably paying in 60 seconds or 120 seconds. But that's a lot cheap, lot simple, and lots cost effective as against paying for service on an hourly basis, which a lot of other services are. Well, that's cheap, but using Lambda is a lot cheaper than that. And then we have services like Route 53, a DNS service in the cloud. And now I do not have to maintain an DNS account somewhere else and my cloud environment with AWS. I can get both in the same place. Alright, let me talk to you about how AWS makes life easier, or how companies got benefited by using AWS as their IT provider for their applications or for the infrastructure. Now, Unilever is a company, and they had a problem, right? And they had a problem, and they picked AWS as a solution to their problem, right? Now, this company was sort of spread across 190 countries, and they were relying on a lot of digital marketing for promoting their products. And their existing environment, their legacy local environment, proved not to support their changing IT demands, and they could not standardize their old environment. Now, they chose to move part of their applications to AWS because they were not getting what they wanted in their local environment. And since then, rollouts were easy, provisioning new applications became easy, and even provisioning infrastructure became easy, and they were able to do all that in push button scaling. And needless to talk about backups that are safe and backups that can be securely accessed from the cloud as needed. Now that company is growing along with AWS because of their swift speed in rolling out deployments and being able to access secure backups from various places and generate reports, and in fact useful reports out of it that helps their business. Now on the same lines, let me also talk to you about Kellogg's and how they got benefited by using Amazon. Now Kellogg's had a different problem. It's one of its kind. Now their business model was very dependent on an infra that will help to analyze data really fast, right? Because they were running promotions based on the analyzed data that they get. So they being able to respond to the analyzed data as soon as possible was critical or vital in their environment. And luckily, SAP running on HANA environment is what they needed, and they picked that service in the cloud, and that sort of solved the problem. Now the company does not have to deal with maintaining their legacy infra and maintaining their heavy compute capacity and maintaining their database locally. All that is now moved to the cloud, or they are using cloud as their IT service provider, and now they have a greater and powerful IT environment that very much complements their business. Let me start the session with this scenario. Let's imagine how life would have been without Spotify. For those who are hearing about Spotify for the first time, Spotify is an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify now uses AWS Cloud to store the data and share it with their customers. But prior to AWS, they had some issues. Imagine using Spotify before AWS. Let's talk about that. Back then, users were often getting errors because Spotify could not keep up with the increased demand for storage every new day. And that led to users getting upset and users canceling the subscription. The problem Spotify was facing at that time was their users were present globally and were accessing it from everywhere, and they had different latency in their applications. And Spotify had a demanding situation where they need to frequently catalog the songs released yesterday, today, and in the future, and this was changing every new day. And the songs coming in rate was about 20,000 a day, and back then they could not keep up with this requirement, and needless to say, they were badly looking for a way to solve this problem. And that's when they got introduced to AWS, and it was a perfect fit and match for their problem. AWS offered a dynamically increasing storage, and that's what they needed. AWS also offered tools and techniques like storage lifecycle management and trusted advisor to properly utilize the resource, so we always get the best out of the resource used. AWS addressed their concerns about easily being able to scale. Yes, you can scale the AWS environment very easily. How easily, one might ask? It's just a few button clicks. And AWS solved Spotify's problem. Let's talk about how it can help you with your organization's problem. Let's talk about what is AWS first, and then let's bleed into how AWS became so successful and the different types of services that AWS provides, and what's the future of cloud and AWS in specific. Let's talk about that. And finally, we'll talk about a use case where you will see how easy it is to create a web application with AWS. Alright, let's talk about what is AWS. AWS, or Amazon Web Services, is a secure cloud service platform. It is also pay-as-you-go type billing model where there is no upfront or capital costs. We'll talk about how soon the service will be available. Well, the service will be available in a matter of seconds. With AWS, you can also do identity and access management, that is, authenticating and authorizing a user or a program on the fly. And almost all the services are available on demand, and most of them are available instantaneously. And as we speak, Amazon offers 100 plus services, and this list is growing every new week. Now that would make you wonder how AWS became so successful. Of course, it's their customers. Let's talk about the list of well-known companies that has their IT environment in AWS. Adobe uses AWS to provide multi-terabyte operating environments for its customers. By integrating its system with AWS Cloud, Adobe can focus on deploying and operating its own software instead of trying to deploy and manage the infrastructure. Airbnb is another company. It's an community marketplace that allows property owners and travelers to connect each other for the purpose of renting unique vacation spaces around the world. And the Airbnb Airbnb community users' activities are conducted on the website and through iPhones and Android applications. Airbnb has a huge infrastructure in AWS, and they're almost using all the services in AWS and are getting benefited from it. Another example would be Autodesk. Autodesk develops software for engineering, designing, and entertainment industries. Using services like Amazon RDS or Relational Database Service and Amazon S3 or Amazon Simple Storage Service, Autodesk can focus on deploying or developing its machine learning tools instead of spending that time on managing the infrastructure. AOL or American Online uses AWS, and using AWS they have been able to close data centers and decommission about 14,000 in-house and co-located servers and move mission critical workload to the cloud and extend its global reach and save millions of dollars on energy resources. Bitdefender is an internet security software firm, and their portfolio of softwares include antivirus and anti-spyware products. Bitdefender uses EC2, and they're currently running few hundred instances that handle about 5 terabytes of data, and they also use Elastic Load Balancer to load balance the connection coming in to those instances across availability zones, and they provide seamless global delivery of service because of that. The BMW Group, it uses AWS for its new connected car application that collects sensor data from BMW 7 series cars to give drivers dynamically updated map information. Canon's Office Imaging Products division benefits from faster deployment times, lower cost, and global reach by using AWS to deliver cloud-based services such as mobile print. The Office Imaging Products division uses AWS such as Amazon S3 and Amazon Route 53, Amazon CloudFront, and Amazon IAM for their testing, development, and production services. Comcast, it's the world's largest cable company and the leading provider of internet service in the United States. Comcast uses AWS in a hybrid environment. Out of all the other cloud providers, Comcast chose AWS for its flexibility and scalable hybrid infrastructure. Docker is a company that's helping redefine the way developers build, ship, and run applications. This company focuses on making use of containers for this purpose. And in AWS, the service called the Amazon EC2 Container Service is helping them achieve it. The ESA, or European Space Agency, although much of ESA's work is done by satellites, some of the program's data storage and computing infrastructure is built on Amazon Web Services. ESA chose AWS because of its economical pay-as-you-go system as well as its quick startup time. The Guardian newspaper uses AWS, and it uses a wide range of AWS services including Amazon Kinesis, Amazon Redshift that power an analytic dashboard which editors use to see how stories are trending in real time. Financial Times, FT, is one of the world's largest leading business news organization, and they used Amazon Redshift to perform their analysis. A funny thing happened. Amazon Redshift performed so quickly that some analysts thought it was malfunctioning. They were used to running queries overnight, and they found that the results were indeed correct, just as much faster. By using Amazon Redshift, FT is supporting the same business functions with costs that are 80% lower than what was before. General Electric, GE, is at the moment as we speak migrating more than 9,000 workloads including 300 disparate ERP systems to AWS while reducing its data center footprint from 34 to 4 over the next 3 years. Similarly, Harvard Medical School, HTC, IMDb, McDonald's, NASA, Kellogg's, and a lot more are using the services Amazon provides and are getting benefited from it. And this huge success and customer portfolio is just the tip of the iceberg. And if we think why so many adapt AWS, and if we let AWS answer that question, this is what AWS would say. People are adapting AWS because of the security and durability of the data and end-to-end privacy and encryption of the data and storage. Experience. We can also rely on AWS way of doing things by using the AWS tools and techniques and suggested best practices built upon the years of experience it has gained.
Flexibility. There is a greater flexibility in AWS that allows us to select the OS, language, and database. Easy to use. Swiftness in deploying. We can host our applications quickly in AWS, be it a new application or migrating an existing application into AWS. Scalability. The application can be easily scaled up or scaled down depending on the user requirement. Cost saving. We only pay for the compute power, storage, and other resources you use, and that too without any long-term commitments. Now let's talk about the different types of services that AWS provides. The services that we talk about fall in any of the following categories you see, like compute, storage, database, security, customer engagement, desktop and streaming, machine learning, developers tools, stuff like that. And if you do not see the service that you're looking for, it's probably is because AWS is creating it as we speak. Now let's look at some of them that are very commonly used. Within compute services, we have Amazon EC2, Amazon Elastic Beanstalk, Amazon Lightsail, and Amazon Lambda. Amazon EC2 provides compute capacity in the cloud. Now this capacity is secure and it is resizable based on the user's requirement. Now look at this. The requirement for the web traffic keeps changing, and behind the scenes in the cloud, EC2 can expand its environment to 3 instances, and during no load, it can shrink its environment to just 1 resource. Elastic Beanstalk, it helps us to scale and deploy web applications, and it's made with a number of programming languages. Elastic Beanstalk is also an easy to use service for deploying and scaling web applications and services deployed be it in Java, .NET, PHP, Node.js, Python, Ruby, Docker, and a lot other familiar services such as Apache, Passenger, and IIS. We can simply upload our code, and Elastic Beanstalk automatically handles the deployment from capacity provisioning to load balancing to autoscaling to application health monitoring. And Amazon Lightsail is a virtual private server which is easy to launch and easy to manage. Amazon Lightsail is the easiest way to get started with AWS for developers who just need a virtual private server. Lightsail includes everything you need to launch your project quickly on a virtual machine, like SSD based storage, a virtual machine, tools for data transfer, DNS management, and a static IP, and that too for a very low and predictable price. AWS Lambda has taken cloud computing services to a whole new level. It allows us to pay only for the compute time, no need for provisioning and managing servers. And AWS Lambda is a compute service that lets us run code without provisioning or managing servers. Lambda executes your code only when needed and scales automatically from few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. Let's look at some storage services that Amazon provides, like Amazon S3, Amazon Glacier, Amazon EBS, and Amazon Elastic File System. Amazon S3 is an object storage that can store and retrieve data from anywhere. Websites, mobile apps, IoT sensors, and so on can easily use Amazon S3 to store and retrieve data. It's an object storage built to store and retrieve any amount of data from anywhere. With its features like flexibility in managing data and the durability it provides and the security that it provides, Amazon Simple Storage Service or S3 is a storage for the internet. And Glacier is a cloud storage service that's used for archiving data and long-term backups. And this Glacier is an secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backups. Amazon EBS, Amazon Elastic Block Store, provides block store volumes for the instances of EC2. And this Elastic Block Store is highly available and a reliable storage volume that can be attached to any running instance that is in the same availability zone. EBS volumes that are attached to the EC2 instances are exposed as storage volumes that persist independently from the lifetime of the instance. And Amazon Elastic File System or EFS provides an elastic file storage which can be used with AWS Cloud Service and resources that are on premises. And Amazon Elastic File System, it's simple, it's scalable, it's an elastic file storage for use with Amazon Cloud Services and for on-premises resources. It's easy to use and offers a simple interface that allows you to create and configure file systems quickly and easily. Amazon File System is built to elastically scale on demand without disturbing the application, growing and shrinking automatically as you add and remove files, so your application have the storage they need and when they need it. Now let's talk about databases. The two major database flavors are Amazon RDS and Amazon Redshift. Amazon RDS, it really eases the process involved in setting up, operating, and scaling a relational database in the cloud. Amazon RDS provides cost-efficient and resizable capacity while automating time-consuming administrative tasks such as hardware provisioning, database setup, patching, and backups. It sort of frees us from managing the hardware and sort of helps us to focus on the application. It's also cost effective and resizable, and it's also optimized for memory, performance, and input and output operations. Not only that, it also automates most of the services like taking backups, monitoring, stuff like that. It automates most of those services. Amazon Redshift. Amazon Redshift is a data warehousing service that enables users to analyze the data using SQL and other business intelligence tools. Amazon Redshift is an fast and fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL and your existing business intelligence tools. It also allows you to run complex analytic queries against petabyte of structured data using sophisticated query optimizations. And most of the results, they generally come back in seconds. Alright, let's quickly talk about some more services that AWS offers. There are a lot more services that AWS provides, but we're going to look at some more services that are widely used. AWS Application Discovery Services help enterprise customers plan migration projects by gathering information about their on-premises data centers. Planning a data center migration can involve thousands of workloads. They are often deeply interdependent. Server utilization data and dependency mapping are important early first step in migration process. And this AWS Application Discovery Service collects and presents configuration, usage, and behavior data from your servers to help you better understand your workloads. Route 53, it's a network and content delivery service. It's an highly available and scalable cloud domain name system or DNS service. And Amazon Route 53 is fully compliant with IPv6 as well. Elastic Load Balancing, it's also a network and content delivery service. Elastic Load Balancing automatically distributes incoming application traffic across multiple targets such as Amazon EC2 instance, containers, and IP addresses. It can handle the varying load of your application traffic in a single availability zone and also across availability zones. AWS Autoscaling, it monitors your application and automatically adjusts the capacity to maintain steady and predictable performance at a lowest possible cost. Using AWS Autoscaling, it's easy to set up application scaling for multiple resources across multiple services in minutes. Autoscaling can be applied to web services and also for DB services. AWS Identity and Access Management, it enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. And moreover, it's a free service. Now let's talk about the future of AWS. Well, let me tell you something. Cloud is here to stay. Here's what in store for AWS in the future. As years pass by, we're going to have a variety of cloud applications born like IoT, artificial intelligence, business intelligence, serverless computing, and so on. Cloud will also expand into other markets like healthcare, banking, space, automated cars, and so on. As I was mentioning some time back, lot or greater focus will be given to artificial intelligence. And eventually, because of the flexibility and advantage that cloud provides, we're going to see a lot of companies moving into the cloud. Alright, let's now talk about how easy it is to deploy an web application in the cloud. So the scenario here is that our users like a product and we need to have a mechanism to receive input from them about their likes and dislikes and give them the appropriate product as per their need. Alright, though the setup and the environment, it sort of looks complicated, we don't have to worry because AWS has tools and technologies which can help us to achieve it. Now we're going to use services like Route 53, services like CloudWatch, EC2, S3, and a lot more, and all these put together are going to give an application that's fully functionable and an application that's going to receive the information like using the services like Route 53, CloudWatch, EC2, and S3. We're going to create an application and that's going to meet our need. So back to our original requirement, all I want is to deploy a web application for a product that keeps our users updated about the happenings and the new comings in the market. And to fulfill this requirement, here is all the services we would need. EC2 here is used for provisioning the computational power needed for this application. And EC2 has a vast variety of family and types that we can pick from for the types of workloads and also for the intents of the workloads. We're also going to use S3 for storage, and S3 provides any additional storage requirement for the resources or any additional storage requirement for the web applications. And we're also going to use CloudWatch for monitoring the environment, and CloudWatch monitors the application and the environment, and it provides trigger for scaling in and scaling out the infrastructure. And we're also going to use Route 53 for DNS, and Route 53 helps us to register the domain name for our web application. And with all the tools and technologies together, all of them put together, we're going to make an application, a perfect application that caters our need. Alright, so I'm going to use Elastic Beanstalk for this project, and the name of the application is going to be, as you see, GSG Signup, and the environment name is GSG Signup Environment 1. Let me also pick a name. Right, let me see if this name is available. Yes, that's available. That's the domain name. So let me pick that, and the application that I have is going to run on Node.js. So let me pick that platform and launch. Now, as you see, Elastic Beanstalk, this is going to launch an instance. It's going to launch the monitoring setup or the monitoring environment. It's going to create a load balancer as well, and it's going to take care of all the security features needed for this application. Alright, look at that. I was able to go to that URL, which is what we gave, and it's now having an default page shown up, meaning all the dependencies for the software is installed and it's just waiting for me to upload the code, or in specific the page required. So let's do that. Let me upload the code. I already have the code saved here. That's my code, and that's going to take some time. Alright, it has done its thing, and now if I go to the same URL, look at that, I'm being thrown an advertisement page. Alright, so if I sign up with my name, email, and stuff like that, it's going to receive the information and it's going to send an email to the owner saying that somebody had subscribed to your service. That's the default feature of this app. Look at that. Email to the owner saying that somebody had subscribed to your app and this is their email address, stuff like that. Not only that, it's also going to create an entry in the database. And DynamoDB is the service that this application uses to store data. There's my DynamoDB. And if I go to tables, right, and go to items, I'm going to see that a user with name Samuel and email address so and so has said okay or has shown interest in the preview of my site or product. So this is where, or this is how I collect those information, right? And some more things about the infrastructure itself is it is running behind an load balancer. Look at that. It had created a load balancer. It had also created an auto-scaling group. Now that's the feature of Elastic Load Balancer that we have chosen. It has created an auto-scaling group. And now let's put this URL. You see this? It's not a fancy URL, right? It's an Amazon given URL, a dynamic URL. So let's put this URL behind our DNS. Let's do that. So go to services, go to Route 53, go to hosted zone, and there we can find the DNS name, right? So that's a DNS name, all right? Alright, let's create an entry and map that URL to our load balancer, right? And create. Now, technically, if I go to this URL, it should take me to that application. Alright, look at that. I went to my custom URL and now that's pointed to my application. Previously, my application was having a random URL and now it's having a custom URL.
Hey all, welcome to yet another video from Simplilearn. Imagine a large hospital where doctors and nurses need to access patient records every day. They look up medical histories, test results, and treatment plans to make sure they give the best care. One day, the hospital's old database system crashes, and suddenly nobody can get the information they need. Doctors can't see patient records during emergencies, and everything comes to a standstill. What can the hospital do to make sure this never happens again? This is where AWS databases come to the rescue. By using AWS powerful and reliable database services, the hospital can make sure the patient data is always available, safely stored, and easy to access. AWS offers a range of database solutions that keep the data secure and backed up, so doctors and nurses can always get the information they need, even in emergencies. So in today's video, we'll explore about the storage services of AWS and the different types of databases available in AWS. We'll explain how each service works, their key features, and the best ways to use them. Whether you are a developer, a database administrator, or just curious about cloud technology, this video has something for you. So, what is AWS? Amazon Web Services, or AWS, is a comprehensive cloud computing platform provided by Amazon, offering a wide array of on-demand services such as compute power, storage, and databases, along with advanced functionalities like machine learning, analytics, and IoT. It helps businesses to scale their applications efficiently. It reduces the IT cost as it has pay-as-you-go model. Its global network of data centers ensures high availability and security. Now, what is a database and why is it important? So databases are systems that store, organize, and manage lots of data efficiently. They have tables to hold the data, queries to find specific information, and indexes to speed up searches. Databases also ensure that all operations are completed correctly and keep data secure. Now there are different types of databases. Relational databases use structured tables and SQL for queries, while NoSQL databases handle unstructured data and are easier to scale. Now, using databases in cloud has many benefits. Cloud databases can easily grow or shrink based on your needs. So you can handle busy times without paying for extra resources you don't need. They are also reliable because cloud providers manage backups and replicate data in different locations, which minimizes downtime and data loss. Additionally, cloud databases reduce costs because you don't have to buy and maintain your own hardware and software. They allow global access, so teams and applications around the world can quickly get the data they need. Now let's discuss the various storage services provided by AWS and identify which AWS databases use each type of storage. So AWS offers a variety of storage services tailored for different use cases. First, we have Amazon S3, or Simple Storage Service, which is an object storage service that is highly scalable, durable, and secure, ideal for backups, big data analytics, and content storage. It's used by databases like Amazon RDS, Amazon DynamoDB, and Amazon Redshift for backups and data storage. Next, we have Amazon EBS, or Elastic Block Store, which provides block storage for EC2 instances, offering different volume types for balancing cost and performance. Now, Amazon EBS is used by Amazon RDS and Amazon Aurora for database storage. Now, next we have Amazon EFS, which is Elastic File System. Now, it offers scalable file storage that can be concurrently accessed by multiple EC2 instances, suitable for applications needing shared access like web serving and content management. Next on the list is Amazon FSx, which provides fully managed file systems optimized for specific workloads, such as FSx for Windows File Server and FSx for Lustre, the latter being ideal for high-performance tasks like machine learning and big data processing. Now, for archival storage, Amazon S3 Glacier offers low-cost storage for infrequently accessed data, perfect for compliance and archival needs. Now, finally, we have the AWS Snow family, including Snowcone, Snowball, and Snowmobile, which facilitates secure and efficient data transfer into and out of AWS, supporting the initial data loading for various databases. So having known the services offered by AWS, now let's move on to the different databases in AWS and discuss each of them with their use cases. So first we have Amazon DynamoDB. Now, Amazon DynamoDB is a fully managed NoSQL database service offered by AWS. It is designed to handle large amounts of data with high speed and low latency, making it perfect for applications that need to store and retrieve data quickly. Some of its features are scalability. DynamoDB can automatically scale up or down based on the application's demand, ensuring consistent performance. It provides single-digit millisecond response times, which is ideal for real-time applications. AWS handles all the maintenance tasks like backups, patches, and hardware provisioning, so you don't have to worry about them. So let's see a use case. Imagine you are running a mobile game with thousands of players online simultaneously. Each player's game progress, scores, and in-game purchases need to be stored and retrieved quickly to ensure a smooth gaming experience. Now, DynamoDB can efficiently handle this type of workload by providing quick access to player data even when there are sudden spikes in game activity. This ensures players have a seamless and enjoyable experience without delays or lag. Now, next we have Amazon Aurora. Amazon Aurora is a high-performance, fully managed relational database service offered by AWS. It's designed to be compatible with MySQL and PostgreSQL, which are popular database systems, scaling, so you don't have to worry about them. Let's see its use case. Imagine you have an online store that handles thousands of transactions every day. You need a database that can quickly process orders, manage inventory, and store customer information without any slowdowns. Amazon Aurora is perfect for this because it can handle lots of read and write operations very efficiently, ensuring a smooth shopping experience for your customers. Plus, Aurora can automatically scale up to meet high demand during sales or holidays and scale down when traffic is lower, helping you save costs. Its high availability and automatic backup features mean your data is always safe and accessible, even in case of hardware failures. This makes Aurora an excellent choice for running a reliable and responsive e-commerce website. Next on the list, we have Amazon RDS. Now, Amazon RDS or Amazon Relational Database Service is a cloud-based service that makes it easy to set up, operate, and scale a relational database. This means you can store and manage your data in a structured way using popular database engines like MySQL, PostgreSQL, Oracle, SQL Server, and MariaDB without worrying about the underlying infrastructure. Now, imagine you run an online store. You need a database to keep track of your products, customers, orders, and inventory. Using Amazon RDS, you can quickly create a database that handles all these tasks. RDS automatically takes care of backups, software updates, and scaling, so you don't have to worry about your database crashing during a big sale or needing more space as your business grows. Now next, we have Amazon TimeStream. Now, Amazon TimeStream is a cloud-based time series database service offered by AWS, designed to efficiently store and analyze timestamp data. Now, timestamp data is information collected at regular intervals, like temperature readings every minute or stock prices every second. So the key features include performance. It handles trillions of events per day with fast query capabilities. Now, it automatically scales up or down based on the volume of data. Now, you only pay for storage and queries you use, with automated data lifecycle management to reduce costs. Now, imagine you have a network of thousands of IoT sensors deployed across a city to monitor air quality. Each sensor collects data like temperature, humidity, and pollution levels every few seconds. Now, Amazon TimeStream can efficiently store this vast amount of timestamp data and provide quick access for real-time monitoring and historical analysis. This helps in analyzing trends, predict pollution levels, and make data-driven decisions to improve air quality. Next on the list, we have Amazon Neptune. Now, Amazon Neptune is a fully managed graph database service provided by AWS. It's designed to work with highly connected data, making it ideal for applications where relationships between data points are as important as the data itself. Its key features include graph models. It supports popular graph models like Property Graph and RDF, which is Resource Description Framework, optimized for querying large amounts of interconnected data quickly. It handles database management tasks like backups, patching, and scaling automatically. Now, one common use case for Amazon Neptune is building social networking applications. So in a social network, users are connected to each other in various ways: friends, followers, likes, comments, and groups. Now, Neptune can efficiently manage these connections and quickly answer complex queries like who are the mutual friends of two users or what groups are my friends part of. So by using Neptune, social media platforms can provide a fast, responsive user experience even as the number of users and connections grow. So next we have Amazon QLDB. Now, it stands for Amazon Quantum Ledger Database, which is a fully managed ledger database provided by AWS. It is designed to maintain a complete and unchangeable history of all changes made to your data over time. Think of it like a highly secure and transparent digital logbook where every entry is recorded and can't be altered. So the key features are immutable ledger. Once data is entered, it cannot be changed or deleted. It ensures the integrity of your data by allowing you to verify that it hasn't been tampered with. Now, AWS handles all the maintenance, including scalability, backups, and availability. So one common use case for QLDB is in tracking financial transactions. So imagine a bank needs to maintain an accurate and tamper-proof record of all the transactions to ensure transparency and compliance with regulations. So QLDB can provide a trustworthy and unchangeable log of every transaction, making it easy to audit and verify the history of financial activities. Now, the last on the list is Amazon RDS on VMware. So it is a service that allows you to run Amazon's Managed Relational Database Service or RDS in your own data centers using VMware. Now, VMware is a virtualization and cloud computing software provider. So this means you can enjoy the benefits of RDS like automated backups, patching, and scaling without moving your data to the AWS cloud. So it's perfect for businesses that want to keep their data on premises due to regulatory requirements, low latency needs, or existing investments in VMware infrastructure. For example, imagine a hospital that needs to store and manage large amounts of sensitive patient data. So due to strict privacy regulations, this data must remain on-site itself. With Amazon RDS or VMware, the hospital can set up and manage databases easily within their own data centers. They get the reliability and automation of AWS RDS while keeping patient information secure and compliant with local laws. So this setup ensures the hospital's data is always backed up, secure, and accessible without the complexity of managing database servers manually. Hey tech enthusiasts, welcome to yet another informative video from Simplilearn. Imagine you're managing an online store. You need to handle day-to-day transactions, analyze sales trends over the past year, and store massive amounts of raw customer feedback from social media. How do you manage all this data efficiently? This is where databases, data warehouses, and data lakes come into play. I'm pretty sure most of you are well aware of what a database is. A database is a system that stores and organizes data in a structured way, using rows and columns, making it easy to access, manage, and update information. Now, if data can be stored and managed in databases, then what is a data warehouse and a data lake? And why do we need them? So in this video, I will give you a clear understanding of what a database, data warehouse, and data lake is with examples. How are they different from each other and what factors to consider before choosing amongst the three? So let's jump in. So what is a database? A database is essentially a structured collection of data or information that is stored electronically. It serves as a centralized repository where data is organized in a systematic way, often using tables, rows, and columns. So the primary function of a database is to support online transaction processing or OLTP, which means it handles the real-time transactions and operations of businesses or applications. So behind the scenes, a database management system or DBMS manages the database, ensuring data is stored securely and efficiently. So the DBMS also allows users and applications to interact with the data through queries, updates, and modifications. So in common usage, the term database can refer both to the actual data repository and the software system or DBMS that manages it, providing a seamless interface between users and their stored information. Now, there are two types of databases. Relational databases store data in structured tables with fixed rows and columns. This structured approach makes them ideal for applications requiring strong data consistency and complex querying capabilities. On the other hand, non-relational databases, often referred to as NoSQL databases, offer more flexibility by accommodating various data models. So these include JSON for semi-structured data, BSON, key value pairs for simple data retrieval, tables with dynamic columns for evolving schemas, and graph databases using nodes and edges for connected data relationships. So some of the examples of databases are Oracle, MySQL, and PostgreSQL, and also MongoDB. Now, what is a data warehouse? So a data warehouse functions as a specialized database designed to store structured information gathered from multiple sources, so encompassing both current and historical data. So unlike traditional databases primarily focused on transaction processing, data warehouses are tailored for analytical purposes. So they consolidate data from different systems to facilitate comprehensive analysis, uncover insights, and generate business intelligence through reports and dashboards. So in essence, while a data warehouse is indeed a type of database, it distinguishes itself by its optimized architecture for handling complex queries and facilitating data analytics essential for strategic decision-making in organizations. So a data warehouse serves as a centralized repository designed to store large volumes of both current and historical data gathered from diverse sources. This data ranges from raw, initially ingested information to highly refined, cleansed, filtered, and aggregated data sets. The process of moving data into a data warehouse is managed through extract, transform, load or ETL process, which extract data from its original sources, transform it to fit the warehouse schema, and load it into the warehouse on a regular basis, such as hourly or daily schedules. So this periodic loading means that the data warehouse may not always reflect the most current state of the original systems. So once the data is successfully loaded into the warehouse, business analysts and data scientists can utilize business intelligence tools to connect to the data warehouse. So these tools enable them to explore the data, uncover valuable insights, and generate reports that aid business stakeholders in making informed decisions based on comprehensive data analysis. So examples of data warehouse is Amazon Redshift, Google BigQuery, and IBM DB2 warehouse. Now, what is a data lake? So a data lake serves as a centralized storage repository for data collected from various sources, preserving it in its original or raw format. So unlike data warehouses that also handle extensive volumes of both current and historical data, data lakes distinguish themselves by their versatility in storing diverse data formats such as JSON, BSON, CSV, etc. So the core objective of a data lake typically revolves around analyzing this data to extract valuable insights. So however, some organizations use data lakes mainly because they offer affordable storage options, storing data in anticipation of future analysis. So data lakes are versatile storage systems that can handle large amounts of structured, semi-structured, and unstructured data. So unlike traditional databases or data warehouses, data lakes don't need data to be organized before storing it, allowing quick accumulation of diverse data types like spreadsheets, JSON files, PDFs, and multimedia. So different users access data differently. Structured data is often used directly by business analysts for insights, while unstructured data requires expertise from developers, data scientists, or data engineers. This set of flexibility lets analysts and scientists discover unexpected patterns and insights, using the data's variety and volume to solve problems that weren't anticipated initially. So data and data lakes can be processed with online analytical processing or OLAP systems and visualized using business intelligence tools, improving data exploration and decision-making capabilities. Some of the examples of data lake are AWS S3, Azure Data Lake Storage Gen 2, Google Cloud Storage, etc. So now let's recap the differences among the three of them. So if your application needs to store data, which is essential for most interactive apps, having a database is crucial. So databases are fundamental for applications in various industries and scenarios. They provide an organized way to store, retrieve, and manage data effectively. For instance, an online store uses a database to handle product stocks and customer orders. Similarly, a healthcare system relies on databases to manage patient information and medical histories. Even social media apps use databases to store user profiles and posts. So without databases, it would be difficult to manage and access data reliably, impacting the functionality and usability of interactive applications. Now, data warehouses are essential when organizations need to store large amounts of historical data and analyze it deeply to gain business insights. Their organized structure makes data analysis straightforward, accessible to business analysts, and beneficial for data scientists. So unlike transactional databases used daily for operations, data warehouses specialize in handling complex queries and generating detailed reports. So this capability supports strategic decision-making based on past trends and patterns. It's important to know that while data warehouses excel in analytics, they aren't suitable for real-time transaction processing or handling multiple users at once. So organizations typically maintain separate databases for day-to-day operations and use the data warehouse specifically for strategic analytics and business intelligence. Now, data lakes are a budget-friendly way to store large amounts of data in its original form. So unlike regular databases or data warehouses that need data to be organized beforehand, data lakes allow storing various data types like structured, semi-structured, and unstructured without immediate restructuring. So this keeps data raw, letting business fully explore and analyze both current and past information, uncovering insights that may not be obvious initially. So data lakes are great for advanced analytics such as machine learning and predicting trends, offering flexibility for experimenting with data. However, they aren't suitable for handling day-to-day transactions or meeting the fast data access needs of operational tasks, which traditional databases and data warehouses specialize in. So I hope now you all know how the three of them differ. Now, having known that, there are some factors to be considered before deciding on which platform to use. So let's look into those. Considerations like the variety and volume of data sources, the way data arrives, and how predictable its structure is are crucial. So data lakes are versatile, handling unstructured data in various formats. On the other hand, data warehouses specialize in structured data from multiple sources. Now, databases perform well with structured data from one source, but may struggle with scalability. Now, the choice between these platforms depends on these factors, shaping their roles in data management and analytics. Now, in a solid data management strategy, choosing when and how to use data models is crucial. Data lakes offer flexibility by storing raw data alongside metadata, allowing schemas to be applied later during data extraction for analysis. On the other hand, databases and data warehouses use ETL, extract, transform, load processes. Here, raw data is transformed into a predefined structure upon ingestion, called schema on write. This difference shows how data lakes enable agility in exploring data and adjusting schemas as needed, contrasting with databases and data warehouses that prioritize upfront data organization and consistency through fixed schemas. Now, big data is highly valuable for businesses, evident in their investments in data management. As data grows in volume and speed, storage expenses increase. Data lakes are cost-effective because they store data as is, reducing storage needs compared to data warehouses that require extensive processing before analysis. Databases can scale storage capacity to match demand. Now, the choice between a data warehouse, data lake, or relational database depends on users' role, whether they are a business analyst, data scientist, or a part of operations, and their specific organizational needs. So operations teams focused on business insights often prefer data warehouses for structured data analytics, despite higher setup and storage costs. Data scientists prefer data lakes for their flexibility with structured and unstructured data, which supports advanced AI and machine learning. Business analysts skilled in SQL may find relational databases adequate for generating specific trend reports on business segments. So each option serves different needs based on data complexity, analytics requirements, and cost considerations. Now, organizations have different preferences between open source and proprietary software, along with the communities backing them. So data lakes are popular because many use platforms like Hadoop, and there's a growing amount of unstructured data from various company systems and real-time data streams. Another important point is how easy and affordable it is to update systems and when data sources and structures change. Unlike relational databases and data warehouses, which can be expensive to update, data lakes make it simple to adjust, making them flexible for changing data needs.
As cloud adoption continues to increase, with IDC predicting that global cloud spending will reach 1.3 trillion by 2025, there's never been a better time to certify your skills. This AWS Cloud Practitioner certification is for anyone who wants to understand Amazon Web Services cloud better, no matter their technical background. Plus, AWS certified professionals earn an average of $183,000 per year, highlighting the significant financial benefits of becoming certified. So what are you waiting for? In this video, we will cover everything about AWS Cloud Practitioner certification, career goals and objectives, market demands, cost investment, and advantages of the certification. Alright, so let's understand about AWS Cloud Practitioner certification. Alright, so now let's talk about AWS Certified Cloud Practitioner exam. So the AWS Certified Cloud Practitioner exam is an entry-level certification designed for individuals who are new to cloud computing and want to build a foundational understanding of AWS services. This certification is particularly beneficial for those without an IT background, making it accessible to a wide range of people looking to start a career in the cloud. This certification is ideal for business professionals, including sales, product management, and project management roles. It helps them gain a basic understanding of cloud concepts, which enhances their ability to communicate effectively with the technical teams and customers. By understanding the core AWS services, pricing, and support models, these individuals can make decisions and contribute more to their organizations. One of the advantages of AWS Certified Cloud Practitioner exam is the flexibility it offers in testing options. Like candidates can choose to take the exam in person at VIEW or like testing centers or online with a proctor, making it convenient to fit for various schedules. Alright, now talking about the key details of the exam. So first, that is a level of the exam is foundational, Then talking about the duration, the exam lasts 90 minutes, giving candidates ample time to answer all the questions thoroughly. The format of exam. So it consists of 65 questions which can either be multiple choice or multiple response. This format is designed to test your understanding of AWS services and cloud concepts in a comprehensive manner. Talking about the cost. The exam cost is $100. It's worth noting that additional cost may apply depending on your location and the prevailing exchange rates. Then testing options. So as we already discussed, you can take the exam in person at a person view testing center or online through a proctored exam, offering flexibility to fit your schedule and preferences. So this was about the AWS Practitioner Certification. Now let's have a look at one of its important factors, which is career goals and objectives. So the AWS Certified Cloud Practitioner Certification helps you start with a career in cloud computing by giving you a foundation knowledge of AWS services. So this certification is great for entry-level jobs as it shows employers you understand basic cloud concepts. However, the certification alone isn't enough to secure a job. To maximize your chances, it's important to create cloud projects alongside your studies. Working on cloud projects helps you apply that you have learned and gives you practical experience, making you more attractive to employers. It's also beneficial to stay updated in the new AWS services and continue learning. Building a portfolio of projects can show potential employers that you have hands-on experience, which is highly valued in the job market. Also, for individuals in sales, product management, project management, or other technical roles, the AWS Cloud Practitioner Certification can help them better understand how cloud computing works and how AWS services can be used to benefit their business. This can improve communication and collaboration with the technical teams and customers. Now let's move on and have a look at salary and companies hiring for AWS professionals. So the average salary of an AWS professional in the United States is $133,000 per year. This high-paying job role is in demand across many companies. Notable employers looking for AWS professionals include TCS, Accenture, Mindtree, IBM, Capgemini, and Deloitte, and many more like that. These companies value AWS skills due to the growing need for cloud computing expertise. AWS professionals help business leverage cloud technology for better scalability, efficiency, and the cost-saving purposes. With such a increasing or lucrative salary and demand from leading companies, pursuing a career in AWS professional can be a smart and rewarding choice for you. Alright, now let's talk about the market demands. So don't worry about new AI technologies stealing your future about cloud job. You don't have to worry. The demand for AWS skills in the job market is growing rapidly, with many companies transitioning to cloud computing. The cloud computing market is experiencing explosive growth according to Gartner in 2024. Worldwide end user spending on public cloud services is forecast to total $679 billion. Businesses of all sizes are migrating to the cloud to benefit from its scalability, cost efficiency, and agility. This rapidly adoption has created a significant skill gap. A recent report by Global Knowledge estimates a shortage of over 3 million cloud computing professionals globally. By acquiring AWS skills, you are not just securing a job in today's market, but you are positioning yourself for a successful career in the ever-growing field of cloud computing. Coming to the next one, which is cost investment. So the AWS Certified Cloud Practitioner exam costs $100. This is a straightforward fee for registration and taking the exam. Additionally, while the AWS offer free digital training courses, you might also consider investing in supplementary study materials such as books, online courses, and practice exams. Now, let's discuss the advantages of Cloud Practitioner Certification. One of the coolest perks of getting the AWS Practitioner Certification is the digital badge you receive. It's like a digital trophy that you can proudly display on your social media profiles and email signatures. This badge not only shows off your achievement, but also grants you immediate access to exclusive AWS-sponsored certification events, which can be a great way to network and learn more. Another fantastic benefit of this exam: once you're certified, you get a 50% discount voucher that you can use for recertification or even for taking another AWS certification exam. This means you can keep your skills up to date without breaking the bank. Yes. Alright, the next is, when it comes to recognition, AWS really goes the extra mile. As a certified professional, you will get the invites to special regional appreciation receptions. Plus, when you attend a major events like AWS reInvent or select AWS Summit events, you can use your digital badge to gain exclusive access to the AWS certification launches. These launches are perfect for networking, relaxing, and meeting other AWS professionals. Lastly, you'll also become a part of AWS Certified Global Community. This community, accessible via Intuitive, allows you to connect with other AWS certified individuals from around the world. It is an excellent platform for networking, sharing knowledge, and staying in the loop with latest in AWS. So this AWS Cloud Practitioner certification opens doors to the world of opportunity in the booming cloud computing market. With its industry recognition and focus on foundation knowledge, this certification is a valuable investment for both aspiring IT professionals and business-minded individuals.
AWS Solutions Architect Associate. So AWS has multiple certifications and multiple training courses. Out of that, solution architect is one of the roles in cloud projects, right? Who actually is responsible for designing the architecture for IT workload and then deploying application, and all he takes help of developers, DevOps engineers, or for security part, security specialists, network part, network specialists. So there's a team working on. One of the member of the team is solution architect, and he is responsible for designing and implementing the complete cloud architecture on any one of the cloud vendors such as AWS. In solution architect, there are two types of certification or two levels are there. One is associate and the other is professional. So professional is the later stage, which is an expert stage into solution architect role. However, associate is an entry stage into solution architect level. And once you become solution architect associate, you would be called as cloud engineer in your company, right? So there are many roles you can see in the job description. So cloud engineer is the common designation we have. And in the companies, when we become solution architect, there are majorly two types of role that these cloud engineers do. One is called as pre-sales cloud engineers, pre-sales cloud or pre-sales solution architect, whatever terminology they are using. But pre-sales is something that they do. And the second is just a cloud engineer, right? So out of these two roles, what role you will be working on depends on many factors. The first thing, you must have good knowledge of AWS. And after good knowledge, if you can do global certification of solution architect associate, which is 3 years valid certification offered by AWS itself. And after your knowledge, if you go for certification, which is optional because not every company demands certification. But if a company demands or if a job description demands, then doing certification is completely subjective. Whether the demand of the job is experience plus certification or only knowledge plus experience, something like that. So if you have good knowledge of cloud, and in fact for certification also good knowledge is required. So everything is depend on what kind of knowledge you have plus a little hands-on. Hands-on in the sense you're not working on the actual project of the industry. You're learning it first time. So whatever practices we can do on different services, that is hands-on I'm talking about, or some mini projects that we'll be doing, final project that we'll be doing. So this is all the combination of all three. And this, if you have, then you either get a pre-sales job or cloud engineer job. That is what the outcome of this particular learning is, right? So why I'm learning AWS Associate Solution Architect course. So the reason is either I want to become a pre-sales engineer or I want to become a cloud engineer, or there can be third possibility that people are already working on cloud, but they just want more experience into it. Okay, so let us start. I'm going to sign in into my account or on my login, basically, not my account. So I'll open a new tab and then I will be entering username and password there. So are you able to see the console home? That's all. This is your lab, nothing else. If you don't see access denied or access denied, so this is the account given by Simplilearn. So this is the AWS account. If you go to the right hand side, you can see account ID. My account ID is ending with 9199. And then I can see that I am an IAM user. and my username is ODL user 1394774. You'll be also able to see the same kind of thing. However, the username will be different. Now, how to use the account? What are the part? It is the next topic. This is not current topic. Okay. I wanted to just show you that. Let us understand cloud computing. Okay. So cloud computing is a business that almost started in 2005 plus, in that era in the world, 2006 onwards probably. And in India, it started way back in 2011 and 12. Predominantly from 12, 13, it has started in India also. And what is that cloud computing business, right? So earlier, IT companies, the job of IT companies was to help, the customers. This is the customer. And he says that I want a very nice IT availability of my business. I do one business. So he's a client, right? And he says that, sir, I want a very good website and I want it to be launched. I want to do business online. So I want my end customer to visit it. So he approaches IT company, and the IT company, what they would be doing? They would be doing two things. Number one, they would be creating a very nice website for him, and then they will be launching the website on server. So all the online website or application on mobile phone, whatever we use, there's a server on which this application is running. Am I correct? So IT companies do the same thing for their customers, right? Now, making a website is all called as development, or very specifically is called software development, or sometimes people call it as application development. Many words are written, but making an application is application development. Simple. This is done by software developers. So companies have software developers who can make that application. Now, what is in by launching? Launching means running that website on a server. Now, what is meant by server? Server means a hardware machine, or we can say a hardware computer or hardware computing machine on which your website will be running. So we generally call, for example, there is a Google server on which Google is running. There is a Microsoft server on which Microsoft website is running. There is a server on which Simplilearn website is running. For example, this LMS portal, which you see on my screen, is also like, one of the web applications or applications, you can say, for that matter. And this application, now we are going to visit it by typing one URL, and there is one server on which this application is running. So IT companies need to have that server on which their client's website would be running. This is the simple thing that every IT company used to do. Am I correct, Tim? Okay. So this is a rough idea, generalized idea that everybody has, even you are IT person or non-IT person. But if you go deep dive, if you understand software architecture, it is not just the website which is running on server. It is not the only application which is running on one server and that is all about. No. Software architecture has multiple components. There can be database, there can be storage, there can be, let's say, messaging queues, there can be notifications, there can be monitoring tools. So if you see the software architecture, it has consist of a lot of things, right? So not only website, which is called front end, companies also have databases, which is acting as a backend most of the times. And then website to database transaction happens. They also have storage where they can store the files and everything. So if I keep adding the things, then there will be a lot of things, as a part of software architecture. So for one client, company has to maintain this particular architecture. And for that, they require infrastructure. What is infrastructure all about? Infrastructure means the resources on which your applications are running. You always understand, see, IT is very simple. It consists of two things. One is software, one is hardware. These are the two important terms. And then you can categorize it further. You can do subcategory. In software, there are these type of software, that type of software. In hardware, again, you have servers, then you have network, you have other things, that and that. Ultimately, what happens? You require hardware servers to run your softwares. Is that clear? This is the fundamental thing, right? So making software is easy, that you have developer, they can make softwares for you. But hardware is a thing which you need to establish. And companies used to have such a setup of hardwares so that applications can be running. That setup is called as data center. So suppose a client comes to an IT company. So they have a team of developers who can develop the software. They can develop the software, that is website. But for these hardware servers, companies need to maintain the data centers. In the data centers, there will be a lot of hardware setup. I'll show you something on my screen. And I'll be using Google. It is a general information that everybody can have. So I'll be going on Google and would try to show you an image of data center. How does it looks like? So you can see any image on my screen. These are the places, like there is a building or a warehouse, is a big space. And in that spaces, what I'm seeing? I am seeing there are vertical racks. Do you see the rack? We have a rack at our house also, right? We have racks where we can put clothes or use it for multiple purpose, right? You can put any stuff, any material or books, anything. These racks are there, and in the racks there are some hardware servers are set up. You can see these images and they're all connected through cables. You can see this guy, right? On the left hand side, you can see these images. In this rack, see this person. I'm not interested into the website of that, but I'm interested into this image. So he is trying to connect with the hardware, right? And these racks are consisting of different types of servers, right? Those servers are used for multiple purposes. And also they are all connected through network. Network is required because this is all something, which has to be connected with internet, right? So you can see in this image, these are all connected to each other on a particular network. So there can be a local area network, LAN, WAN, MAN, and then these are all connected to internet also. So that is a very fundamental concept. Those who never knew that, these images can help you to understand how data center looks like. So if I'm an IT company and my clients are asking me to create website and launch them on, or create IT infrastructure and launch it on hardware, then I have to be ready with the team of developers. Also that I should have data centers. So if I keep watching on data center part, this is something which requires huge capital investment, because it requires you to have a space, it requires you to purchase hardwares, it requires you to give air conditioning, it requires you to give 24/7 internet. And I believe this is something which requires a very big upfront investment, which is called capital expenditure. Am I right? It is very similar to purchasing a car. Suppose if I purchase a car, I have to invest a lot. Similarly, a company has to maintain a data center. For that purpose, they have to invest a lot and huge amount of money into it. And that is what IT companies used to do. Even after doing that, they had to hire new people. The new people who can maintain those data center, who can look after the data centers activities, right? They can solve their problems. They can look after monitoring, everything, whatever it requires. In fact, security also. We need to secure those data center. So again, surveillance is required. Security people are required. We want technical engineers who can solve the problems which are happening. And in case if any kind of damage happens, again, the company has to purchase a new one, solve the existing one. Or if you require more hardware, then again, you have to invest once more. So what do you think the IT companies' attention or the whole investment is now divided into two things. One is developing the software and the other is developing the data center also. Am I correct? So it became very difficult for companies, to sustain with those data center. And then there, the business of giving the hardware part or giving the hardware part for sharing purpose is something that many companies started doing it. Slowly, companies started giving their own infrastructure to other companies on rent so that they can host their application on it. And now in the market globally, there was a need for that. Companies like Amazon, Microsoft, Google, they all came forward. As far as the information that I have, Amazon started working in the era of 2000. In the year of 2006, they officially launched their cloud business. And what they did, they found out this business loophole in the market and they started providing cloud computing services. What is that part? That part is that now Amazon says that IT companies do not have to maintain data center for them. It is not required. They need to look after their app development. That much is enough. Whatever client application is that they can develop it. What Amazon is doing with their business called as Amazon Web Services, they are started providing these data centers which are maintained by them, and on top of data center they are providing services. Two things, right? So if I am an IT company or if I'm a client directly, so AWS says that we have data centers, we have hardware setups, and to use that to launch your website or application on it, we provide services. We provide 300 plus services. You can use services for different purpose. And then those services, those applications will be running on Amazon's data center. So if I'm an IT company, I'll be creating one account of AWS. In that account, I'll be using the services. And now this is very important to see. As a client, what I'll be doing, I'll be creating one free account in AWS. In that account, I'll be using these services as per my requirement of the project. And Amazon is maintaining data center for it. You can see the black color things. These are all given by Amazon. What I am doing in the red color is I'm using those services. And those services are run by data centers, which are managed by AWS. These data centers are managed by AWS. And in return, what AWS is doing, AWS is charging me. They are obviously, nothing is free, right? It's a business. So I have to pay the bills. For every account, there is a bill generated in the end of the month. So in return, AWS is charging me certain amount, but that amount is comparatively very lesser because that model is called as pay as go. Pay as go. What is pay as go? Pay as go means it's very similar to renting part. Do you use Uber all over the world? Everybody sitting here, maybe from different countries. Do you know Uber cab sharing service? Everybody knows Uber model, right? Don't you think cloud computing and Uber is the same thing? We are not purchasing a car that is being purchased by a company. We are not investing into it that is being already done by companies. Companies are maintaining car, they are paying for driver, they are paying everything, petrol or diesel or gasoline, whatever, they are maintaining it, they're looking after maintenance, tire, everything. Also, whatever happens is all the companies responsible. As a customer, I just go book a cab, they drop me at one location and I'm paying the fare. I'm paying the rent for using that car for a particular amount. If I say that, no, I want to travel more distance, then I will be giving more fare. Once my requirement is over, I can simply, as per my requirement, I'll book the cab. My requirement is not required. I'll take out of the cab. I'm not paying any more. What is this? Am I like booking the cab on demand? I need a cab. Immediately I go to the app. I book it. Cab comes to at my doorstep. It drops me somewhere. The job is over. Similarly, IT companies can use AWS so that they can create whatever resources they want using the AWS services on demand. And that everything is online. Don't you think? What I'm doing here, look at me. Imagine I am an IT company. I have got access to an account. Suppose this account is created by me. I have one AWS account. I can immediately go, right, and start creating resources. Only the thing that I have to do is that I have to develop the website, nice website. So if I have a website, I can go to a particular service. For example, I go to EC2. I launch my website and my business is online. At the end of this month, they will be giving bills. Right now, I cannot see the bill here. This is not my account. But if I go to billing and cost management, I'll be able to see the bills of every month. And if I know the bills of every month, I will be paying for that. And let's say after 1 year, after 2 years, after some days, after some hours, I don't require some resources, I can immediately delete it. So I have a full control on how I can launch the resources and I can delete the resources. And accordingly, my business will be online. I don't need to maintain data center. I don't need to do anything at all. There is something which is already provided by AWS, and that is called cloud computing. The proper definition of cloud computing is on-demand delivery of IT resources online. Simple. On-demand delivery of IT resources online. So slowly, with the class progresses, when we will go for one by one on different services, we will be able to understand what are the IT resources are required for a project. I took some names such as we require web server, we require database server, we require storage devices, we require notification service, we require messaging, we require some compute part, we require containers, we require some functions, we require access management. There are so many things that will be required. So I must tell you that for Solution Architect Associate, there are some services that you must learn. And this course is developed accordingly for you. So as I told you, the definition, on-demand delivery of IT resources online. So we will be, day by day, we will be creating resources with the help of services. And slowly, day by day, you will be understanding each and every service. Like, for example, tomorrow you'll be learning some service. Day after tomorrow, you'll be learning some different service. So day by day, you will be understanding each and every block of your project. And finally, once you try to reach, right? Once you try to reach the end of the course, you will have good idea how this complete IT infrastructure works, how this software architecture works, how cloud helps you to do that. But right now, for time being, I wanted to convey the message that this is a third-party service that clients are using. AWS is a third-party cloud provider which companies are using, and AWS has a big list of customers. I can show you some existing customers of AWS, and everything is available on internet. That is why I don't want to lie, anything as such in front of you, because whatever I'll be showing you is all on official website of AWS. So this is an official website, aws.amazon.com. There's a customers list, and for different services, we show different customer case studies. So there is a service related to containerization, and these are some customers which are doing it. However, if I want to see, all customers for all services. Okay, so I'm using some third-party website to show you the list of AWS customers until 2020. And mostly, the OTT platforms and different companies, I can show you Aon, Adobe, Airbnb, Alcatel, AOL, and this is very old list, okay? It's 2024 right now, and this is a page that I got for 2020, which is, I think, not actually good to show you. But 2023 is something that is good. And yeah, so customers list, you can see these are the companies and industries and the region where they are using AWS. So it's a big list. Some of the famous, such as, Amazon.com itself. Do you use Amazon.com for shopping? Hello? Yeah, so Amazon.com is the business of Amazon, and AWS is also another business of Amazon. AWS started in 2006, and they successfully migrated Amazon.com on 2010, if I'm not wrong. So 2010, Amazon.com was completely shifted to AWS. And also some of the OTT platform, you guys are cricket lover, I believe. So you must be using Hotstar. You must have seen the World Cup match a day ago, right? India won the final, and you were watching Hotstar. I remember 5 CR was the maximum count of viewers on Hotstar, right? If I'm not wrong. Perfect. This whole Hotstar is running on AWS. Netflix, Amazon Prime. Yep. So I still remember I was watching the match 5 CR, and I was very impressed that, yeah, so AWS is backing up the whole thing on Hotstar, and everything was basically online, and Hotstar doesn't require their own infrastructure. So it's a good business, right? And in the market, AWS is a leader in this business, followed by Microsoft, number 2, and then Google, and then Alibaba, IBM. These are all like the market leaders in the cloud computing business. However, it's not necessary that every company goes to AWS only or Microsoft only, or they go for third-party cloud. So basically, companies have 3 kind of scenarios, which are called cloud models. I'm actually teaching you the topics, okay, guys? So this is not just basic information. I'm actually teaching you AWS, right? So there are 3 types of cloud models that are existing. The first type is called as private cloud. Then the second type, which is called public cloud. You have to note down if you want, or you can take a screenshot of my drawings, okay? If you like my diagram, you can take a screenshot. And then the third type is called hybrid cloud. So these are 3 types of cloud models, and companies fall into any one of these models. So first of all, let us understand private cloud. Suppose an IT company is having their workload on their own data center. So if company is maintaining their own data center, right? Company, if it is maintaining own data center and 100% workload is on their own data center, they are also using virtualization, they are also launching everything on their own data center, then that company falls into private cloud. So this is like they are maintaining their own data center, they have the whole setup, they are launching everything on their data centers only. The second category is there are some companies who have 100% workload on AWS. So AWS or Microsoft or Google, whatever you are using the product of, for this training, I'm using AWS. So if a company has complete IT infrastructure on AWS, everything is in their AWS account only. They are not maintaining their data center. It is AWS data center where 100% workload is running. Then it is called as public cloud. And the third category of the companies where, because of governance and compliance issue, they cannot move 100% workload on AWS. So what they do, as per their governance and compliance issues, if certain X amount of workload on own data center and certain percent of workload on AWS. So they are having mix up of the load. So there are certain things. For example, if I give you example, let's say I give you example of banking industries. Do you know the banks are also running on cloud? Are you aware of this? Let's take any leading bank in the world, so they are running their infrastructure on cloud also. But not every bank is on public cloud. Most of the banks are on hybrid cloud. What is meant by hybrid cloud? It means that their part infrastructure is on their own data centers, probably their virtual machines, right? If a company is having their own data center, will they put it in AWS premise or their own premise? It's very obvious that this is their own property. They will be putting it in their own premise. Am I right, Pratik? If you talk about private cloud, yes. Public cloud means it is some third-party company's data center. So if I'm using my own car, I'll be parking in my own parking. But if it is Ola, Uber car, then they will be parking in their own parking. It's not my parking in that sense. So hybrid cloud is like banking, for example. I take one example of banking industries. Banks have certain resources on own data center, such as, let's say, their virtual machines are on their own data center. Probably they are using storage of cloud. So they are having percentage of workload on their own and percentage of workload on cloud. And this kind of model is a requirement for some companies because of governance and compliance issues. Governance and compliance, if you don't understand what is this is mean that for any companies, it is bounded by certain protocols and rules. You take any example of any company. So they are bounded by certain rules and regulation. These are called governance and compliances. Governance means maybe that particular nation where that business is running on, that nation is having certain rules which the company has to follow. In fact, the state where that company is there, it has to follow the state rule also. Also, the company itself has their own protocol and policies, which that company has to follow. For example, I take banking example, and the bank has to maintain data encryption. This is very obvious, right? The data must be encrypted. So data encryption is not that nation's, regulation, or it is not the state regulation. It is the company's policy. And as per the company's policy, their employees and their project, everything has to be as per their policies. So the governance word, when I say governance, that is not only connected to country or not only related to state, but it is also related to the company's own policies. That is one thing. Compliance means there are organizations or bodies who look after particular sector. For example, I give you some example. In US, for healthcare industry, there is one compliance called as HIPAA. Or in Europe, there is called as PCDSA, Payment Card Data Encryption Standard, PCDES, something like that. So these are the worldwide global compliances that if you fall into an industry, you have to follow that. Suppose my company is doing a business of banking. It is a financial company, and that is having credit card or debit card for their customers. So if I fall into that industry, I have to be compliant with the rules given by that particular group or particular compliances. So for that purpose, because of those restrictions, sometimes companies have to put their infrastructure, some of the infrastructure on own data center. Rest of the infrastructure where there is no compliance restriction, they can put it on third-party cloud such as AWS. In that scenario, company is maintaining two sites. One is their own site and the other is AWS site. And that is called hybrid cloud model. So if you're working in a cloud computing company, right, who is doing a business for clients for launching their website on AWS. So you may be finding your clients in any of the three categories. Either they are having purely on private cloud, or they will be purely public cloud, or they'll be having hybrid cloud. I hope this diagram is clear to everybody and you understand it. Hybrid means computation will be on cloud, but data shall be on private. This is just one example. It is not necessary that every hybrid cloud will have VM on data. This is one example that probably some company is having virtual machine on premises and storage on AWS. This is one example I give, Samir. This is not the rule that VM should be here and storage should be there. Companies may have anything, right? It's just that %X workload is on own data center, %Y some services they are using from AWS. And it is very subjective. That is a perfect thing which is meant. That hybrid split is completely subjective to each firm. Right? It's up to them that how they evaluate their project cost, everything. So companies would do that. %X, %Y, X and Y are the random numbers. These are variables, right? Somebody can have 10%, 90% ratio. Somebody will have 50-50. Somebody will have 30-40. It's up to them what kind of percentage they want to have. That's why I use the word X and Y. Hybrid means something on AWS, something on own. So that is completely subjective to the company. It depends on many scenarios. What is their compliance is saying, what they find feasible. There are something that they find feasible to run on their own data center or must be on AWS. Mostly data need to be local. Why companies keep data on cloud for compliance? So you need to understand cloud computing for that purpose, because I agree with you that so far companies used to keep their data on locally, but nowadays you see, even Hotstar, one big example. In fact, Hotstar is having everything on AWS. This is public cloud model for Hotstar, right? So it's not that AWS or Microsoft or Azure, but I never mean that AWS is not compliant with the things. AWS is 100% compliant with many things. However, still companies' own policies sometimes have a restriction that we can't go with third party. Then what do you say? AWS is also compliant. Azure is also compliant. GCP is also compliant for storage. There is no doubt. They support all the compliances which is happening. But still, if the company have the policy, no, we have to be kept it local only. We can't do anything for that purpose, right? However, those companies who are ready to open, to accept and go ahead, because the benefit that you get on third-party cloud is more than what you do it on local. And that is for what purpose we are learning this particular course in this training. So when I'll teach you storage part, I'll make you understand what are the storage services AWS provides, how it is happening and how it is useful. Okay, so if you think that public means that it is public and it is not secure, no, that is not the thing. Everything is secure, by the way. What is the difference between architect associate and architect professional and certification details? Basically, associate level is a starting step. You act as a junior engineer or a cloud engineer into cloud projects. This is the initial start of you working on clouds. However, professional requires you to work for 2 to 3 years minimum. You must have 3 years of experience, and professional is a expert level of the same job. It's like junior engineer and senior engineer, similar to that. So the certification, if you want to start with, suppose you are starting your cloud career today, then you go with the solution architect associate. You get the job, you work on the job, spend some years, then go with the professional certificates. Services, those services who learn you in solution architect, same services you will get in professional. There will be some extra services also, but the level will be difficult comparatively. So we would be looking at AWS Global Infrastructure, and then we will see how to create your own personal AWS account. Then what are the ways we can access different ways to access AWS account. After this, we will be starting with the first service called Identity and Access Management. In that service, we will be looking after 4 important topics: root user, IAM user, group, and policy. All right. So let us start with AWS Global Infrastructure. And we discuss into that cloud computing is basically simple, on-demand delivery of IT resources over internet. It means there are companies who are providing infrastructure and the services to IT companies, such as if you talk about cloud providers, AWS is Amazon's business, so Amazon Web Services. And then we have Microsoft Azure and Google GCP. So AWS is a cloud provider. It means that AWS has provided a global infrastructure for companies. They have their own data centers and everything that companies do not need to maintain. So I'm going to show you this global infrastructure on the official website. So this is an official website of AWS wherein I can show you the image. Now this is what our beautiful world, and you can see there are some circles shown. These circles indicate presence of AWS data centers in the world. Now the point is very clear that Amazon will maintain the actual data center consisting of hardwares, and these data centers are located in different cities of the different countries. I can start with, let's say, USA. North America, we have, here Ohio, then Northern Virginia, Oregon, California, Northern California, and there are two which are for US government called as government cloud. You can see government cloud is that particular area, is that particular data centers is actually made up for US government only. So for us who are the actual customers, these are the regions in USA. However, in Canada, there are two, Canada West and Canada Central. Then there is Mexico. Now Mexico is in the red color. So basically all these are called as regions. Now Mexico region is the upcoming one. It is not made available. So they are in the process of making it. Then if you go to Europe, we have Spain, Paris, Zurich, Germany. Germany is coming soon. Stockholm. Then we have UK, London, Ireland, and also Middle East Kingdom of Saudi Arabia. So this is like coming soon, and the existing region is, yep, this UAE, Bahrain, Tel Aviv. In Africa, we have Cape Town. India has two, Mumbai and Hyderabad. And Australia, I believe, has two. One is Sydney and Melbourne. And then we have Jakarta, Singapore, Malaysia is upcoming, Thailand is upcoming, Hong Kong is already available, Taiwan is upcoming region. In China, we have Ningxia and Beijing and Seoul. And in Japan, we have Osaka and Tokyo. These all are called as regions of AWS. Region. So what is meant by region? A region is group of data center of AWS into a particular country. So if I take one example of Tokyo, I take Tokyo region. So what is meant by Tokyo region? Tokyo region is basically a group of data centers in that particular country. So let's say data center, you know that it is one building or a warehouse where hardware setups are there. So I am drawing couple of data centers in Tokyo region. And, these data centers are having hardware servers, storage servers, networking devices. It is all backed up by internet, electricity, everything. Even if I can show you something very interesting, how does an AWS data center looks like? Okay. So AWS data center. Last time I have seen one very wonderful video on official website of AWS. Okay, so yep, so if you can see, so they maintain big data centers, right? So what you see on the screen, the video is all showing you the glimpse of the place, one of the data center of AWS. However, I would see if I can show you something interesting. Yeah. So this is an image. You see this. This is one angle wherein, you can see two racks are there on the left-hand side in the black color. And inside that, there are hardware servers. Well, the point is they are maintaining it very wisely. They're taking care of security, performance, Yeah, so I was trying to show you an AWS technician gives us a tour of a data center in Eastern Oregon and how it looks like inside. Now, this is the actual image, right? So these people are maintaining those data center very perfectly. It has a huge capacity. There is one YouTube video. However, you will not be able to hear the sound of it, but yes, if I can make it maximize, you will actually get a glimpse of very precisely. We'll be talking about the upper layer. So right now I'd like to give that few minutes of this, showing you that, see, as I told you yesterday, there are only two things you can focus on, hardware and software. And softwares run over hardware. Now, AWS or Microsoft or Google, these guys are maintaining such data center and they are, big in numbers. They have these hardware servers you can see in the racks. Yeah, we have technicians who look after the maintenance of those data centers, hardware machines. Yeah, and they are all connected through internet. So of course, you need to be connected to a network in order to provide the service. And all the AWS services, there are 300 plus AWS services. They're all running on these data centers, right? So this is something which is a ready system called as cloud computing provided to all of us. We as an IT company or an individual, we can go use those services and deploy our application. Now, in this topic, we are actually discussing what is the strategy of AWS in maintaining the data center, and again, what is the concept of region and availability zone we are going to talk about. In a particular region, right, you saw the names of the cities in particular countries. Like in India, we have Hyderabad and Mumbai. Japan has Tokyo and Osaka. USA has 6 regions, I remember. Africa has Cape Town. Now, all these are the name of the cities in that country. These are all called as region. And one region consists of multiple data center. And one data center is like one building or one warehouse. You can see this is like one data center. I can show you again. This is like how many data center would be there? I think there are two. Yep. So these are two different buildings, or there is one third building and fourth building also. So these are separate buildings or warehouses called as data centers. I hope you have got now enough idea, which is required to understand it even better. All right. So I must be very confident that you have enjoyed this video and coming back to this. Now, one region, when I was talking about like Tokyo, it consists of multiple data centers. You can see on my screen, I have drawn a couple of black color buildings, and these black color buildings are data centers. Now, if you ask me, how many data centers in one region, there is no such official number given by AWS, but there are multiple data centers for sure. And what they do, if you have seen my diagram very carefully, then you would see that they have made subgrouping of data center within a region. Can you see I have made 3 groups of data center here? This is one group, this is another group, and there is one more group here. So this subgrouping inside a region, that is being made. So these data centers are placed in the form of groups. These are different buildings, but yes, there is enough distance between two groups. You can see there is a distance between two groups. How much distance they maintain is not sure. Even it is not officially declared on any website of AWS, but there is roughly 60 miles of distance. And it's not the official number, but what we have seen through different blogs and videos is around 100 miles, 100 kilometers or 60 miles of distance they maintain. It varies, it is very subject to place, but there is enough distance between the two groups. And they maintain that different groups. And why they maintain the group? Because they want to create availability zone. Now, what I have drawn in the green color, that green color circle, that group is called as availability zone. So I can name it like, for example, this is AZA, this is AZB, and this is AZC. So there are 3 availability zones inside one Tokyo region, and this Tokyo is a region. So now you can see there are 3 levels. The actual physical part is actually the data center inside which hardware is there. And there are groups of data center called as availability zone, and multiple availability zone consist of one region. And this is the same architecture you would see in every region. How many availability zones are there inside one region? Because in Tokyo, I have drawn 3 availability zones. But probably if you go to Northern Virginia, you would be finding it that, uh, Northern Virginia has 6 availability zone. And if you go to some another region, there can be different. So the idea is in a particular region, there are 3 or more than 3 availability zones are available. Any region if you so. Minimum 3 or more than 3 regions or availability zones are there inside the region. Now, why this structure is made? Why multiple data centers are required? Why they made groups of data center inside a region? Because when I launch resources and to launch the resources, I will use some service. Now you can see the list of services here. There are different categories, like these are analytics related services. So whenever you want to do data analytics, then you can go with these services, you can see on my screen. And then we have application integration. We have service that helps you to maintain blockchain related networks. Also, business applications are there. App Fabric, Chime. Chime is like, chatting service or meeting service. There is Connect, Pinpoint. You go to financial management related services. These are compute services. Compute services are helpful to you to run your website, your application, to run your code. And these are the main services like compute. Then we have containers also. So containerization is a very advanced technologies that is being used in the software development. So if people have the project in which they are using containerization, so they can go with these ECS service or EKS service. ECS stands for Elastic Kubernetes Container Service, and EKS for Kubernetes. Then we have customer enablement. We have database services, DynamoDB. We have relational database service, RDS. This is graph service called Neptune. We have developer tools. These are required for software developers who are making application and they want to deploy it on AWS. So they want CI/CD tools and all these things. So those who are familiar with CI/CD, you can see these services which are helpful for that. Then we have front-end and web mobile app service, wherein you can easily launch your mobile applications or front-end application easily, like Amplify, AppSync, Device Farm, gaming related service, Internet of Things, IoT, machine learning. These are AWS machine learning, AI, ML services. Out of that, many services are very famous, like Bedrock is used very, very extensively. We have DevOps Guru, we have Fraud Detector, some are related services, right? We have Poly, SageMaker. Those people who are in AI ML category, or those who want to pursue their career in AI ML. So in AWS, there is a service called SageMaker, which is used to build, train, and deploy machine learning models. Then we have media services, and you can understand now it is trying to widely cover all the possibilities which are required in the project. You can see security related services, and today we are going to learn IAM service. So you can see IAM is also listed here. Then finally, we have storage category, and there are multiple storage services we have. Now imagine I would like to create my project. And in that project, I want to create some resource. So basically, a project would start with, let's say, launching a website. I'm taking very simple example. I have a website, I would like to launch it. For a website, I require a server. So I can go to compute and I can go to compute category, try to find out EC2 service, a virtual machine it gives me. So when I launch this machine, when I create this virtual machine on my AWS account, basically it is created inside a region. Can you see on the right hand side, there are regions listed? All right, so you could see Northern Virginia, and there is a naming convention also. You can see there are two US East regions, Northern Virginia and Ohio, number 1 and number 2, which are actually named as US East 1 and US East 2. Followed by US West, there are two, Northern California and Oregon, which are named as US West 1 and US West 2. These are 4 regions in US. And then we go to Asia Pacific. We have Mumbai, like AP South 1, Osaka, and then you go to Europe, EU Central 1, then Stockholm, EU North 1. These are all list of the region. The number 1 is always the default region that is selected. In my screen, there is Northern Virginia. What is the region that is being shown on your screen? Is it Stockholm? If yes, then you can change it. Because you are deciding in which region you would like to launch your resource. So you can go to the list, click on Northern Virginia, and then N Virginia should be seen here. Now, after I remove the list, I am seeing only one name. So this is the selected region. Now come back. What I was trying to explain you that when I launch my resource, that resource will be launched inside this region, inside one availability zone. Now let me show you. For example, I'm launching one virtual machine. So my virtual machine will be launched inside a region and inside an availability zone. So imagine this blue color is my one EC2 machine, which I launched. And on that EC2 machine, my website will be running. So in the account, how many machines I have created? I have created only one machine, which you can see on my screen. That is one server I have created on which my website I have launched. But that server I have created, one EC2 virtual machine I have created in one availability zone. But in that availability zone, there are many data centers. Can you see that? 1, 2, 3, 4, 5. I have drawn 5 data centers inside it. So the idea is that within the availability zone, this EC2 machine is redundantly running on every data center. All right. Can you see I have drawn EC2 in every data center? So what I'm trying to explain is you have launched one EC2 machine, but it is running inside every data center. This is called redundancy. So actually this EC2 machine is only one in quantity, but actually it is running redundantly in every data center because they believe that if one data center is not responding for any reason, if that data center is not working well, or we are not able to or the AWS is not able to get that machine, then at least another data centers are running and your EC2 will be always available in that AZ, in that availability zone. So you have to see my diagram only. This is automatically redundant. This is not made by me. I have launched only one machine. We launch one machine. All right. And internally, automatically, this machine is running in that data centers in that availability zone. I have launched machine in AZ-A. Do you understand? I'm not talking about AZ-B or C. I have launched one machine and the EC2 machine is launched in only one availability zone. So you have one EC2 machine that you have launched, and that machine you have launched inside one AZ. And in that AZ, it is automatically redundant in all the data centers. Because if one data center fails, then other data centers are still having the EC2 running. Let's go step by step. Okay. All right. So the point is, I have launched only one machine, right? There can be a possibility that the whole availability zone is not responding. You can see the whole availability zone is not responding. There are possibilities, right? There can be technical issues in the whole data centers, all the data center in that AZ. or there can be problem related to natural calamities. We may not sure what may happen in the future. Maybe there is a big flood happens, maybe earthquake happens, or maybe there is, any kind of natural calamities which is you're going to make big impact on your availability zone. If that happens, and if that all data center in that AZ are not responding, will your EC2 will be available? Will this EC2 will be available if the whole availability zone is down, right? So the idea is that if the availability zone is not responding, then that EC2 will also be not responding. I'm talking about all the data centers are not responding in that availability zone. This never happens, but in case if it happens, then that EC2 will not be enough. So will you recommend your client launching only one machine? Will you say that, sir, let us go with one machine only, and one machine is launched inside one AZ? So there is a risk of AZ level issue, right? So always make sure that if that EC2 is launched, right, in one availability zone, then you have to recommend your client that don't go with one machine. All right, don't go with one machine, go with multiple machines, minimum 2 or more than 2. So I will recommend my client that, sir, we should go with at least 2 or 3 or 4 machines, minimum 2-3 machines we should go with. And if my client agrees, so what I will do, my first machine I will launch in one AZ, and the other machine I will launch in another availability zone. Now you see that my first machine I have launched in availability zone A, and the another machine I have launched in another availability zone. Both are having the same website. There is no doubt. Both machines are having the same website. Now, why I'm recommending it to launch the another machine in another availability zone? He could have launched machine in same availability zone. But again, the risk, whether the risk will be resolved, what is your opinion? If I launch 2 machines in the same AZ, is it going to help me more? Or instead of that, if I launch 2 machines in 2 separate AZ, what is better? In separate availability zone, is it better? If I go with multi-AZ approach, if I try to spread my machine in multiple availability zone, that is more better, because between the two groups, there is a big distance, right? So if anything bad happens in one area, that is not necessarily going to impact another area. And that is the idea behind the grouping. That is the idea behind availability zone. And that is why I always write down this formula that if you are using multi-AZ setup, this is called multi-AZ setup. It means you are launching multiple machine, but in multiple availability zone. I am again repeating, launching multiple machines in multiple availability zone. And that multiple availability zone, if you are launching your machines in, then you are going to achieve one important aspect in cloud that is called high availability. So please note down, this is one principle that everybody should be aware of, which is called high availability. High availability means your systems must be highly available. And I give you one simple example. Okay. So I'm right now giving you a training. Correct. So if my internet goes down, what would happen? So if my internet goes down, my system will not be available. It means I will not be available to you. Correct. But if I have alternate internet option, if I have alternate broadband option, then obviously I can switch to that network and I will be still available to you. Am I right? Another example, if I go to my exam tomorrow, if I carry 2 pens, 3 pens, then even if one pen fails, another pen is useful. So the idea is that this is my strategy. This is client strategy that we should launch multiple machine in multiple availability zone, because if one machine goes down because of the problem in the AZ, then another machine will necessarily not be impacted. It will be obviously running. And this is the way our customers will be able to find the website. The end customers will be able to always visit the website. Am I right? Is that the logic? Ultimately, your customer end customer should always be able to visit your website. Your website should not be down. That is called multi-AZ setup. And it is recommended that whenever you create the architecture, correct? Whenever you create the architecture, you should always maintain multiple availability zone setup. We know there are three components into global infrastructure. One is called data center, that you have already seen, the buildings inside which the hardware is there. The group of data centers is called availability zone. And the group of all the availability zone is called as region. Region indicates one city. So if it is Tokyo, not necessarily it is residing inside Tokyo only, but in the area of Tokyo, wherever Tokyo city is there, in that area, they are maintaining three groups of data center, and thereby the services or the resources will be launched over there. So I, as a customer, has liberty. I have a choice. If I launch my project, I can choose region as per my choice. By default, I have chosen Northern Virginia. So whatever I'm creating in this account, that will be created in Northern Virginia only. Do you understand that whatever I will be launching, I'll be launching in one region. Now the question is, the biggest question is, how would I know that which region is better for me? Okay. How would I know that what region is better for me and which AZ is better for me? These are very obvious questions. So the first thing is that I can see the list of region in different countries. In which region I should launch my infrastructure, I should launch my project. How would you know that? There are some strategies that you must be, followed. So I'm proceeding ahead with, criteria to choose the correct region. So this is called criteria to choose right region. Right means correct region. Okay, so I'm writing down the criterias which will help you to choose the correct region. And the first criteria is called governance. Governance and compliance, or we can say regulations. All right. So suppose my customer is a bank. All right. And the bank is from India. They want to launch their IT infrastructure on cloud. So which region they would be choosing? So they have to first of all check with their current governance compliances or regulations for which the company is abide to. Every business has to follow the rules and regulations of the country, right? Every government has set up the rules for the companies running in that particular country. So if my government says that I have to launch my resources in India only, right? So I have only two options. Either I will go with Mumbai or either go with Hyderabad. Do you agree? Do you understand regulations, compliances, and governance, which are every company has to follow that? So first question the client has to ask itself is there any obligation to me? If yes, then my choice becomes very restricted. Right. Then the second question, after this criteria, I have to also see one more thing that is called latency. Latency? What do you mean by latency? Okay. On my browser as a client, if I type www.simplilearn.com, Simplilearn.com, when I type it, I'm sending a request. Am I right? I'm sending a request to Simplilearn server from my client machine, and Simplilearn server will respond back with some web page, right? Okay. So if you go to Hotstar, right, you open the app and you click on some button, anything you clicked on because you want to watch the movie or the cricket match, anything like that, and you get the content back again. So what is this? This is the time it takes to respond back. So it is a kind of delay, right? Suppose the delay is more. Will you be happy as a customer? What is your user experience? What do you want as a better user experience? You want faster response or slower response? Quicker response, faster response. So latency is actually a delay in the response. So you would always look after latency factor. Suppose, as per my governance and compliances, India government is asking me for the bank, to launch their server in Asia only, right? Only in Asia. And in Asia, there are a lot of options I have. I have, many countries in Asia where data centers and the regions are available. But the second question I'm thinking about is latency. So in that, how would I choose the region? I would think of my end customer, the people who are going to visit the website. What do you want? You want lower latency, right? How would you achieve lower latency? How would you achieve the lower latency if the distance between client and server is less? Correct? Am I right? If my customers are in Asia, should I take the US region for my server? Do you think my end customer are sitting in Asia and they're sending request go back long way to USA and returning back? This is not a good approach. I should try to find a closer server. So basically, when I choose the region, I have to keep in mind where are my end customer are sitting. If my customer is in Africa, then it is very wise decision to choose some region which is closer by. If my customers are in USA, then I should choose some US region. If my customers are in Australia, then this Melbourne or Sydney would be the better one. Okay. So latency is one factor. Third one, the third criteria is called as cost. And this is very important criteria. The cost of using the services, as I told you, AWS charges you monthly billing. And in the monthly billing, you will see the charges of resources that you have used. But it all depends on the region also. The cost, the charges of services varies region to region. It varies region to region. So it also depends on the tax structure of the country. So if I'm launching something in India, and if I'm launching the same thing in USA, the charges that I'll be paying are different. So I have to see the cost factor also, that which one becomes cheaper for me. I have to save my money. So I have to look at the cost factor. And finally, the last factor is service availability. So suppose I'm looking for one service, and if that service is not available in the region, then that region is useless for me, correct? So it's very obvious that I should choose the region if the service is available. For example, in my project, I require 12 services. Those 12 services, are they available in the region? There's a list of regions as per the services. I can show you something very interesting that will be helpful for you. AWS services by region. Okay, so I would like to show you something interesting. List of AWS services available by region. So if I'm targeting Northern Virginia, then I can see these services are available. So I have to see if the service is available or not available. I'm sharing you these URLs. I'm making the file for all of you. Okay, so that's a good thing that you will be able to see these links later on. Second, you will be also able to see this data center part. I'm sharing you this also. And then I would also want you to see this particular link. So these are the 4 criteria roughly, which you can take in your mind, and you ask this question to yourself being a client, and then you will be able to choose the right region. But then another question is, if I choose the region, suppose I decided that Tokyo is the best region for me. So while launching the machine, which AZ is suitable? So there is no such criteria to choose the AZ. You can choose any AZ inside that region. Ultimately, are you going to launch in one AZ or multi-AZ? Multi-AZ. So if you are using all the availability zone, then there is a question of choosing the right availability zone. Is that question applicable then? What do you think? Because I'm going to use all AZs, then why should I ask the question which one is the better one? All are equal, right? All are same. So you can choose multiple availability zone. Number of AZ matters. In every region, minimum 3 AZs are there. And how much we are recommending you? Multiple. So what is the definition of multiple, Shayan? Think carefully. One is one multiple? No. 2 or more than 2? 2 or more than 2? So if possible, I will go with 2 or 3 or 4 or 5, anything as such, correct? So anything which is 2 or more than 2, that will be multiple. So it is you who is going to decide. If you try to cover maximum availability zone, you will get maximum high availability. Suppose I want to launch 3 server. Should I choose 2 AZs or 3 AZs for 3 server? I want to launch 3 EC2 machine. Obviously, try to launch 3 EC2 machine in 3 availability zone. Very simple. And that is what the criteria to choose region. Now, one thing is very clear that my whole project will be inside the region only. Now, the people are very creative. They are thinking about what if there is a problem in the whole Tokyo region? Can you think about it? It may happen. Can you give a guarantee? These are physical data center. Does any company can give guarantee that this will never fail? We have seen in the real world, we have seen many bad situations. We all have gone through Corona, right? For 2 years consistently. And there are wars happening. There are earthquakes happening. There are natural calamities. Human beings are not capable of giving a guarantee of anything, right? We are living in a damn real world. And that's why everything may fail at any time. So we must be able to think about that situation also. So if one region is there, right, and I'm launching a project in one region, and if that region goes fail, then what about the situation? The whole infrastructure will be down. Will your customer will be happy? The answer is no, not at all. So in IT, I'm not talking about cloud, okay? In IT, there is a strategy called a disaster recovery. Do you know DR? You must have heard of these words. DR strategy, DR strategy, DR strategy. This looks very big word, right? This is not a rocket science. This is a common sense. This is a common sense. You know, I live with my family. One day I'll be old. If my son says, okay, dad, you cannot live with me, I'll be buying another house also. If I don't have one house, I'll go to the another house. We always keep things backup, right? I am living in one city, but my parents are living in another city. If there is anything bad happens in this, I'll pack up. And this happened with Corona, right? We all went to our hometown back. We have another home. So similarly, this is what the DR strategy we use in our real life. During Corona pandemic, we all went back to our hometown and we all survived because we followed DR strategies, right? So the thing is simple. What is meant by DR strategies? So DR strategy is like, we recommend our clients to choose one region as a primary region where their actual production environment is live. So let's say Tokyo is something where the servers are running. All right. Now, we recommend them to create one more replica site or another site in some different region. Suppose I'm making a site in Northern Virginia. And I'm mimicking the same in architecture like this here in Northern Virginia also. So primarily, my end customers will be approaching or they will be made available with this infrastructure, which is running on Tokyo. So this will be called as my primary site. And the other one is, which is in completely different region, is called as recovery site. And the DR strategy is what? If any disaster happens in the primary site, let us say disaster happens, this is not available, then we will redirect our customers to our recovery site. Isn't it a simple logic? Isn't it a simple logic? This is called DR strategy. This is a strategy. So at the global level, of course, cost is involved. We are making 2 sites, right? So cost will be involved. Ultimately, you get global level of benefits. But this is the customer's responsibility. This is the client's responsibility to create 2 sites, one as a primary site, another as a recovery site. This is what is happening in the real world. Our real customers of AWS, or not only AWS, any cloud business or even the private cloud, people are creating 2 sites because they know that if the whole site goes down, we will have not enough time to recover it, and until we recover, that will be bigger downtime duration, more downtime duration. It will make a big loss to our business, right? Imagine Amazon.com is not available for 1 hour. How many billions of dollars they will be losing within that 1 hour? So they cannot take a risk of having that website down. Cannot take a risk of. Any end customer, any client is not happy with that, right? So as a solution architect, we should recommend DR strategies for them. I hope you understand the logic. Suppose the site is not filled, the primary site is wonderful, but your site is in Tokyo, but my customer are spread all across the world. I have global customers. It's not Asian customers only. I have the customer base all across the world in every country, and my main server is in Tokyo. So then the customers who are living near to Tokyo will get faster response. The people who are living far from Tokyo, I mean, imagine like your main server is here in Tokyo. You can see Tokyo here, right? In Japan. But your customers are all across the world. So people in USA will find it slower. Okay, forget about this. Have you seen the World Cup matches, cricket matches? Those who don't know cricket, it's a sports. You must have seen another sports matches also. So you must be using OTT platform. Now Disney Hotstar is something that the Disney Hotstar server is in USA, right? So we all sitting in different countries watching the match, the live stream match. How we are able to get the content with the lowest possible latency, because we are the global customer and the server is in some one particular region. For that purpose, there is another solution called as Content Delivery Network, CDN. Now CDN is something for that. There is one service called CloudFront, Content Delivery Network using CloudFront. All right. So downtime issue or the problem of failure, that is something is, has to be troubleshooted first. It is not necessary that there is a physical damage to your data center. There can be some problem from your side also. Being a client, you must have done a wrong setup, or there is some resources getting exhausted. So the thing is that troubleshooting is the responsibility of AWS team as well as your team who is making the infrastructure on AWS, right? So they all have to resolve the problem. If it is under the scope of your team, it is related to your services and project, your application, then you have to resolve it. If there is no problem from your side, then AWS team will help you to solve the problem from physical data centers perspective. So that is for sure. It is their product. They have to help you in order to maintain that. What is meant by redundancy? Redundancy means multiple things are running behind. When I say that I'm running one machine in one AZ, in my diagram, can you see in Tokyo, there are two machines. Can you see it? Yeah, okay. So this is my machine A and this is in machine B, and they are running in different availability zone. So when I say that this machine A is running in one availability zone, it means in that availability zone, there are multiple data centers, right? So the machine is running redundantly in data center. So behind the scene, they run multiple copies of that machine into multiple data center. For you, you'll see only one machine, but actually there are multiple machines running behind. This is called redundancy. Why redundancy is made? Not as a backup, but as a spare machine. There's a difference between the word backup and spare. Spare, right? You keep spare things. Am I right? So I go with 2 pens in the exam. One is spare. Okay. Now what is meant by backup? Backup means taking the copy of that into some storage device. Suppose I have mobile phone, I have photos of my family. So I take a backup of that. It means that I'm not creating one more mobile phone. I have one mobile phone only. I am not creating another mobile phone as a spare. So if I carry two mobile phone in my pocket, that is called redundancy. Like I'm having two things. But when I say backup, it means I have only one phone, but I'm taking a backup of photos into some storage so that in case if tomorrow my phone is lost, I can purchase a new phone and take my data back again. We take a backup in real life. Anyways, so AWS account creation, if you want at personal level, if you want to create your own personal AWS account or any company, then they can visit the website aws.amazon.com. You can note down. aws.amazon.com is the official website of AWS. So before you start creating an account, make sure that you have a valid credit card or debit card with you. So at least a credit or a debit card is required. Nowadays, net banking is also supported. UPI is also supported for India. So you can click on create AWS account on the top right corner. And once you click on create AWS account, then you get sign up page. Okay. Now going forward, it's a very simple step. You have to first of all give one simple email ID. So for example, I'm giving my email ID here, and you can give any account name as per your wish. So I'm saying that trainer is my account name. So once I do that, I put my email ID and everything. I'll click on verify email address. So when I click on verify email address, my email address will receive one OTP, and I have to enter that OTP. And once I enter the OTP, then they will ask me simple questions. What is your first name, last name? What is your address? What is your mobile number? And then they will ask me to enter either debit card or credit card details. That's all. And I have to create the account. It's that simple. Okay. So credit card and debit card for payment process, because when the bills are generated, they are generated by the end of the month. So you must be sharing with, either one valid debit card or credit card. So that's all. Initially, they do not charge you anything. So even if you give the details of credit card or debit card, they will not charge you anything. However, when the bill is generated, it is your responsibility to pay the bills. I hope this is clear how to create AWS account. This is similar to creating any account in any website. It is though very, very simple. Then next question is, what are the ways a client can access AWS account? So basically there are three ways AWS account can be accessed, or AWS account services can be accessed. And these three ways are called as management console. The second is called command line interface. Command line interface is also called as CLI. Console is also called as GUI. And the third is called SDK. SDK stands for Software Development Kits. Now, this SDK is called as programmatic way of accessing AWS account, or it is also called as programmatic access. These are the three ways we can always access your AWS resources. Now, the first way is called console. Console is basically a browser-based access. What is meant by browser-based access? Browser-based access means on my browser, I have opened aws.amazon website, and in that I have logged in into my account. Now this is an account where I have logged in, and you see console home. So this is called as console. This is the graphical user interface wherein I can use my mouse, I can click on icons, buttons, I can see the option, and accordingly I can visit a service and create a resource. So suppose as an example, I go to S3 and I type Amazon S3 and I go and I create a bucket in S3, right? Right now I'm just creating one S3 bucket, and the way I'm creating is actually, this is all graphical user interface, isn't it? I'm simply going and clicking on buttons, icons. I can see the different menus. I can see the resource created, and I can work on that resource. This way of access is called as graphical user interface, called as console access. And to enter into AWS using console access, you require user ID and password. So that is one way we can access AWS resources. And in order to log in into your account by this way, you require user ID and password. And this will be the way every day we will be accessing AWS account and we'll be doing practical. Okay. As a solution architect, most of the times you will be going through console way only. However, this is not the only way you can access your AWS account. There is another way you can access, is called as command line interface. Command line interface means there is a CLI you can have in your always your operating system. Like if you have Windows, you have command prompt, correct? Then you have Macintosh, like your Apple machines, or even if you have Linux laptop, then you will be having terminal, right? Now through that, like on command prompt, for example, I can type some command and try to log in into AWS account. Now that CLI access requires, again, it requires credential, and this access of login is through commands. That is why it is called as command line argument, right? So CLI is like you will be using commands, and through different commands you will be able to log in into AWS account. For that purpose, you require different kind of credential, which are called as access key and secret access key. Access key and secret access key, which is similar to user ID and password. Okay. So I will be showing you right now. I'm just telling you the three options. Okay. Whenever there is a demo of CLI, I will show you the demo of CLI also. But right now you can understand there are two ways I can log in into my account. One is on the browser. I have to enter user ID password. The other way is I can go through CLI. While going through CLI, I will enter access key and secret access key. Is that clear to everybody? And Mr. Ramdas, if you can understand, you have to try resolving the audio problems rather than blaming the whole class, right? So guys, you can confirm me if this CLI is also clear to you. I'll show you practically, don't worry, how the things are working, right? So who uses CLI option? That is a question. CLI option is used by mostly developers. The developers who are working on AWS project, they will be using CLI options multiple times. What operation you can do on GUI, the same operation you can do through CLI. For example, right now, I have shown you one simple task that I created one S3 bucket. Do you remember that? There is one service called S3 and there is one bucket I have created with this name. I did this with the help of buttons, icons, and by clicking on those icons, right? But I can do the same thing through CLI also. For that purpose, I have to use certain commands. I should know that for creating the bucket, what is the command to be used, right? For that purpose, I'm going to share you one document, which is called as AWS CLI reference. Now, AWS CLI reference is something, which gives you the information of all the commands that you can use. This page is an official website of AWS where you can see the name of services. For example, I want to find S3 service. So this is alphabetically arranged. I can scroll down. After I scroll down, I will try to find S3 service inside this particular list. Okay, so I got S3. In S3, what operation I want to do? So I can see all the operation of S3 here. So I want to, let's say, create a bucket. So I have to find out what is the operation for that. So MB, there's an available command list. If I go to MB command, so MB stands for make bucket. What it does, can you see the description? It creates an S3 bucket. So it helps you to create an S3 bucket. So if you want to do the same operation with the help of CLI, then you must have a knowledge of how to use MB command, right? How we can use MB command. So there is, a particular, example given, like for example, AWS S3 MB, and there's a name you have to give and region you have to give. So this document you can refer in future if you want to do CLI operation. Both operations are same. In the GUI, whatever I was doing, and in the CLI, whatever I will be doing, both are same. Only the way of doing is different. CLI operations are faster because GUI operation, if you go through GUI, you have to go through this website. You understand? If your request goes through the website, it will be experiencing a delay in the response. It's like loading the results onto this website. However, if you go through CLI, that operation happens very fast. Okay, so if you are a developer, you can understand it's very better that it is a direct API call from the CLI. However, through GUI, you are making a call through one application, that is the AWS website. So that is why it is nothing is like good or bad, but these are two different ways, and developers generally go through CLI to perform the operations very quickly. However, we will be going through GUI in the whole training to do the activities. GUI and CLI. Now the last option is reserved for only software developers, the people who are going to making the website. Because if I draw the architecture, and let me show you one sample architecture in front of you. So suppose if I go, and show you a simple two-tier architecture, right? So in the two-tier architecture, I will have a server on which my website is running. And then I have a database server on which my database is also running. Okay. Now you tell me, when from the website on the database, when the data will be inserted, right? So this operation of inserting the information into this database service will be done from the website. So this is nothing but your application. So when you write the code of application as a developer, you have to make request of that particular operation to this particular service. Now this database service is in your AWS account. Correct? So then that is something related to development. But the point is very simple. When software developers, they will do development, they will make the website or application. In the program, they will write down the command to get access to these services. So for that purpose, they will also require credential. And this is called programmatic access. Programmatic access means they are trying to access AWS services from the application itself, because this website has to make operation on database. And that is why it is called programmatic access. So this third option is out of scope for all of us because we are solution architect. This third option is only for software developers. Those who don't know development, for them, this is not applicable. Those who are going to become software developer or they will be becoming AWS developer, for them, this particular option will be useful. And for that purpose, again, they require access key and a secret access key. So these are the three possible ways people can go for, AWS account. They can try, with any of these three options. However, being a solution architect, you have to focus on console only. That is GUI, first option, which you can see on my screen. This is the GUI option. You'll be doing all practical on GUI only. Okay. So these are the three ways we can access our AWS account. This was for your information purpose only. Now what to do if you want to do CLI operation at all? Okay. So first of all, you all will follow me. You will open Google. And in Google, what you will do, you will type download AWS CLI. You can see my search query. I hope you are following me, right? You will click on Google and you will find download AWS CLI. Okay. So once you click on this, then you open this website, first website. All right. You must come on this page. Are you on this page? So what you have to do, you have to scroll down. Okay, choose the operating system. Windows or Mac. If Windows, then you see the first link here, which is .msi file. Okay, if you are Windows. Now, if you are a Mac user, then go to Mac. In the Mac, you again find package, PKG file. You simply need to see the operating system, Mac OS. It says AWS install update instruction. Go to Mac. And then you find this GUI installer, the first option. This is the link I'm asking you to click on. So if you click on this link, it will download one setup. Both for Windows and Mac, it will download one setup for you. So I am having Windows laptop. So I will do Windows demonstration for you. So I need to click on this. It is going to download one MSI file on my laptop. So if you open that setup, this will open a new window and you have to wait for some time until you get the next button. So for that next button, it will take few more seconds. So wait for a few seconds more and you will get next button very soon. Okay, so for Windows, the next button is appeared on my screen. I click on next, accept the license, next, next, next. I just need to keep installing, that's all. Right, so next, next, next. This is a very simple thing. Nowadays, even children can install any software, right? Like installing a game software. And then we will check it on command prompt, whether we can see it. So my screen is actually showing you the installation. So let me finish that first. After I finish the installation, I will go to command prompt and Mac people will go to terminal. So on the command prompt, you have to type one command, that is AWS space minus minus, that is hyphen hyphen version. And after you type AWS space hyphen hyphen version, you will be able to see one response which says AWS CLI 2.17.6 Python. Do you get that response? Do you get the response to the command AWS hyphen hyphen version? Okay, it means that CLI is available on your laptop. Now, this is a command to check the version of AWS CLI. Now I will give you next command. I have to log in. Please repeat the command to check login. Okay, so now after this is done, I will show you how to log in into AWS using CLI. Okay, so for that purpose, there is a command called AWS space configure. What is the name of command? AWS space configure. Same for Mac. This is a common command for all, even it is Mac or Windows. The name of command is AWS space configure. So once I enter AWS configure, they will ask me first question, access key ID. Is it asking you the question? Please enter access key. Now, what is meant by access key and secret access key? Secret access key and access key act as a username and password. Okay. So if I can show you here, I have written it for CLI, access key and secret access key is required. Now, how can I get it? But right now, I would like to create one access key or secret access key for me. I'm creating one access key for myself for CLI. Because you don't understand what is IAM user, so you will not understand what I'm doing right now. I know it better. I'm taking care of all of you.
Cloud services are now available to satisfy almost any IT requirement. Although cloud computing services vary greatly, they all have some basic qualities and benefits in common. And they can be classified into a few basic cloud service kinds. Hello everyone, I'm Shamli and I welcome you all to this new video of Simplilearn on cloud computing services. Let me give you an overview of the concepts you are going to go through in this video. First, we will go through what is cloud computing. Then we will have an introduction to cloud computing services, followed by the types of cloud computing services. And at the end, we will look into the features and benefits of cloud computing services. So let's not waste any more time and get started with the video. So what is cloud computing? Cloud computing is the distribution of cloud computing services via the internet, including servers, storage, databases, networking, software, analytics, intelligence to provide faster innovation, more flexible resources, and economies of scale. You usually only pay for the cloud services you use, which helps you cut costs, run your infrastructure more efficiently, and scale as your business grows. Now that we know what cloud computing is, let's proceed with understanding cloud computing services. Cloud computing services provide users with a variety of capabilities, including email, storage, backup, data retrieval, app creation, testing, data analysis, audio-video streaming, software on demand, regardless of the type of service. Although cloud computing is still a relatively new technology, it is now being used by a wide range of organizations, including large enterprises, small businesses, non-profit government agencies, and even individual consumers. So, not all clouds are created equal, and not every sort of cloud computing is appropriate for every situation. A variety of models, varieties, and services have evolved to assist you find the best option for your needs. To begin, one must decide on the type of cloud deployment or cloud computing architecture that will be used to implement your cloud services. Cloud services can be deployed in 3 different ways: public cloud, private cloud, or hybrid cloud. Now let's dive down deeper into cloud computing services and explore its type in more detail. Cloud computing, unlike a microprocessor, is not a single piece of technology. Rather, it's a system made up of 3 services: infrastructure as a service, platform as a service, and software as a service. So let's have a better understanding of each, starting with infrastructure as a service. So what is infrastructure as a service? It is a type of cloud computing that uses the internet to provide virtualized computing resources. The cloud provider controls IT infrastructures such as storage, server, and networking resources, and also offers them to subscribe companies via virtual machines, accessible over the internet in the IaaS model. For businesses, it can provide numerous advantages, including the ability to make tasks faster, easier, more flexible, and less expensive. Now, let's have a look at the working of IaaS. Users connect to resources and services across a wide area network, such as the internet, and then use the cloud provider's services to complete the application stack. The user can, for example, log into the infrastructure as a service platform to build virtual machines, install operating systems in each VM, deploy middleware such as databases, create storage buckets for workloads and backups, and install the enterprise workload onto that virtual machine. Customers can then track cost, monitor performance, balance network traffic, solve application difficulties, and manage disaster recovery using the provider's service. So moving ahead, let's go through its advantages and disadvantages. Advantages. Organizations select infrastructure as a service because operating a workload without having to buy, manage, and support the underlying infrastructure is frequently easier, faster, and more cost-effective. A company can rent or lease infrastructure from another company using infrastructure as a service. For workloads that are transitory, experimental, or change abruptly, it is an effective cloud service paradigm. For example, if a company is creating a new software product, hiring an IaaS provider to host and test the application may be more cost-effective. Once the new software has been thoroughly tested and refined, the company can move it away from the IaaS environment and into a more traditional in-house deployment. If the expenses of a long-term commitment are lower, the organization could commit the piece of software to a long-term IaaS deployment. Now, disadvantages. Billing can be a challenge for some firms. Despite its flexible pay-as-you-go model, cloud invoicing is quite detailed and it is broken down to reflect specific service usage. When evaluating the invoices for each resource and service involved in application deployment, users frequently experience sticker shock or discover expenses that are greater than expected. Another issue it faces is lack of insight because its providers own the infrastructure. The configuration and performance of that infrastructure are rarely transparent to its consumers. Users may find it more difficult to operate and monitor systems due to the lack of transparency. Users of infrastructure as a service are also concerned about service availability and reliability. The supplier has a big influence on the workload's availability and performance. The workloads of users will be impacted if a provider has network constraint or any other type of internal or external outage. Furthermore, because it is a multi-tenant design, the problem of noisy neighbors might have an adverse effect on users' workloads. So now these are the top infrastructure as a service providers. Linode is a privately held cloud hosting firm based in the United States that offers virtual private servers. Hostwinds, web hosting, cloud hosting, and dedicated server options are all available from Hostwinds. Microsoft Azure is a cloud computing service operated by Microsoft for application management via Microsoft Managed Data Centers. DigitalOcean offers developers cloud service that make it easy to deploy and grow programs that run on several machines at the same time. Alibaba Cloud is a cloud computing firm that serves online businesses as well as Alibaba's own e-commerce ecosystem. So the second service is Platform as a Service. What is Platform as a Service? Platform as a Service products which are geared towards software development teams include computing and storage infrastructure, as well as development platform layer that includes web servers, database management systems, and software development kits for multiple programming languages. Working of Platform as a Service. For software development, it does not replace an organization's complete IT infrastructure. It's made possible by the hosted infrastructure of a cloud service provider. A web browser is the most common way for users to access the offerings. Platform as a service such as application hosting and Java development can be supplied via public, private, or hybrid clouds. So now let's look into the advantages and disadvantages. Advantages. The main advantage of Platform as a Service for users is its simplicity and convenience. Much of the infrastructure and other IT services will be provided by the Platform as a Service provider, which users can access from anywhere via a web browser. The flexibility to pay on a per-use basis allows businesses to forego the capital costs associated with on-premises gear and software. Many Platform as a Service solutions are aimed towards software developers. These platform provider computation and storage infrastructures, as well as text editing, version management, compilation, and testing capabilities to assist developers in swiftly and efficiently developing new software. Coming to the disadvantages, Platform as a Service, on the other hand, can cause issues with service availability and resilience. Customers may suffer as a result of a service outage or other infrastructure interruption, which might result in costly productivity losses. Its suppliers, on the other hand, will typically deliver reasonably high uptimes. Another widespread problem is vendor lock-in, which occurs when users are unable to simply transition many of their services and data from one Platform as a Service solution to another. When choosing a provider, users must consider the business risk of service outages and vendor lock-in. Internal changes to a Platform as a Service product could also be a problem. The impact on users might be tough and disruptive. If a platform as a service provider ceases supporting a programming language or chooses to use a different set of development tools. So let's have a look at the top platform as a service provider. IBM Cloud Computing refers to a set of cloud computing services for businesses provided by IBM, a technology corporation. Red Hat is a collection of tightly integrated Red Hat technologies for building cloud infrastructure and developing cloud-native apps on premises. Elastic Beanstalk, AWS Elastic Beanstalk, is an Amazon Web Services application deployment orchestration solution. Salesforce offers CRM services as well as enterprise applications for customer service, marketing, automation, analytics, and application development. And Software AG Cloud is an open and independent cloud platform that serves as your one-stop shop for all software AG has to offer in the cloud. Now coming to the next service, which is Software as a Service. So what is Software as a Service? Customer Relationship Management, or CRM, marketing automation, and business analytics are just a few of the application-level services offered by Software as a Service companies. So how does it work? The provider gives consumers network-based access to a single copy of an application that the provider designed expressly for Software as a Service distribution in the software on-demand model. The source code for the program is the same for all clients, and new features or functionalities are rolled out to all the users at the same time. The data of each model's customer may be stored locally in the cloud or both locally in the cloud, depending on the service level agreement. Coming to its advantages, customers subscribe to a software as a service solution rather than buying and installing software or additional gear to support it. Many firms can now budget more effectively and predictably by converting costs to recurrent operating expenses. You can also cancel software as a service subscriptions at any time to avoid incurring recurring fees. Its systems are frequently customizable and can be connected with other corporate applications, particularly when using software for the same vendor. Vertical scalability is a feature of cloud services like software as a service, which allows clients to access more or fewer services or features on demand. Disadvantages of software as a service. When providers endure service delays, impose undesirable modifications to service offerings, or suffer a security breach, all of these things can have a significant impact on customers' ability to use the software as a service offering. Customers should be aware of their software as a service provider's SLA and ensure that it is followed. If the provider adopts a new version of an application, it will roll it out to all of its clients, whether or not they want it. This may need the organization allocating additional training time and resources. Switching vendors can be tough, as it is with any cloud service provider. Customers must migrate massive volumes of data when switching vendors. Furthermore, some vendors use technologies and data types which can make transferring client data between cloud providers even more difficult. So coming to the top companies that provide software as a service, Adobe is a collection of Adobe incorporation programs and services that provide user with access to software for graphic design, video editing, web development, and photography, as well as a set of mobile apps and certain optional cloud services. SAP is a platform as a service designed by SAP SE for developing new applications and enhancing existing ones in a secure cloud computing environment managed by SAP. Google Cloud. Google Cloud Platform is a set of cloud computing services provided by Google that run on the same infrastructure as Google's internal products, such as Google Search, Gmail, Drive, and YouTube. Freshworks Cloud Platform allows users to manage their identities and access across all of their Freshworks products. And Atlassian, advanced features such as an 99.9% uptime SLA, unlimited storage, and premium support provide teams the confidence to scale reliably. Now that we have all the in-depth information about different types of cloud computing services, let's move ahead and explore its benefits and features, which makes it so popular and convenient. First, the supplier hosts and maintains the site in their own facility. The cloud hosting provider acquires, hosts, and maintains the necessary hardware and software. Users avoid the construction expenditures and maintenance problem that would be incurred if the service was established on-premise. Second, self-service using a web-based interface. Through a web interface, service users can initiate certain service functions as well as increase or reduce their service consumption level with little or no intervention from the service provider. Third is, you must pay to utilize the facility. Users of the service only pay for the services they use. When compared to the typical method of building on-site IT capacities targeted for the highest usage situations and then having that capacity to go unused for the most of the time. This can result in significant cost savings. And the fourth one is scalability that comes close to being infinite. Cloud computing service providers usually have the infrastructure in place to deliver their services at a large scale. That means that cloud service consumers can readily accommodate business expansion or periodic surges in service usage. Well, this is all about cloud computing services.
Hello everybody, welcome to Simplilearn's AWS S3 tutorial for beginners. My name is Kent, and today I'm going to be covering these following points. I'm going to be covering what is cloud computing. I'm going to be showcasing what AWS is in terms of cloud computing, and I'm also going to be covering the core fundamental service of the Simple Storage service, which is a object storage service. We're going to be covering the benefits of the Simple Storage service, better known as S3, what objects and buckets are, and we're going to be seeing how things are working in the background and implementing that in terms of lab assisted demonstrations in order for you to see what those features of S3 are. And then we'll perform a wrap up of the material we've done in a conclusion. So let's get started. What is cloud computing? So here is a definition of cloud computing, but I'm going to paraphrase it. Cloud computing is nothing more than you gaining access to infrastructure through web services with a pay-as-you-go model. Now, this is a very, very different model than we're traditionally involved in on an on-prem data center. So when I mean on-prem, I'm saying on-premise. Okay, so you'll hear that a lot, on-prem. Now, when we are on on-premise data center, we have to provision lots of infrastructure even before we get started with deploying any type of application, whether it be a mobile application, a web application, etc., etc. So every application needs some sort of underlying infrastructure, whether that be bare bone servers, databases. They're obviously going to be needing some types of storage, etc., etc. So all this is something that we have to kind of fight against in order just to get started with deploying our application. So this takes usually, traditionally, depending on the size of the company, about 3 months to set up. So what if we could leverage all this infrastructure as a service and just through some API call, that's what the web services is all about, We could provision a server or we could provision a database within minutes and then deploy any type of application that we want to on top of that stack, and also take advantage of any storage that we may want. We may want object level storage, which is what we're going to cover. We may want an elastic file system, right? So there are different types of storages that we're eventually going to look at as you go down your learning path with Simplilearn. So cloud computing is really about provisioning of all these kinds of services, but not only at the infrastructure level. We're going to see how we could move up the stack and get entire platforms as a service, or even softwares as a service. So what is AWS? Well, AWS is really a cloud computing platform that will offer us many services through these API calls. Some are, again, just bare infrastructure like a service. Other can be a service as a software, for example, email. So here we have an example of the public data storage. This is S3, the simple storage service icon that you're going to see over and over again. This is a representation of an actual bucket in S3. So this will become more clear as we continue the slide deck and actually reinforce this with some hands-on lab. But as you can imagine, you may want to provision a private software-defined network in the cloud. And so we can do that in AWS. We can provide load balancing. We could provide scalability in terms of auto-scaling groups that will respond to increased demand as your application, let's say, becomes more popular. You want that infrastructure to grow elastically. So doing this on premise is traditionally not only extremely expensive and thus prohibitive, but very difficult to implement physically speaking as well. So by going with a cloud provider like AWS, we can severely reduce the expense and the complexity of setting all of this up, because we're trading capital expense for variable expense. So capital expense is about you procuring all the hardware that you need beforehand and the budget being approved before even getting that hardware in through your door, right? And then you have to configure it. So there's that complexity factor. Whereas if you're doing this through AWS, you can within minutes just provision all of that very quickly. So you're also not paying for everything all up front. You're paying this with a pay as you go model. So very different. We're now removing what's called undifferentiated lifting, which is everybody has to do the same thing, but it's not really bringing any value to their end product. We all have to buy servers and configure them and scale them, etc., etc. So if we remove that element and have AWS handle that, we can concentrate on our business, which is our application, and improving that application and responding more to our clients' request. We can be more agile, more flexible. So all of this leads to these points that we see here on this slide. Much easier to use, much easier to get our application to market. We're actually going to be leveraging the physical security that AWS implements for us. They have data centers all over the world that we're going to plug into, and that physical security is already implemented for us. There are varying levels of security that we're going to get into through our AWS journey, but right off the bat, you know that you have physical security. Of course, we're going to be talking about storage in this demonstration or in this slide deck over here. But the nice thing is we only pay for what we use. So that's that variable expense that I was talking about that we've traded for capital expense. We can easily set up databases. We can easily automate our backups and have those backups stored in the cloud through that S3 storage that we're going to get into. Okay, so lots of benefits of going through AWS here. And it's also comprehensive and simple to use. Comprehensive meaning that there are hundreds and hundreds of services. It's going to be actually quite time consuming for you to just know what each service does in general, but you'll get there through your journey. It's all about sticking with it and learning something new every day, which is what Simplilearn is all about. Over here, we have infrastructure as a service, platform as a service, and software as a service. So these are three different types of distinctions we have in the cloud industry to basically cover what's going on here on the right hand side. So on premise, you're traditionally involved in everything from networking, which is you, for example, buying the switches, the routers, the cabling, everything all the way up the stack to deploying your application, and you see everything in between there. Okay, so this is a very time-consuming job. Not only that, but it costs a lot of money because you have to buy all these machines up front, and you have to have the individuals with the right knowledge to maintain all of this stack. All right, so different individuals in different teams maintaining this whole on-premise data center. You may also have different data centers deployed globally. So you can imagine the cost overhead of this. So everything in green is basically you're managing it. Now we can offset that and ask AWS to handle part of this stack over here. So on this second column over here, we see infrastructure as a service, which basically says, AWS, I want you to handle all the networking, my software-defined network. I want you to handle my storage, elasticity. I want you to handle my compute power, my virtual machines. I want you to handle even administrating those machines at a physical layer as well. And I want you to physically secure them. So this will allow you more time to focus on all the green up here. Of course, we can move up the stack and say, I even want AWS to take on more responsibility. And that would be more of a platform as a service where AWS would also install and maintain the operating system for you. So you can imagine things like new versions of operating systems, security patches, maintenance patches, all of the like, and any middleware or runtime that you have on top of that. Think of something like the Java virtual machine, perhaps, that needs to be updated. Now, you wouldn't be responsible for maintaining all of what's in orange over here. You would only be responsible for deploying your application and making sure that your data is saved and secured, right? So again, platform as a service is a more hands-off approach. So think of it as you wanted to set up a CI/CD deployment environment for your development team, and you wanted to be very involved in just handling your application code and making sure that it was properly compiled, built, tested, and deployed, right? Well, this could be implemented as a platform as a service. Or you could take your code as a zip file and give it to AWS's service called Beanstalk, which would automatically deploy your code and make sure that it's highly available, scalable, and fault tolerant across all of the orange stack over here, right? So more of a hands-off approach. Of course, we can go all the way up the stack and tell AWS to take care of everything for us and just ask for a service, much like a utility, like electricity or water. We might want to say, we just want an email software service, and we're not really concerned about how the underlying operating system or servers or network are configured for that. We just want to use the software as a service. We don't want to administrate anything else. We just want to be sort of like an end user to it. So AWS will manage everything underneath the hood. So there are varying types of services. You pick and choose whichever one makes more sense for you and your team. So what is S3? S3 stands for Simple Storage Service, and it is an object storage service in Amazon. What this means is that it doesn't matter what kind of file you upload to S3, it will be treated as an abstraction, meaning an object. So you can upload a PDF file, you can upload a JPEG file, you can upload a database backup. It doesn't really matter. All that is abstracted away by the use of storing it within an object. We're going to talk more about what composes an object. But by doing so, what happens is S3 allows us to have industry leading scalability. So it doesn't matter if you're going to make a request for that database backup, let's say that object, 5 times or 10,000 times, that request, that demand will scale. The underlying infrastructure that is implemented behind the scenes is handled for you. So in a sense, it's kind of like a serverless service, a storage service, where you're not implicated in handling anything underneath the covers. You're just uploading your objects and accessing them later on. In terms of data availability, very powerful as well, because it takes those objects and will replicate them across at least 3 availability zones. Of course, these availability zones have 1 or more data centers attached to them. So you have lots and lots of copies of your objects distributed globally, or at least at a regional, in a regional area. You can do this as well globally if you enable global replication. And you will see that your level of durability will skyrocket, and you're just not going to worry about losing an S3 object. Data security, well, we can encrypt our data at rest, our objects at rest. We can encrypt it in transit. We can also come up with security policies at the bucket level, which we're going to talk about what a bucket is very soon. These are going to be implemented through what's called IAM policies, and you're going to be able to control who or what has access to your objects. And of course, because everything is handled underneath the covers, all the servers, all the storage nodes are cloud optimized for the best possible performance. So let's continue on our journey on what is S3. We're going to take a look at what is a bucket and what is an object. As you can see here, you have inside this bucket, which is a logical container for an unlimited amount of objects. You could have objects of different shapes and sizes. Like I said, you could have pictures, database backups, etc. So this is what's being represented here by different shapes. And you can think of a bucket really as almost like a folder where objects or files are placed within them. So there are many ways for us to place objects within a bucket. We can do this through the AWS console, which I'll be showing you very shortly. We can do this via the command line interface, or we can do this through a software development kit. At the end of the day, all those 3 options go through an API, right? So it's all about picking the right method that is best suited for whatever kind of end user or application that needs access to these buckets and to these objects. Now, once you've got the data or objects within this bucket, you can control pretty much how the data is accessed, how it's stored, whether you want it to be encrypted, and how it's even managed. So you can have organizations that have specific compliance needs. For example, any objects that are placed in there, perhaps some PDFs, are not to be modified or not to be touched for 90 days. Let's say we can imply object locks if we want to. We can imply security guards. We can also, for example, record all API actions that try to access, to list, to delete any kind of API operations on those objects at the bucket level or on the object level. We can record if that is some sort of organizational compliance need for auditing or for whatever internal auditing reason that you may have. So continuing on here, you can see that there are many organizations that use S3. One in point is Amazon itself. S3 is so popular and so durable that Amazon internally uses it to store its own data. You're guaranteed, almost that you're not going to lose any object in there because it has what we call 11 nines durability. Now, 11 nines durability is really an extreme amount of durability where it's mathematically almost impossible for you to lose an object once you place it in S3. You're in fact more liable to get hit by a meteorite than you are to lose an object in S3, statistically speaking, which is a pretty incredible statistic, but it's true. So if we continue here with the benefits of S3, some of these I've already described, but let's talk about the full picture here. We see the performance, scalability, availability, and durability of S3 are really first class in the industry. Again, durability, we were talking about that 11.9. So what that really means is 99.9999 in total. If you count all the nines, that's 11 of those nines. So most durable in the industry by far. And again, because everything is handled underneath the covers, it's a serverless service. They ensure the scalability and availability and the performance of the inner workings of that object level storage. Now, cost is of course always important, and S3 really shows up here with first class support again for cost. It's got very, very low cost. We can have object level storage for let's say a terabyte of object level storage for as little as $1 a month. So again, it will depend on the kind of storage class. We're going to have a discussion on different types of storage classes that we might want to transition or move over our objects from one storage class to the next, depending on how frequently accessed that data is. As you know, data over time seems to get less and less accessed as your needs shift from one place to another. We're going to talk about that coming up very soon. So we're going to want to really focus on that to reduce our end of the month costs for storage with S3. Of course, security is always at the forefront, and we want to make sure that we either simply secure by encrypting everything right off the bat, either at rest, in transit, or we want to put an object lock or just maintain security at the bucket level, maintaining, let's say, who or what has access to that data. Because by default, no one has access to the data unless we open up the door. And also we want to make sure that we don't give public access to our bucket for obvious reasons of giving away important information by mistake. So AWS makes it extremely difficult for you to accidentally do this. And I'm going to show this in a demonstration lab coming up very soon. And we can also query in place, which is very interesting. So you can imagine you putting, let's say, a file that's in CSV format or a JSON format or Parquet format, some sort of structured format or semi-structured format in S3, and you could actually use SQL queries on the spot to filter that data in place at the bucket level. You could also have other services that may want to extract some business intelligence from that data in your S3 bucket directly as well. So some other more advanced querying operations can take place at the S3 level. So this you will learn during your journey with Simplilearn as you're covering all the AWS technology stacks. And here, the most widely used storage cloud service in the industry. Because of all the points that we just covered, it really is the #1 storage or object level storage solution in the industry. Let's now take a look at objects and buckets in S3. So the objects are really the fundamental entities that are stored in S3, or the lowest common denominator, which means that we're not really interested in what kind of data is within the object at the layer of S3, because S3 doesn't have direct access to the data within an object. Like I said before, it's an abstraction of the data. So we don't know if it's a cat picture, if it's a backup of your database. It's just treated as a fundamental entity, aka the object. Now, every object is associated with metadata, so data about itself, things like what's the name of the object, what's the size, the time and date that the object was uploaded. Things of that nature are categorized as metadata. So S3 does have direct access to that. Now, the data within that object, of course, is accessible by other services. So it's not that once you've uploaded it, you've totally lost the data and it's only can be treated as an object. It's just that at this layer, it's simply just assign metadata and a version ID, a unique version ID. And if you re-upload the exact same object a second or third time to S3, it will have its own version ID number. So a new unique version ID number will be generated. So really what buckets are their logical containers to store those objects. So of course, at an extremely high level, a bucket would be like your root file system, if you want to think about it like that. But that doesn't mean you can't go into this bucket and create separate folders. Now, when you create separate folders in a bucket, because you might want to logically organize all your objects, you might be fooled by the fact that you think this is a hierarchical storage system, when in fact it is not. And I'll talk about that in a second. So you cannot store an object without first storing it into a bucket. So of course, the first step would be for us to create a bucket and then upload objects within that bucket. So an object cannot exist without its container or its bucket. So there's no Windows Explorer view like we're used to in an operating system, because this is not a hierarchical view. No matter if you create folders within folders within folders, in fact, S3's internal architecture is a flat hierarchy. What we do instead is we assign prefixes which are treated as folders in order to logically organize our objects within our buckets. And I'm going to showcase a prefix in one of the demonstrations coming up very soon. So when you create, or when you're working with S3, first of all, you're working at a regional level. You're going to have to pick a region. For example, you might pick US East 1 region or US East 2 region, and the bucket that you're going to be creating will be replicated across several availability zones, but within that region. Also, that data, those objects, can be accessed globally because S3 uses the HTTP protocol. HTTP protocol is very permissive. Everybody knows how to administrate it and work with it. So we just need to give access to that object in terms of a permission policy and give it the proper URL, or give whoever needs access to it the proper URL, and they can access that via HTTP globally. So first, when you're creating a bucket, you have to select the region, and the object will live within that region, but that doesn't mean that it still can't be accessed globally. So let's now take a minute, go over to the AWS console, and actually let me showcase how to create objects and buckets. So for our first lab, we're going to be going and creating an S3 bucket and uploading an object to it. So we first have to log into the AWS console, which we have up here in the address bar. Let's click on either create free account if it's your very first time, or as is in my case, already have an account. We're going to sign in here. You're going to have to pass in your IAM username, password, and your account ID, of course. Once you've logged in, you can search for the simple storage service S3 either by coming up here in the search box and typing S3, and you'll find it there. That's probably the easiest way. Or if you want, you can take a look at all the services and it'll be under storage over here, the first one. Okay, so pick whichever method you see best for yourself. Once we're here, we want to create our first bucket. Now I've already have a couple of buckets here, so we're going to go on and create a new bucket. The very first thing is you have to specify a bucket name. Now this bucket name has to be globally unique. If you take a look here at the region that we're in, it doesn't actually select a specific region. It selects the global option, which means that this bucket will become globally accessible. So that is why it needs to have a unique name, much like a DNS name has to be unique for your website, right? So I'm going to come up here and pick a name that I think is going to be unique. So I'm going to say Simplilearn S3 demo. All right, let's take a look at if that's going to work out. Of course, we have to pick a region, but it is globally accessible. So you either pick a region that's closest to your end users, or in our case, since we're just doing a demonstration, we can do whichever is closer to us right now, okay? And we're gonna skip these options for now. We're gonna come back to them later on. We're just gonna create the bucket. Now, hopefully that was a unique name and allowed me to create that, and it looks like it did. So if I scroll down, you can see that it clearly got created over here. Now, we're going to click on that, and we're going to start uploading objects to this bucket. So let me click on the upload button, and you can either select one or more files, or you can select an entire folder. So I'm going to just go and select a specific cat picture that I have here. Okay, and again, we'll go through some of those other options later on, and we'll just click upload. Now this should take no time at all because of the fact that it's a very small object or file that's being uploaded. So it has succeeded. We can close this up. And we see now clearly that the object is in our bucket. If we go to properties, we can see the metadata associated with this bucket. We can see the region that it's in. We can see the ARN, which is the Amazon resource name, which uniquely identifies this resource, this bucket, across the globe. So if ever you needed to reference this, let's say in an IAM policy or whatever other service needed to communicate with S3, you would need this ARN. It's a very important piece of information. And of course, we have the creation date. Some high level metadata. So objects, as we have covered already, consist of not only the data itself, but the metadata. So there's lots of metadata, and there's a lot of other features that we can go here and enable very easily. And this will be the basis of the future demonstrations that I'm going to do. All right. So just to recap what we just did, we created a unique bucket, give it a name of Simplilearn S3 demo, and uploaded our first object to it. So let's now take a look at the inner workings of the Amazon S3. When we upload an object into a bucket, we have to select which one of these storage classes the object will reside in. So you see I have 6 storage classes here at the bottom, and each have their own characteristics that we're going to get into. By default, if you don't specify anything, it'll get placed in what's called the S3 standard storage class, which is the most expensive out of all these storage classes. Once your object gets colder, and what I mean by colder is your access patterns diminish, meaning that you're accessing that file less and less over the course of time, so it gets colder, you will transition that object from one tier to the next, all the way to, for example, S3 Deep Archive. So again, Deep Archive signifies extremely cold, so maybe you're only referencing this data once a year, once every couple of years. And so you want to have the cheapest possible storage available. So right now you can get about 1 terabyte of storage per month for about $1 a month with S3 Glacier Deep Archive. So you are going to be very interested in knowing how to transition from one or more of these storage classes over time in order to save on your storage costs. That's really why we're doing this. So let's go through some of these storage classes. By default, like I said, whenever you upload an object, you automatically get placed into the standard storage class. So any files that you're working on frequently, daily, this is the best fit for it. You've got the highest level of accessibility and durability as well. Not that the others don't have the same level of durability. However, we'll see how when you transition from one storage tier to the next, some characteristics do change in order for you to save on some costs. We're going to go through some of those. Now, this would be considered hot data, right? Data that's used all the time, maybe just by you, maybe by everybody, right? So that's the perfect place to place it in the standard storage class. Now, over time, like I said, you may find yourself working less and less, perhaps on a document that was due by the end of the month. That document was submitted, and then afterwards you don't work on that document anymore. Perhaps you're only working on revisions based on feedback from your colleagues that are asking you to make some corrections or some amendments. And so only those corrections or amendments come in perhaps once a month. And so in that case, you might find yourself finding a justification for moving that document from the standard tier to the standard IA or infrequently accessed tier. Maybe any objects not modified for more than 30 days are a good fit for that. And that's really the criteria for IA, inactive access, is that S3 or AWS itself recommends to only put objects in there if they haven't been accessed for at least 30 days. So you get a price reduction, a rebate for putting objects that are not accessed frequently in here. Of course, if you remove objects, let's say before the 30-day limit, then you are charged a surcharge for retrieving an object that you said was infrequently accessed, but it really was not. So bear that in mind. If you're going to place objects in infrequent access, be somewhat reasonably assured that you're not going to be going there and accessing them. You can still access those files, no problem, just as quickly. They have the same level of accessibility and durability. However, like I said, anything less than 30 days, you'll get a price ding on that. If you want to have long-term storage, we're talking about Amazon Glacier. So this is more anything over 90 days that hasn't been modified, or 180 days. There's two subcategories of Amazon Glacier that we're going to get into. And this is the cheapest storage by far. And Amazon Glacier doesn't really operate through the AWS console as the same as the standard and the infrequent access. You can't really upload objects to Glacier via the console in the browser. You can only do so, let's say, through the command line interface or through an SDK. The only thing you can do on the web console with Glacier is actually create what's called a vault, which is a logical container for your archives. But then after that, you have to go through the CLI or the SDK to do the rest of the work there. If we continue on, there's some gray areas between the S3 standard and the Glacier. One is the one zone infrequently accessed storage class. So if we go back to the regular standard and IA storage class, all of these objects are stored across a minimum of 3 availability zones. If you want a further price reduction, you can store your objects in a one zone IA storage class, which means that instead of taking that object and replicating it across 3 or more availability zones, it will only store it in a single availability zone, therefore reducing the level of availability that you have to that object. So in this case here, if that single availability zone would go down, for example, you would not have access to that object. Once it would come back up, of course, you would. The other thing is if there was an immense catastrophe where the actual availability zone was destroyed, well, of course, then your object is also gone. So if that's something that doesn't worry you because you have already many copies of this object maybe lying around on premise, then this is a good option for you because it's data that you're willing to lose or lose access to for short periods of time if ever that single availability zone goes down. So it's about an extra 20% off the price from already the normal IA standard price. There is another one called the standard reduced redundancy storage. This one is kind of getting phased out as we speak because the same price for this storage class is about the same amount you're going to pay for the normal IA standard class. What this does is, again, is a good fit for your objects that you're not really worried about losing if there is some sort of catastrophe that happens in an availability zone. There's less copies of it that are stored, and so if that data center and that availability zone goes down, then you lose your object. So of course it offered at the time the highest price reduction possible, but now the difference between this one and the normal IA standard storage class is so small in terms of price that you're probably not going to migrate to or navigate to this storage class. But it is still there in the documentation, and it may very well come up still in the certification exam, so at least be aware of that. Let's now take a look at some individual features of S3, starting off with Lifecycle Management. So Lifecycle Management is very interesting because it allows us to come up with a predefined rule that will help us automate the transitioning of objects from one storage class to another without us having to manually copy things over. Of course, you could imagine how time consuming that would be if we had to do this manually. So we're going to see this very soon in a lab. However, let me discuss how this works. So once it's basically a graphical user interface. It's very, very simple to use once you come up with these lifecycle management rules. But you're going to define two things. You're going to define the transition action and the expiration action. So the transition action is going to be something like, well, I want to transition an object from, maybe it's all objects, or maybe it's just a specific type of object in a folder, example, that has a specific prefix, from one storage class, let's say standard, to standard inactive or infrequent access. Maybe only after 45 days, after at least a minimum of 30 days, like we spoke of before. And then maybe after 90 days, you want to transition the objects in IA to right away Glacier Deep Archive, or 180 days. You come up with whatever combination you see fit, okay? It doesn't have to be sequential from S3 to IA to one zone, etc., because like we discussed before, it depends what kind of objects that you're interested in putting in one zone, objects that you don't really mind losing if that one availability zone goes down. So you're going to be deciding those rules. It ends up that this even is not a simple task because you have to monitor your usage patterns to see which data is hot, which data is cold, and what's the best kind of lifecycle management to implement to reap the benefits of the lowest cost. So you have to put somebody on this job and make the best informed decisions based on your access patterns, and that is something that you need to consistently monitor. So what we can do is we can instead opt for something called S3 Intelligent Tiering, which basically analyzes your workload using machine learning algorithms. And after about a good 30 days of analyzing your access patterns, we'll automatically be able to transition your objects from S3 standard to S3 standard infrequent access. Okay, it doesn't go past the IA one, it doesn't go after the Glacier and whatnot. Okay, so it can then offer you that at a reduced price overhead. So there is a monitoring fee that is introduced in order to implement this feature. It's a very nominal, very, very low monitoring fee. And the nice thing is if ever you take out an object out of the infrequent access before the 30-day limit, as we spoke of before, you will not be charged an overhead charge because of that. Why? Because you're using the intelligent tiering. You're already paying an overhead for the monitoring fee. So at least in that sense, the intelligent tiering will take the object out of IA and put it back into the S3 standard class if you need access to it before the 30 days. And in that case, you won't be charged that overhead. So that is something that is very good to do in order not to have to put somebody on that job. So yes, you're paying a little bit of overhead for that monitoring fee, but at the other side of the spectrum, you're not investing in somebody working many hours to monitor and put into place a system to monitor your data access patterns. So let's take a look at how to do this right now. Let's implement our own lifecycle management rules. So let's now create a lifecycle rule inside our bucket. First off, we're going to need to go to the Management tab. in the bucket that we just created. And right on the top, you see right away, lifecycle rule. We're going to create lifecycle rule, and we're going to name it. So I'm just going to say something very simple, like simply learn lifecycle rule. And we have the option of creating this rule for every single object in the bucket, or we can limit the scope to a certain type of file, perhaps with a prefix like, I could see one right now, something like logs. So anything that we categorize as a log file will transition from one storage tier to the next as per our instructions. We're doing this because we really want to save on costs, right? It's not so much of organizing what's your older data versus your newer data. It's more about reducing that storage cost as your objects get less and less used. So in this case, logs are a good fit because perhaps you're using your logs for the first 30 days, you're sifting through them, you're trying to get insights on them, but then you kind of move them out of the way because they become old data and you don't need them anymore. So we're going to see how we can transition them to another pricing tier, another storage tier. We could also do this with object tags, which is a very powerful feature. And in the lifecycle rules action, you have to at least pick one of these options. Now, since we haven't enabled versioning yet, what I'm going to do is just select transition the current version of the object between these storage classes. So as a reminder of what we already covered in the slides, our storage classes are right over here. So the one that's missing is obviously the default standard storage class, which all objects are placed in by default. So what we're going to say is this. We want our objects that are in the default standard storage class to go to the standard inactive access storage class after 30 days. And that'll give us a nice discount on those objects being stored. Then we want to add another transition. And let's say we want to transition them to Glacier after 90 days. And then as a big finale, we want to go to Glacier Deep Archive. You can see the rest are grayed out. Wouldn't make sense to go back. And maybe after 180 days, we want to go there. Okay. Now there's a little bit of a warning or a call to attention here. They're saying if you're going to store very small files into Glacier, not a great idea. There's an overhead in terms of metadata that's added, and also there's an additional cost associated with storing small files in Glacier. So we're just going to acknowledge that. Of course, for the demonstration, that's fine. In real life, you don't want to store very big tar files or zip files that had, one or more log files in there. Okay, that would bypass that surcharge that you would get. And over here, you have the timeline summary of everything we selected up above. So we have here after 30 days, the standard inactive access, after 90 days, Glacier, and after 180 days, Glacier Deep Archive. So let's go and create that rule. All right, so we see that the rule is already enabled, and at any time you could go back and disable this if ever you had a reason to do so. We can easily delete it as well, or view the details and edit it as well. So if we go back to our bucket, now what I've done is created that prefix with the /logs. Since we're not doing this from the command line, we're going to create a logs folder over here that will fit that prefix. So we're going to create logs, create a folder. And now we're going to upload our, let's say, Apache log files in here. So we're going to upload one demonstration Apache log file that I've created with just one line in there, of course, just for demonstration purposes. We're going to upload that. And now we're going to just close that. And now we have our Apache log file in there. So what's going to happen, because we have that lifecycle rule in place, after 30 days, any file that has the logs prefix, or basically is placed inside this folder, will be transitioned as per that lifecycle rule policy that we just created. So congratulations, you just created your first S3 lifecycle rule policy. Let's now move over to bucket policies. So bucket policies are going to allow or deny access to not only the bucket itself, but the objects within those buckets to either specific users or other services that are inside the AWS network. Now, these policies fall under the category of IAM policy. So IAM stands for Identity and Access Management. And this is a whole other topic that deals with security at large. So there are no services in AWS which are allowed to access other services or data, for example, within S3 without you explicitly allowing it through these IAM policies. So one of the ways we do that is by attaching one of these policies which are written in a JSON format. So it's a text file that we write. At the end of the day, that's the artifact, and that's a good thing because we can use that artifact and we can configuration control it in our source control and version it and put it alongside our source code. So when we deploy everything, it is part of our deployment package. So in this case here, we have several ways of doing this. We can use what's called the policy generator, which is a graphical user interface that allows us to simply click and point and populate certain text boxes, which will then generate that JSON document that will allow us to attach that to our S3 bucket. And that will determine, like I said, which users or services have access to whatever API actions are available for that resource. So we might say we want certain users to be able just to list the contents of this bucket, not necessarily be able to delete or upload new objects into that bucket. So you can get very fine-grained permissions based on the kind of actions you want to allow on this resource. So in order to really bring this home, let's go and perform our very own lab on this. Let's now see how to create an S3 bucket policy. Going back to our bucket, we're now going to go into permissions. So the whole point of coming up with a bucket policy is that we want to control who or what, the what being other services, have access to our bucket and our objects within our bucket. So there are several ways we can go about doing this. Let's edit a bucket policy. One, we can go and look at a whole bunch of pre-canned examples, which is a good thing to do. Two, we could actually go in here and code the JSON document ourselves, which is much more difficult, of course. So what we're going to do is we're going to look at a policy generator, which is really a form-based graphical user interface that allows us to generate, through the answers that we're going to give here, the JSON document for us. First question is, we got to select the policy type. Of course, we're dealing with S3, so it makes sense for us to create an S3 bucket policy. The two options available to us are allowing or denying access to our S3 bucket. Now, in this case here, we could get really fine-grained and specify certain kinds of services or certain kinds of users. But for the demonstration, we're just going to select star, which means anything or anybody can access this S3 bucket. All right. Now, depending on also the actions that we're going to allow. So in this case here, we can get very fine-grained, and we have all these checkboxes that we can check off to give access to certain kind of API action. So we can say we want to give access to, just deleting the bucket, which obviously is something very powerful. But you can get more fine-grained. As you can see, you have more of the getters over here, and you have more of the listing and the putting new objects in there as well. So you can get very fine-grained. Now, for demonstration purposes, we're going to say all actions. So this is a very broad and wide-ranging permission, something that you really should think twice about before doing. We're basically saying we want to allow everybody and anything, any service, all API actions on this S3 bucket. So that's no small thing. We need to specify the Amazon resource name, the ARN of that bucket specifically. So what we're going to do is go back to our bucket, and you can see here the bucket ARN. Okay, so we're just going to copy this, paste it in this policy generator, and just say add statement. You can see here kind of a resume of what we just did, and we're going to say generate policy. And this is where it creates for us, and make this a little bit bigger for us, it creates that JSON document. So we're going to take this, we're going to copy it, and we're going to paste it into the generator. Okay. Now, of course, we could flip this and change this to a deny, right? Which would basically say we don't want anybody to have access or anything, any other service to have access to this S3 bucket. We could even say /* to also encapsulate all the objects within that bucket. So if I save this right now, you have a very ironclad S3 bucket policy, which basically denies all access to this bucket and the objects within. Of course, this is on the other side of the spectrum, very, very secure. So we might want to, for example, host a static website through our S3 bucket. So in this case here, allowing access would make more sense, right? So if I save changes, you see that we get an error here saying that we don't have permissions to do this. And the reason for that is because it realizes that this is extremely permissive. So in order to give access to every single object within this bucket, as in the case that I was stating of a static website being hosted on your S3 bucket, it would be much better to also at first enable that option. So I'm just going to duplicate the tab here. And once you go back to the permissions tab, one of the first things that shows up is this block public access setting, right? Right now it's completely blocked, and that's what's stopping us from saving our policy. We would have to go in here, unblock it, and save it, right? And it's also kind of like a double clutch feature. You have to confirm that just so you don't do that by accident, right? So now what you've effectively done is you've really opened up the floodgates to have public access to this bucket. It's something that can't be accidentally done. It's kind of like having to perform these two actions before the public access can be granted. Now, historically, this was something that AWS was guilty of, was making it too easy to have public access. So now we have this double clutch. Now that this is enabled or turned off, we can now save our changes here successfully. And you can see here that now it's publicly accessible, which is a big red flag that perhaps this is not something that you're interested in doing. Now, if you're hosting a public website and you want everybody just to have read access to every single object in your bucket, yes, this is fine. However, please make sure that you pay very close attention to this type of access flagged over here on the console. So congratulations, you just got introduced to your first bucket policy, a permissive one, but at least now you know how to go through that graphical user interface through the policy generator and create them and paste them inside your S3 bucket policy pane. So let's continue on with data encryption. So any data that you place in S3 bucket can be encrypted at rest very easily using an AES 256 encryption key. So we can have server-side encryption. We could have AWS handle all the encryption for us, and the decryption will also be handled by AWS when we request our objects later on. But we could also have client-side encryption where we, the client that are uploading the object, have to be responsible for also passing over our own generated key that will eventually be used by AWS to then encrypt that object on the bucket side. Of course, once that happens, then the key is discarded, the client key is discarded, and you have to be very mindful that since you've decided to handle your own encryption, client-side encryption, that if ever you lose those keys, well, that data is not going to be recoverable in that bucket on the AWS network. So be very careful on that point. We can also have a very useful feature called versioning, which will allow you to have a history of all the changes of an object over time. So versioning sounds exactly how it's named. Every time you make a modification to a file and upload that new version to S3, it will have a brand new version ID associated with that. So over time, you get a sort of stack of a history of all the file changes over time. So you can see here at the bottom, you have an ID with all these ones, and then an ID with 121212. So eventually, if ever you wanted to revert back to a previous version, you could do so by accessing one of those previous versions. Of course, versioning is not an option that's enabled by default. You have to go ahead and enable that yourself. It is an extremely simple thing to do. And so there may be a situation where you already have objects within your buckets and you only then enable versioning. Well, versioning would only apply to the new objects that would get uploaded from the point that you enabled versioning. The objects that were there before that point will not get a specific version number attached. In fact, they will have a sort of null marker version number that will get attached to them. It's only after that you modify those objects later on and upload a new version that they will get their own version numbers. So right now, what we're going to be doing is a lab on actual versioning. So let's go ahead and do that right now. In this lab, we're going to see how to enable versioning in our buckets. Enable versioning is very easy. We're simply going to click on our bucket, go into properties, and there is going to be a bucket versioning section. We're going to click on edit and enable it. Once that's done, any new objects that are uploaded to that S3 bucket will now benefit from being tracked by a version number. So if you upload objects with the same file name after that, they'll each have a different version number. So you'll have version tracking, a history of the changes for that object. Let's actually go there and upload a new file. I'll upload one called index.html. So we're going to simulate a situation where we've decided we're going to use an S3 bucket as the source of our static website to deploy one. And in this index.html file, if you take a look right now, let's take a look at what's in there. You can see that we have welcome to my website and we're at version 2. Okay, so if I click on this file right now and I go to versions, I can clearly see that there's some version activity that's happening here. Okay, we have here at 1456, which is the latest one is on the top, the current version, we have a specific version ID. And then we have a sort of history of what's going on here. Now, I purposely enabled versioning before and then tried to delete versioning or disable versioning. But here's the thing with versioning. You cannot disable it fully once it's enabled. You can only suspend it. Right? Now, suspending means that whatever version numbers those objects had before you decided to suspend it will remain. So you can see I have an older version here that has an older version number. And at this point here, I decided to suspend versioning. And so what it does, instead of disabling the entire history, it puts what's called a delete marker. Okay? You could always roll back to that version if you want. Now, in the demonstration, when we started it together, I enabled it again. So you can see this is actually the brand new version number as we did it together, but you don't lose the history of previous versioning if ever you had suspended it before. So that's something to keep in mind, right? And it'll come up in the exam where they'll ask you, can you actually disable versioning once it's enabled? And the answer is no, you can only suspend it and your history is still maintained. Now, we have that version there, and let's say I come to this file and I want to upgrade this, I don't know, I say version 3, right? And now what's going to happen is if I click on this version, just as the current one with version 2, and I open this, we should see version 2, which is fine. That's expected. If we go back to our bucket and upload that new version file that has version 3 in there, the one I just modified, we should now see in that index.html file a brand new version that was created under the versions tab. And there you go, 1458, just 2 minutes after. You can see here we have a brand new version ID, right? And if I open this one, you can see version 3. So now you have a way to enable versioning very easily in your buckets. And you also have seen what happens when you want to suspend versioning, what happens to the history of those versions files before. Just to actually go back here to the properties where we enabled versioning in the first place, if I want to go back in here and disable it, like I said, you can't disable, you can only suspend. And that's where that delete marker gets placed, but all your previous versions retain their version ID. So don't forget that, because that will definitely be a question on your exam if you're interested in taking the certification exam. So congratulations, you just learned how to enable versioning. Let's move on to cross-region replication, or CRR as it is known. There will be many times when you find yourself with objects in a bucket and you want to share those objects with another bucket. Now that other bucket could be within the same account, could be within another account within the same region, or could be within a separate account in a different region. So there's varying levels of degree there. The good thing is all of those combinations are available. So CRR, if we're talking about cross-region replication, is really about replicating objects across regions. Something that is not enabled by default, because that will incur a replication charge because it's syncing objects across regions. Of course, you are spanning a very wide area network in that case, so there is a surcharge for that. Now, doing so is quite simple to do, but one of the things that we have to be mindful of is to give permissions for the source bucket, which has the originals, to allow for this copying of objects to the destination bucket. So if we're doing this across regions, of course, we would have to come up with IAM policies, and we would also have to exchange credentials in terms of IAM user credentials, in terms of account IDs and the such. We're going to be doing a demonstration in the same account, in the same region, but largely this would be the same steps if we were going to go cross region. So this is something you might find yourself doing if you want to share data with other entities in your company. Maybe you're a multinational and you want to have all your log files copied over to another bucket in another region for another team to analyze, to extract business insights from. Or it might just be that you want to aggregate data in a separate data lake in an S3 bucket in another region, or in like I said, it could be even in the same region or in the same account. So it's all about organizing, moving data around across objects, across these boundaries. And let's actually go through a demonstration and see how we can do CRR. Let's now see how we can perform cross-region replication. We're going to take all the new objects that are going to be uploaded in the Simplilearn S3 demo bucket, and we're going to replicate them into a destination bucket. So what we're first going to do is create a new bucket, okay? And we'll just tack on the number 2 here. And this will be our destination bucket where all those objects will be replicated to. We're going to demonstrate this within the same account, but it's the exact same steps when doing this across regions. One of the requirements when performing cross-region replication is to enable versioning. So if you don't do this, you can do it at a later time, but it is necessary to enable it at some point in time before coming up with a cross-region replication rule. All right, so let me create that bucket. And now after the bucket is created, I want to go to the source bucket and I want to configure under the Management tab here, a replication rule. So I'm going to create a replication rule, call it Simplilearn rep rule. And I'm going to enable this right off the bat. The source bucket, of course, is the Simplilearn S3 demo. We could apply this to all objects in the bucket or perform a filter once again. Let's keep it simple this time and apply to all objects in the bucket. Of course, caveat here, this will only now apply to any new objects that are uploaded into this source bucket and not the ones that are already pre-existing there. Okay. Now, in terms of a destination bucket, we want to select the one we just created. So we can choose a bucket in this account, or if we really want to go cross-region or another account in another region, we could specify this and put in the account ID and the bucket name in that other account. So we're going to stay in the same account. We're going to browse and select the newly created bucket. And we're also going to need permissions for the source bucket to dump those objects into the destination bucket. So we can either create the role ahead of time, or we can ask this user interface to create a new role for us. So we'll opt for that, and we'll skip these additional features over here that we're not going to talk about in this demonstration. We're just going to save this. So that will create our replication rule that is automatically enabled for us right now. So let's take a look at the overview here. You can see it's been enabled. Just to double check, the destination bucket is the demo 2. We're talking about the same region. And again, here we could opt for additional parameters like different storage classes in the destination bucket that object is going to be deposited in, et cetera, et cetera. For now, we just created a simple rule. Now, if we go back to the original source bucket, which we're in right now, and we upload a new file, which will be a transactions file in a CSV format, once this is uploaded, that cross-region replication rule will kick in and will eventually, right, it's not immediate, but will eventually copy the file inside the demo 2 bucket. Now I know it's not there already, so what I'm going to do is pause the video and come back in 2 minutes, and when I click on this, the file should be in there. Okay, so let's now double check and make sure that object has been replicated. And there it is, been replicated as per our rule. So congratulations, you just learned how to perform your first same account S3 bucket region replication rule. Let's now take a look at transfer acceleration. So transfer acceleration is all about giving your end users the best possible experience when they're accessing information in your bucket. So you want to give them the lowest latency possible. You can imagine if you were serving a website and you wanted people to have the lowest latency possible, of course, that's something that's very desirable. So in terms of traversing long distances, if you have your bucket that is in, for example, the US East 1 region in the United States, in the Virginia region, and you had users, let's say in London, that want to access those objects, of course, they would have to traverse a longer distance than users that were based in the United States. And so if you wanted to bring those objects closer to them in terms of latency, then we could take advantage of what's called the Amazon CloudFront Delivery Network, the CDN network, which extends the AWS backbone by providing what's called edge locations. So edge locations are really data centers that are placed in major city centers where our end users mostly are located, more densely populated areas, and your objects will be cached in those locations. So if we go back to the example of your end users being in London, well, they would be accessing a cached copy of those objects that were stored in the original bucket in the, for example, US East 1 region. Of course, you will get most likely a dramatic performance increase by enabling transfer acceleration. It's very simple to enable this. Just bear in mind that when you do so, that you will incur a charge for using this feature. The best thing to do is to show you how to go ahead and do this. So let's do that right now. Let's now take a look at how to enable transfer acceleration on our Simplilearn S3 demo bucket. By simply going to the Properties tab, we can scroll down and look for a heading called Transfer Acceleration over here, and very simply just enable it. So what does this do? This allows us to take advantage of what's called the Content Delivery Network, the CDN, which extends the AWS network backbone. The CDN network is strategically placed into more densely populated areas, for example, major city centers. And so if your end users are situated in these more densely populated areas, they will reap the benefits of having transfer acceleration enabled, because the latency that they will experience will be severely decreased. So their performance is going to be enhanced. If we take a look at the speed comparison page for transfer acceleration, we can see that once the page is finished loading, it's going to do a comparison. It's going to perform, first of all, what's called a multi-part upload, and it's going to see how fast that upload was done with or without transfer acceleration enabled. Now, this is relative to where I am running this test. So right now I'm actually running it from Europe. So you can see that I'm getting very, very good results if I would enable transfer acceleration and my users were based in Virginia. So of course, now I have varying differences in percentage as I go closer or further away from my region where my bucket or my browser is being referenced. So you can see here, United States, I'm getting pretty good percentages. As I go closer to Europe, it gets lower, of course, but still very, very good. Frankfurt, again, this is about probably the worst I'm going to be getting here since I'm situated in Europe. And of course, as I go look more towards the Asian regions, you can see once again it kind of scales up in terms of better performance. So of course, this is an optional feature. Once you enable it, as I just showed over here, this is a feature that you pay additionally for. So bear that in mind. Make sure that you take a look at the pricing page in order to figure out how much this is going to cost you. So that is it. Congratulations. You just learned how to simply enable transfer acceleration to lower the latency from the end user's point of view. We're now ready to wrap things up in our conclusion and go over at a very high level what we just spoke about. So we talked about what S3 is, which is a core service, one of the original services published by AWS in order for us to have unlimited object storage in a secure, scalable, and durable fashion. We took a look at other aspects of S3 in terms of the benefits. We mainly focused on the cost savings that we can attain in S3 by looking at different storage classes. Now, of course, S3 is industry recognized as one of the cheapest object storage services out there that has the most features available. We saw what goes into the object storage in terms of creating first our buckets, which are our containers, high-level containers in order for us to store our objects in. Again, objects are really an abstraction of the type of data that are in there, as well as the metadata associated with those objects. We took a look at the different storage tiers, the default being the standard, all the way till the cheapest one, which is the Glacier, which are meant for long-term archived objects. For example, log files that you may hold on to for a couple of years, may not need to access routinely, and will have the cheapest pricing option by far. So we have many pricing tiers, and if you want to transition from one tier to the next, you would implement a lifecycle policy or use the intelligent tiering option that can do much of this for you. We took a look at some very interesting features, starting from the lifecycle management policies that we just talked about, all the way to versioning, cross-region replication, and transfer acceleration. So with this conclusion, you are now ready to at least start working with S3. Hello everybody, my name is Kent, and today we're going to be covering AWS Identity and Access Management, also known as IAM, tutorial by Simplilearn. So these are the topics which we'll be covering today. We'll be defining what AWS security is, the different types of security in AWS, what exactly is identity and access management, the benefits of identity and access management, how IAM works, its components, its features, and at the end, we're going to do a great demo on IAM with multi-factor authentication and users and groups. So without any further ado, let's get started. So let's get started with what is AWS security. Your organization may span many regions or many accounts, and you may encompass hundreds if not thousands of different types of resources that need to be secured. And therefore, you're going to need a way to secure all that sensitive data in a consistent way across all those accounts in your organization while meeting any compliancy and confidentiality standards that have to be met. So for example, if you're dealing with healthcare data or credit card information or personal identification information like addresses, this is something that needs to be thought out across your organization. So of course, we have individual services in AWS, which we will explore in this video. However, in order to govern the whole process at an organizational level, we have AWS Security Hub. Now, AWS Security Hub is known as a CSPM, which stands for a Cloud Security Posture Management Tool. So what does that really mean? Well, it's going to encompass, like I said, all these tools underneath the hood in order to bring a streamlined way for you to organize and adhere to these standards across your organization. It'll identify any misconfiguration issues and compliance risks by continuously monitoring your cloud infrastructure for the gaps in your security policy enforcements. Now, why is that important? Well, these misconfigurations can lead to unwanted data breaches and also data leakages. So in order to govern this at a very high level, like I said, we need to incorporate AWS Security Hub that will automate and manage all these underlying services for us in order to perhaps take automated action. We call that remediary actions. And you can approve these actions manually, or you can automate those actions as you see fit across your organization. So let's delve a little bit deeper into what is AWS security, and then we'll start looking individually at some of these services. And so our organization has special needs across different projects and environments. So of course, the production, development, test environments, all are going to have their own unique needs. However, it doesn't matter which project or which business unit we're talking about and what are their storage backups needs. They should all be implemented in a concise, standardized way across your organization to meet that compliancy we were just talking about. So we want to automate all these tedious manual tasks that we've been doing, like ensuring that perhaps our buckets in S3 are all encrypted or all our EBS volumes are encrypted. And we want to have an automated process in place in order to give us time on other aspects of our business, perhaps our application development, to bring better business value. And that allows us to grow and innovate the company in a way that's best suited for it. So let's take a look at the different types of AWS security. Now, there are many different types of security services out there. However, we're going to concentrate primarily on IAM in this video tutorial. So I like to think of IAM as the glue between all AWS services, because by default, we don't have permission for any one service to communicate with another. So let's just take, for example, an EC2 instance that wants to retrieve an object from S3. Well, those two services could not interact unless we interacted with IAM. So something that's extremely important to learn. And by the end of this video tutorial, you'll be able to understand what IAM is. We have Amazon Guard Duty here, which is all about logs. Basically aggregates all logs from, example, CloudTrail, which we still haven't talked about. It's at the end of this list over here. But instead of looking at CloudTrail individually, Guard Duty will actually take a look at CloudTrail will take a look at your VPC flow logs, and will take a look at your DNS logs and monitor that account and your network and your data access via machine learning algorithms. And it'll ID any threat where you can automatically remediate the workflow that you've approved. So for example, if you know of a malicious IP address that's making API calls, well, those API calls are registered in CloudTrail, right? So this machine learning algorithm will be able to detect that and take action. So this is really governed at a higher level than you having to individually inspect all your DNS logs, flow logs, and CloudTrails individually and take action through some scripting fashion that you've come up with. So Guard Duty manages all that. We have Amazon Macy, which once again uses machine learning, but also uses pattern matching. Pattern matching can be used with matching kind of libraries that are already in place, or you can come up with your own pattern matching, and that's used to discover and protect your sensitive data. So for example, if you had healthcare data, also known as HIPAA compliancy, or credit card data that's lying around, well, Macy will discover it and will protect it. So as your data grows across your organization, that might be harder and harder to do in your own way. So Macy really facilitates discovering and protecting that, so you can concentrate on other things. AWS Config is something that kind of works in tandem with all the other services. It's able to continuously monitor your resources configurations and ensure that they match your desired configuration. So for example, maybe you state that your S3 buckets should be encrypted by default, all of them, or you want to make sure that your IAM user access keys are rotated. And if they're not, then take remediary action. So a lot of these automated remediary actions, right, are basically executed via AWS config. So you'll see the AWS config actually used by other services underneath the hood. And then you have CloudTrail. CloudTrail is all about logging every single type of API call that's made. So it'll always record the API call, who made it, from what source IP, the parameters that were sent with the API, the response, all that data, which is really a gold mine for you to investigate if there's any security threat. And again, this trail over here, and there can be many, and there's lots and lots of data generated by these trails, can be analyzed by these other services, specifically Guard Duty here, that automates that process so you don't have to. So let's get to the next one, which is, what is identity and access management? So what is IAM? Like I said, IAM is the glue between all AWS services. It will allow those services to communicate with each other once you put IAM into place. The other thing is it allows us to manage our AWS users, which are known as IAM users, and group them together into groups to facilitate assigning and retrieving or removing permissions from them instead of doing it on an individual scale. So of course, if you had 200 IAM users and you wanted in one shot to add a permission to a group that contained 200 IAM users, well, you can do that in one operation instead of 200. Now we do have a distinction between IAM users and end users. End users use applications online, whereas IAM users are your employees in your organization that are interacting directly with AWS resources. So for example, an EC2 instance would be a resource that, let's say, a developer would be interacting with. And traditionally, those are resources that are used full-time from 9 to 5, let's say, 5 days a week, 365 days a year, okay? Now, sometimes those users have to have elevated permissions for a temporary amount of time, and that is more suited for a role. And that'll eliminate the need to create separate accounts just for, type of actions that are needed for, let's say, an hour a month or 2 hours a week or something like that. Something like backing up an EC2 instance, removing some files, doing some cleanups. Traditionally, you don't have those permissions as a developer, but you can be given temporary permissions to assume this role. So it's kind of like putting a hat on your head and pretending you're somebody that you're usually not for a temporary amount of time. Once you take off the hat, you go back to being your old, boring IAM user self, which doesn't have access to performing backups or cleanups and stuff like that. So the roles interact with a service called a secure token service, which gives us specific keys, specifically an access key, a secret key, much like a username and password. And then we have a token key, which only gives you access to this role, this elevated permission, for 1 to 12 hours. So we'll talk more about roles as we go on through this video tutorial, but it's important that you at least remember at this point, even if you don't know all the details, that roles have to do with temporary permissions, elevated permissions. So what are the benefits of IAM? Well, across our organization, we are going to have many accounts, and like I said, hundreds if not thousands of resources. So scalability is going to be an issue if we don't have a very high level visibility and control over the entire security process. And once we have a tool like, for example, Security Hub, which we saw on the first slide, we can continuously monitor and maintain a standard across our organization. So very, very important to have that visibility. And we do when we integrate with AWS Security. Now, we also need to eliminate the human factor, right? So we don't want to manually put out fires every single time. Of course, there will be times when something new occurs that we've never seen before that will be needed. However, once an occurrence happens and reoccurs, we can obviously come up with a plan to remediate the action. So once we automate, we can definitely reduce the time to fix that reoccurring error, or it could be a new error that we don't have to interact with because we're using machine learning algorithm services like I was talking about, like GuardDuty or Macy. And we can really reduce the risk of security intrusions and data leakage and such by using IAM to facilitate this. Of course, you may have many compliance needs. You may be dealing with applications that use healthcare data or credit card information for payments, or you might be dealing with a government agency, let's say in the US, that has certain compliancy requirements that needs assurances that if their data is stored on the cloud, that you're still following the same compliance controls that you were, let's say, on premise. So we have a very, very long list of compliance requirements that each AWS service adheres to. And you can go on the AWS documentation online and you could figure out if, for example, DynamoDB is compliant with HIPAA compliancy. And it is. And so you can be sure that you can use that. So AWS itself has to constantly maintain these compliancy controls in place, and they themselves have to pass all these certifications, and that gets passed on to us. So much less work for us to implement these compliance controls. We can just inherit them by using AWS's security model by IAM. And last but not least, we can build the highest standards for privacy and data security. Now, having all this on our own on-premise data center poses security challenges, especially physical security challenges. You have to physically secure the data center. You might have security personnel that you need to hire, 24/7 camera surveillance, et cetera, et cetera. So just by migrating to the cloud, we can take advantage of AWS's global infrastructure. They're very, very good at building data centers. That's part of their business, and securing them. So of course we have a shared security model in place. However, you can rest assured that at least as the lowest common denominator, physical security has been put into place for us. Again, as other services are used, more managed services or more higher end services used in AWS, more and more of that security model will be AWS's responsibility and less yours. We will always have a certain type of responsibility for our applications, but we can again use these high-level services to ensure that our ability to encrypt the data at rest and in transit are always maintained by coming up with specific rules that need to be adhered to. And if those rules are not adhered to, then we have remediary actions that take place in order to maintain, again, that cross-account or organizational-wide security control. Okay, so lots of benefits of using IAM. And let's now take a look at exactly how IAM works and delve deeper into authentication and authorization. So there are certain terms here that we need to know about. One of them is principal. Now, principal is nothing more than an entity that is trying to interact with an AWS service, for example, an EC2 instance or an S3 bucket. Now, that could be a user, an IAM user. It could be even a service, or it could be a role. So we're going to take a look how principals need to be specified inside IAM policies. Authentication. So authentication is exactly how it sounds. Who are you? Could be something as simple as username and password, or it could involve an email address. Example, if you're the root user of the account when you're creating the account for the very first time. Other normal users will not need to log in with their user email. It'll only be the root user that needs that. You could also have developer type access, which needs access, let's say, via command line interface or a software development kit, also known as an SDK. Now, for those kind of access points, we're going to need access keys and secret keys, or public-private keys, let's say, if you want to even authenticate and log in through SSH to an EC2 instance. So there are many different types of authentication that we could set up when creating IAM users based on what kind of access they need. Do they just need access to the console? Do they need access to just services in terms of as a programmatic need? So those are different types of authentication. And then we have the actual request. Now, we could make a request in AWS through various ways. We're going to be exploring that via the console, the AWS console. However, every button you click, every drop-down list you select, that invokes an API call behind the scenes. So everything goes behind a centralized, well-documented API. Every service has an API. So if you're dealing with Lambda, let's say, well, Lambda has an API. If you're dealing with EC2, EC2 has an API. Now, you could interact with that API, like I said, via the console indirectly. You could use a command line interface. You can use an SDK for your favorite programming language like Python. So all of them get funneled through, all your requests get funneled through an API. But that doesn't mean you're allowed to do everything just because we know who you are and you have access to some keys, let's say, to make some API calls. You have to be authorized in order to perform certain actions. So maybe you're only authorized to communicate with DynamoDB, and also maybe you're only authorized to perform reads and not writes. So we can get some very fine-grained authorization through some IAM policies in order to control not only who has access to our AWS, but what they're allowed to do. So very fine-grained actions, read actions, write actions, both, maybe just describe or list some buckets. So depending on the AWS user that's logged in, we can control exactly what actions, because every API has fine-grained actions that we can control through IAM. And of course, many different types of resource. When we're coming up with these policies, all these actions can be grouped into resources. So perhaps we can say, well, this user only has access or read-only access to S3, specifically these buckets, and can write to DynamoDB table, but cannot terminate or shut down an EC2 instance. So all these kind of actions can be grouped into resources on a per resource basis based on the kind of role you have in the projects or in the company. So now let's take a look at the components of IAM. We've already seen that we can create IAM users and that how they are different than your normal end users. Now those entities represent a person that's working for an organization that can interact with AWS services. And some of those permissions that we assign through what's called identity-based policies to such a user will have permissions, for example, that are always necessary every time that they're logged in. So perhaps this user Tom always needs access to the following services over here, for example, an RDS instance or an S3 bucket, et cetera, et cetera. And sometimes they will need temporary access to other services, for example, DynamoDB. So in those cases, there would be a combination of normal IAM policies assigned to the user and certain assume role calls done at runtime in order to acquire this temporary credential, elevated permission. There is also the root user, which is different than your typical super user administrator access. There are some things that a root user can do that an administrator access cannot. For example, a root user, first of all, logs in with their email address and can also have the option to change that email address, something that is very tightly coupled to the AWS account. So you cannot change the email address with an administrator account. The other thing a root user can do is they can change the support contract. They can also view billing information or taxes information, VAT information, for example. So the best thing to do, the best practice is that once you've created your AWS account, you are obviously the root user. The best thing to do is to enable multi-factor authentication, store away those keys in a secure location, and your first administrative task should be to create an administrator super user, from which that point on you will log in as only an administrative user, and you will create other type of administrative users, and those administrative users will create other IAM users. So never log into your AWS account as a root user unless you need to access that specific functionality that I said that is over and above a super user administrator account. So here we have a set of IAM users, and we could assign to them directly IAM policies, which give them access to certain services. However, the best practice is to create groups, which is just a collection of IAM users. And suppose we have a developer group and a group of security administrators. Of course, we could assign different types of policies to that group, and every user that is assigned to the developer group will inherit those IAM permissions. Makes it much easier to manage your IAM users this way. And for the fact that also you can have users that can be assigned to groups, as you can see here, but what's not shown here that is possible as well is you could have a user that is part of two groups at the same time. The thing that you cannot have, though, is the notion of subgroup. So I can't extend this group and create a smaller group of developers out of this big group here. So we don't have hierarchical groups, but we do allow users to partake in different groups at the same time. So they will inherit those permissions, those IAM policy permissions from, for example, if user A was part of developers and user A was part of security, they would inherit these two policy statements over here. Now, there is another type of IAM policy, and that is called a resource-based policy. So resource-based policies are not attached directly to, for example, users, but they're attached more to resources like an S3 bucket, for example. And so when you have such a case, a user group can't be designated as a principal to a group. That's just one of the restrictions. However, there are other ways to get around that. As I said, when you think of an IAM role, I want you to think that these are temporary credentials that are acquired at runtime and are only good for a specific amount of time. Now, an IAM role is really made up of two components. We have what's called a trust policy. So who do you trust to assume this role? Who do you trust to even make an API call to assume the role? After that, we have an IAM policy. Once you've been trusted to assume the role and you get those temporary tokens, what are you allowed to do? Maybe you're allowed to have read-write access to the DynamoDB. So here we have no long-term credentials that are connected to role. You do not assign a role to a user. The user or service will assume the role via API call via the Secure Token Service, STS. And with those temporary credentials, we'll then be able to access, for example, an EC2 instance if the IAM policy attached to the IAM role says that you can do so. So your users and your applications perhaps running on an EC2 instance and the AWS services themselves don't normally have access to the AWS resources, but through assuming a role, they can dynamically attain those permissions at runtime. So it's a very flexible model that'll allow you to bypass the need to embed security credentials all over the place and then have to maintain those credentials and make sure they're rotated and they're not acquired by anybody trying to find a security hole in your system. So from a maintenance point of view, they're really an excellent tool to use in your toolbox, your security toolbox. So let's take a look at the components of IAM. We have the IAM policy over here, which is really just a JSON document. And that JSON document will describe what this user can do if it's attached directly to it, or if the IAM policy is attached to the group, whatever user is attached to that group will also have the same policy inherited. So these are more long-term credentials in terms of, or permissions rather, that are attached to your login for the duration of your login, whereas roles are, as we've already stated, temporary. And again, once you've established a trust relationship, then we can assign a policy, for example, a policy that gives you only read-only access to a CloudTrail to a role. Now, it's up to the user to assume that role either through the console or through some programmatic means. Whichever way is performed, the user will have to make a direct or indirect call to STS for the assume role call. Now, these permissions are examined by AWS when a user submits a request. So this all happens at runtime dynamically. So when you change a policy, it will take effect pretty much immediately as soon as the user makes the next request. That new security policy, whether you've just added or removed the permission, will take immediate effect. So what we're going to do now is just really quickly go to the AWS console and actually show you how an IAM policy looks like. So I've just logged into my AWS management console, and if I search for identity and access management, it should be the first one to show up. I'll just click on that. And I want to show you actually how these IAM policies look like. If you go to the left-hand side here, there's an entry for policies, and there are different types of policies that we can filter out. So let's filter them out by type. We have customer managed, we have AWS managed, and more in line with job functions that AWS managed also. So we're going to take a look at AWS managed. All that means is that AWS has created and will actually update, maintain these pre-established and already vetted identity policies, IAM identity policies. So I could further down maybe look at all the S3 policies that are available, and we can see there are some that allows only read-only access. There are some that will give us full access. And there are, of course, other types here that we're not all going to explore, but let's just easily kind of take a look here at the full access. You can see it's just a JSON document. And of course, you cannot modify it since this is a managed policy. However, you can copy it and modify it. And in that case, it will become your own version of it. And so it'll be customer defined. And so when you go here and you do a filter, you can filter on your own customer managed policies. So over here, we are simply allowing certain actions, right? We talked about actions before that were based on API. So here we have an API that starts with S3. So this is for the S3 API. And instead of filtering out exactly specifically what API calls are there, we're basically saying all API calls. So star representing all API actions. And again, there is another category of S3 which deals with object Lambda and we are allowing all operations on that specific API as well. We could, if this was our own customer managed policy, actually scale down on which resource, which bucket, let's say, or which folder in a bucket this would apply to. But in this case, since this is a full access, we're basically being given permission to execute every single API action under S3 for all buckets. We're going to see in the lab or the demonstration at the end of this tutorial that I'm going to show you how to scale that down. Okay, so that's how an IAM policy looks like. And if you want to assign an IAM policy to a user, well, stay tuned for the demonstration at the end of the video tutorial. What's not at the end of the video tutorial is really how to create a role. So I'll show you what a role is here. Again, there's a whole bunch of roles already set up that we can go and take a look at here. But we can go and create our own role as well. And I might create a role, for example, that gives in EC2, let's choose EC2, access to S3. So if I click EC2 and click Next Permissions, I can actually assign the S3 permission right over here. It's just a policy, just like we took a look at. Obviously assign it a tag and review it. And I'm just going to call this my EC2 role to S3. Create the role. And because I selected EC2 as a service, it automatically will include that in the trust policy. So now when I go and I create an EC2 instance, I can attach this role to that EC2 instance, and that EC2 instance will automatically be able to, if we're using the Linux 2MI, let's say, have access to, or full admin access to, any S3 bucket in the AWS account. So let's go take a look at where we would actually attach that role on the EC2. So when you're creating an EC2, let's just say we go here, we say launch an EC2 instance, and we'll pick this AMI over here because it'll already include the packages necessary to perform the assume role call to STS for us, so we won't have to code that. And we don't have to embed any credential keys in order to get this running, which is really good, which is the whole point of what I'm doing, because by assuming a role, I don't have to manage that. And I'm just going to pick the free T2 micro. And it is here, once you pick whatever you need, whatever VPC and whatnot, that you come to the IAM role and you select the role to be assumed dynamically. Now I have a whole bunch of them here, but this is the one that I had created here, my EC2 role to S3. And if I go and I launch this EC2 instance, and then I had an application, let's say, that needed to contact S3, or even if I went on the command line of the EC2 instance, I would be able now to communicate with the S3 service, because they would use, they being AWS, would actually use this role to perform an assume role call to get those temporary STS tokens for me, which will then allow me to access my IAM policy, which gives me full access to S3. And off I go. So this is a great way, like I said, to avoid having to administrate any embedded keys in this EC2 instance. And I could take this role away at any time as well. So there you have it, a little demonstration on how to create a role, how to attach it to an EC2 instance, and also how managed and customer managed policies look like in IAM. Of course, there is also the fact that we have multiple accounts, and so we could assign a policy that will also allow a user in another account access to our account. So cross-account access is something that's very well needed, and also is a feature of IAM. So when you need to share access to resources from one account to another in your organization, we are in need of an IAM policy to facilitate that. So also roles can come into play here for that. By also assigning granular permissions, we can make sure that we implement the concept or the best practice of the least privilege access. And also we have secure access to AWS resources, because by default, again, we have the principle of least privilege, and no service can communicate with another until we enable it via IAM. So very, very secure out of the box. Of course, if you want to add an additional layer of authentication, of security, we have multi-factor authentication rather, and that'll allow you to ensure through a hardware device, perhaps let's say a hardware token device, or your cell phone that has some software that generates a code that will allow it to identify you are actually the person that is typing the username and password, and not somebody who's actually stolen your username and password. So at the end of this video tutorial, we will show you, or I will show you how to enable that. And of course, identity federation is a big thing, where your users may have been defined outside of AWS. You may have thousands of users that you've already defined, let's say in an Active Directory or in an LDAP environment on-prem, and you don't want to recreate all those users again in AWS as IAM users. So we can tie in, we can link the users, your user database that's on-prem, or even users that have been, your user account that's been defined, let's say on a social site like Facebook or Twitter or Google, and tie that into your AWS account. And though there is an exchange of information, there is a setup to do, but at the end of the day, it is either a role in combination with an IAM policy that will allow to map what you're allowed to do once you've been authenticated by an external system. So this has to do with perhaps like I said, LDAP or Active Directory, and you can tie that in with AWS SSO. There are many different services here that can be leveraged to facilitate what we call identity federation. And of course, IAM itself is free. So it's not a service per API request. AWS is very concerned to put security first, and so IAM is free. It's just the services that you use. For example, if you're securing an EC2, of course, that EC2 instance falls under the current pricing plan. So of course, compliance, like I mentioned, is extremely important, making sure that it's business as usual in the cloud. And so, for example, if you were using the payment card industry data security standard to make sure that you're storing and processing and transmitting credit card information appropriately in order to do your business, well, you can be assured that the services you use in AWS are PCI DSS compliance. And there's many, many other types of compliance that AWS adheres to as well. So password policies, of course, are important. By default, we do have a password policy in place, but when you go to the IAM console, you're free to update that password policy, make it more restrictive based on whatever policy you have at your company. So many features. And so I think we're ready now to go into a full demonstration, and I will show you how to incorporate IAM users, groups, and also multi-factor authentication. So get ready, let's do it. I'm going to demonstrate now how to attach an S3 bucket policy via IAM. I've already created a bucket called Simplilearn S3 IAM demo. And what we're going to do is we're going to attach a bucket policy right over here. We're going to have to edit it, of course. And the basis of the demonstration will be to allow a user that has MFA, so multi-factor authentication, set up to have access to the contents of a folder within this bucket. So of course, now I have to create a folder. Just simply call it folder 1. Create that folder. And now I'm going to go into that folder and upload a file so that we can actually see this in action. So I'm going to select a demo file that I prepared in advance called demo file user2 MFA. I'm going to upload that. All right. And now what's going to happen is eventually when I create our 2 IAM users, one will have access to view the contents of this file, which should look like something very simple. If I open this up within the console, you'll be able to see, well, it's pretty small right now. I'll make this a little bit bigger, of course. it says this is a demo file which user2-MFA should only be able to have access to. So what's left to do now is to create two users, one called user1 and one called user2-MFA, and that's what we're going to do right now. Let's head over to IAM, Identity and Access Management. And on the left-hand side here, we're going to click on users. You can see here I don't have much going on. I just got an administrator user, so I want to create two new users. We'll start with one at a time. So one called user1. Now by default we have the principle of least privilege, which means this user is not allowed to do anything unless we give them access to either the console right over here, which I will do right now, and also if they were a kind of programmatic user that needed access to specific keys in order to interact with the APIs via the command line interface or the software development kit, for example, if you were a Java developer. So in this case, that is not what I want. So I'm just going to assign console access, and I'm also going to create a default password for this user, but I will not allow them to reset it on the first login, just for demonstration purposes. Now over here, we have the chance to add the user straight to a group, but I'll only do that later on at the end of the demonstration. For now, I want to show you how to attach to this user an IAM policy, which will give them access to specific services. So if I type in S3 full access here, this is an administrative access to an S3 bucket. If you take a look at the JSON document attached or representing that IAM policy, you can see that it is allowing all API actions across S3, star, and also object Lambda across all buckets. And I say all buckets because the star represents all buckets. So it is a very broad permission, so be very careful when you're actually assigning this to one of your users. Make sure that they deserve to have such a permission. So I'm not going to assign any tags here, but I'm just going to review what I've done. You can see here I've just attached an S3 full access permission to this one user, and I'm going to create that user now. Of course, now's the time for me to download the CSV file, which will contain those credentials. If I don't do it now, I will not have a second chance to do this. And also to send an email to this user in order for them to have a link to the console and also some instructions. I'm not going to bother with that. I'm just going to say close. And now I have my user one. You can see here that it says none for multi-factor authentication. So I have not set anything up right now for them. And that's what I want to do for this second user that I want to create, called user2-MFA, or MFA rather. All right, so now I want to do the same exact thing as before. I'm going to assign a custom password. And I'm going to go through the same steps as we saw before. I'm going to attach an existing managed policy that AWS has already vetted for us. Review, create. Now, right now, they're exactly the same. So I have to go back to user 2 and set up multi-factor authentication. And to do that, you have to go in the Security Credentials tab. And you'll see here, assigned MFA device. We have not assigned any yet, so we're going to manage that right now. And we have the option to order and get an actual physical device that's uniquely made for performing multi-factor authentication. However, we're going to opt for the virtual MFA device, which is a software that we're going to install on our cell phones, let's say. So I can actually open this link just to show you the very many options that we have for that. They're right over here. I'm going to go with Google Authenticator. So go to the App Store on your Android device and you can download that. Of course, if you have an Android device. If not, you have other options for iPhone and other softwares for each one of those. So I'll let you do that. Once you've installed that software on your cell phone, you can come here and show the QR code. Now what that is going to do is you're going to need to go to your phone now, and I'm going to my phone right now as we speak, and I'm going to open up that MFA software, in this case the Google Authenticator, and I'm going to say there's a little plus sign at the bottom. I'm going to say scan QR code. I'm going to point my phone to this square code here, this QR code, and it's going to pick it up. I'm going to say add account. There's a little button there, add account, and it's going to give me a code. So I'm going to enter that code right now. So once I've entered the code, I have to wait for a second code, and that's because this code on the screen of my cell phone is going to expire. It's only there for about 20 to 30 seconds. Once that token expires, it refreshes the display with another token. So I have another token now. That's only good for a couple of seconds again. And now I'm going to say assign MFA. What this does is it completes the link between my personal cell phone and this user right now. So now that this has been set up, we can see we actually have an ARN to this device, which we are going to possibly need depending on how we write our policies. In our case here, I'm going to show you a way to kind of bypass having to put that. So now we've got those two users, one with an MFA device and another one without. Okay, so now the lab is going to be, or the demonstration rather, is going to be how do we allow user 2 MFA access to this file in folder 1 and not allow user 1. The distinguishing factor will be that user 2 has an MFA set up and user 1 doesn't. So based off of just that condition, that'll be the determining factor if they can view the file or not. So let's get back to S3 and actually create this IAM bucket policy and see how it's done. So back we are in our bucket, and now we have to go to permissions in order to set up this bucket policy. We're going to click on edit over here, and we're going to click on policy generator to help us generate that JSON file through a user interface. Of course, we're dealing with an S3 bucket policy. Now, what we're going to do is we're going to deny all users and services, so star. S3 is grayed out here because we selected S3 up here. We want to deny all S3 API actions. We're not going to go and selectively go down the list. The specific bucket and the folder. So in this case here, we're missing the Amazon resource name. So we have to go back here and we have to copy the ARN of our bucket, right? So we're going to copy that, come back, Control V, and we're going to, of course, have to specify the folder as well. So I'm going to just do /folder1, and then I'm also going to do /star for all the objects in that folder, okay? So here's the MFA condition that I want to add though, because we cannot assign the MFA condition up here. We have to say add conditions. Very powerful feature here. That's optional, but very powerful. We want to look for a condition that says Boolean if exists, or bool if exists, all right? So there's got to be a key value pair that exists, and there are many, but we're going to look for one that is specifically known as multi-factor authentication present. And we want to make sure that value is equal to false. So I'm going to add that condition, and then I'm going to add that statement. And I want to generate the policy just to show you now how that user interface has generated this JSON document for us that we're going to attach to our S3 bucket. What I want to do is I want to take this in its entirety, copy it, and go back to our S3 bucket that's just waiting for us to paste our policy in here. Okay, so let's see what's actually going on here. We've created a policy. Again, this policy could have any ID. It's just an ID that was given by the user interface. You could name that whatever you want. Of course, something that makes total sense. And then we have one or more statements, and then we only have actually one statement. And again, you can select any ID here. That was just auto-generated by the IDE. We're saying that all actions on the simple storage service, I say all again because of the star, are denied specifically on this resource, which is our bucket and the folder named folder1 and all the objects within that folder under the certain conditions. So the condition is if you have a Boolean value of false associated with a key called multi-factor authentication present, and it has to exist, okay? Then if that value is equal to false, you don't have access to the objects in this folder, which means that if you do have MFA set up, you will be allowed access to the contents of this folder. So if we assign this and apply this to all principals, which would encompass user1 and user2-MFA, then let me just apply this. That would mean that user1 would not be able to see the contents of our object inside folder 1, and user2-MFA would. So let's go take a look and log into, let's log out first, and then when we're going to log back in, we're going to log in as the individual user1 and user2-MFA and prove this is actually the case. So I am now logging back in as user1 that we created moments ago. And of course, if I, for example, go see a service like EC2, we don't have access to EC2. We've just given ourselves access to S3. So this makes total sense. We're just going to go see what we have access to, which is S3. Should be able to list and describe all the buckets there because we've been given pretty much administrative access. Now, if we go here to our created bucket and go inside folder 1 and want to actually open up this document, we can see now that that's not happening, okay? And that's because of that condition that is checking if we actually have a value of true for that MFA key that we specified, okay? So this is expected and this is exactly what we wanted. Now what we're going to do is we're going to log out once again, and we're going to do the same thing but with user2-MFA. Let me log back in. And then specify the new password we created. Now, of course, now I have an MFA code, right? Because I've set that up for user2. So back on my cell phone I go. I am opening up the Google Authenticator application, and I have in front of me a new Amazon Web Services code that is only good for, like I said, maybe 20 seconds. So it's a little nerve-wracking. If you're not good under pressure, you're going to choke. So I just entered the code, and I have to wait for that to actually work. Now, it looks like I actually didn't check off not to recreate the password. So unfortunately, I must have missed that check mark. So I wanted to kind of avoid this here. So I'm going to start over and create a brand new password. A little painful for demonstrations, but it's good for you guys to see how that actually looks like. So because I've set up my MFA device properly, I am able to log in after I enter that MFA code. And once again, if I go to EC2, now I haven't been given the permissions for EC2. I've only been given the permissions for S3. So nothing changes here. I'm going to go to S3. And I'm going to go into folder 1 of our bucket in question. And I'm going to see if I have access now to opening up and seeing the contents. And here I have the contents. This is a demo file which user2-MFA should only be able to have access to. So that worked. So now you guys know how to create a bucket permission policy that is also known as a resource policy because it's assigned to the resource, it's assigned to the bucket. And let me actually show it to you one last time. Here it is. And that'll only allow us to have access to the contents of folder 1 if we have multi-factor authentication set up in our account. So that's really good. The last thing I want to show you now is how to maybe create IAM users in a better way in terms of not having to assign over and over again the same permissions like you saw me do for user 1 and user 2 Of course, now I cannot do anything IAM. Why? Because I'm user 2. I don't have access to IAM. So once again, I'm logging out, and we're going to actually see the best practice in terms of how do I assign IAM policies to a group and then assign users to that group in order to inherit those permission policies. So let's get to it. Let's sign up first. So let us go back to IAM, and we're going to be creating our first group. We're going to simply create the button, or click on the button create group, and we'll come up with a group called testers. We have the ability to add existing users to this group. So we will add, for example, user 1 only to the testers group. And we can also add permissions to this group. So we're going to go here and add, for example, the EC2 full permissions, create group. And what's going to happen now, if we go take a look at testers, we can see we have that one user that we added, and we also have the permissions associated with that group. So this means now that any new users we create will automatically inherit whatever permissions the group has, which is really good for maintainability. So for example, let's say we were to create many new testers. So let's say user 3 over here. Now, of course, I'm going to have to go in this case through the same steps as I did before. I'm just going to remember this time not to forget to uncheck that. And instead of attaching policies directly, I'm going to say, well, I want to inherit the policy permissions that were assigned to the group. So I'm going to say this user is going to be part of the testers group. And of course, I'm just going to skip through the remaining repetitive tasks that I've already described. And this user 3 now is already going to have the permissions to access EC2 that they've gained through the group testers. Whereas if we go back to user 1, this user also has the permissions from the group, but has a unique permission added to itself. So in this case, you do have the option of doing that. You have the option of adding a permission over and above that is assigned to the group to yourself directly. So this is really good, adding permissions to groups when you have, of course, lots of users in your company, or in your organization. And instead of going to them and adding permissions after permission, you can centrally access this in one, or manage this in one place. So for example, if I go back to my roles, groups rather, in my testers, and let's say I forgot to add a permission to all the users in this group. So let's say there was 20 users attached to this group. Okay, I'm not going to bore you with creating 20 users. we have 2 now. That's good enough to show the demonstration. And let's say now I need to add another permission, right? So in this case here, I'm going to add a permission, for example, let's say based on DynamoDB, right? So I'm going to get full access to DynamoDB. I'm going to add that permission. And what's going to happen now is if I go back to my users, for example, user 3, I'm going to see that user 3 automatically has inherited that permission, and so has user 1. All right, show 2 more, and there they are. So in this case, it really allows for you to easily manage a lot of users in that group, because you can simply go to one place, which is the group, and add and remove policies as you see fit, and the whole team will inherit that. So it saves you lots of work, and that is the best practice. So there you have it, guys. You have learned in this demonstration how to create users, how to create groups, how to add users to groups and manage their policies in terms of best practice. And you've also learned how to attach to an S3 bucket a policy that allows you to permit access based off of if a user has multi-factor authentication set up. And we showed you how to actually set that up when creating an IAM user. So again, permissions tab is where this all happens. Hope you enjoyed that, put that to good use, and I'll see you in the next demonstration. So I hope you enjoyed that demonstration. We're just going to wrap things up in a summary and kind of see what was looked at throughout the tutorial. We first started with what is AWS security. We took a look at how important it was across our organization to maintain best practice and also standardize that practice across accounts organization. We took a look at the topmost services, in which we concentrated then after on IAM. And we took a look at what IAM was in terms of IAM users, groups, long-term credentials that are applied as IAM policies, and then the concept of a role. We took a look at the benefits of IAM and the actual terminology used with working with IAM. Of course, principal being an entity that is either a user or a service itself that can gain access to an AWS resources. And we actually saw the different types of authentication and what we can do to implement authorization via IAM policies and also through the use of roles. So we took a look how to organize our users into groups and what actually goes into acquiring a role through a demonstration. We took a look at how to actually create a role and attach that role to an EC2 instance. And then we took a look at the high-level features of IAM, which allowed us to either grant access to another IAM user from another group, implement multi-factor authentication like we just did in the demonstration, or ensure ourselves that we are following all the compliancy standards that have been adhered to by whatever project we're working on, and that AWS is there to support us. So
here we're going to talk about Amazon ECS, a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general, and then it uses a service called Docker. So we're going to understand what Docker is. And there are competitive services available for ECS. I mean, ECS is not the own and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. I mean, each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS. And how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy any application in the cloud. So it's not just deploying. You can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. You know, the same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users, the end user could be in the internet, the end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment. Here, most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is. So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application, which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, a lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now how is that possible? Now, those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that. Suddenly if there is an increase in demand, how do you meet that demand? Right? Let's say you have like 1,000 users. Suddenly the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering. You would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this. You have two physical hosts, joined together as a cluster. And ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases, you will be defining it. So schedule the placement of containers across your cluster. Let's say 2 containers want to interact heavily. You really don't want to place them in 2 different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through Management Console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. With containers, now that worry is already taken away, because we can create an pretty exact environment. The one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that I was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it. You're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there. Right? So no compiling again, no relaunching the application. Simply pack all your code in a Docker container image and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies. You'll be packing the code. You'll be packing the framework. You'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's a highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume, and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. Its security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. Now, one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes, right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more container in it, so to best use those resources. In EC2, straightforward, you can just launch one application. But when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails, and that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this: in many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there, right? This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers, because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already, and it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service. And it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers. And then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running? And any additional software do we need? So those questions gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR. And there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation. ECS integrates well with VPC. And this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are two availability zones here. They can actually run across availability zones. And ECS has got two modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it, because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, Elastic network interface card, separate Elastic network interface card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks that we discussed, the tasks has two components. You see task right here. So they have two components. We have ECS container instance and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance, and it also provides the status of the running containers. Kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. Right? So container agent, when we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then Elastic Network Interface Card is a virtual interface network that can be connected to an instance in VPC. So in other words, Elastic Network Interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances. It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And this cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. They make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is a TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS, ECS was the only service that they can immediately adapt to. And because in Abima TV the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it, along with the benefits that ECS provides. Previously they had to do a lot of work, but now ECS does it for them. Right. Similarly, Remind and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy Docker container on ECS is, first we need to have an AWS account, and then set up and run our first ECS cluster. So in our lab we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5, is it 10, or is it just 1 running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers, and what port number you want to allow and you don't want to allow, who gets access, who shouldn't get access, and what's the IP that you want to allow and deny requests from, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it an backup job? Is it a web application? Is it an data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure your cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and a bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, and let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create cluster. This is our Fargate, and this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right, this gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then a service, and finally the cluster. It's a 4-step process. So in container definition, we define the image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me, and it's not a heavy application, so 0.5 gigabit of memory is enough. And again, it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it, and because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request. And there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it. And I'm going to use some bash commands to create an HTML page, right? This page says that, Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create, right? Index.html. So I'm going to create and put it in an appropriate location, so those pages can be served from the container, right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs, and these are the places where they get stored. That's not the focus as of now, right? So I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC. And then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit, and the task CPU is 0.25 virtual CPU. Name of the service: is it a batch job? Is it an a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's our security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80, right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer, and port 80 receives information on port 80 HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? Cluster name can be Simplilearn ECS demo. Next, we're done, and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC and it's creating 2 subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes. So we just need to be patient and let it complete its creation. And once this is complete, we can simply access these servers using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository. This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. All right, let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, right? IP of that container, right? And it says it's running, it was created at such and such time and started at such and such time. And this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS demo, right? And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here, because remember, this is Fargate. You're not managing any ECS instance, right? So that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2, and then under EC2 I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser, and now it's accessible through the load balancer URL. Right now this URL can be mapped to other services like DNS. This URL can be embedded in any of your application if you want to make that application connect with this container. Now, using IP is not all that advisable, because these containers can die and then a new container gets created, and when a new container gets created, it gets a new IP, right? So hardcoding IP is hardcoding dynamic IPs are not advisable. So you would be using load balancer and putting that URL in that application that you want to make it interact with this container instance. It was a wonderful experience in walking you through this ECS topic, and in here we learned about what AWS is and why we're using ECS, and what is ECS in general, what is Docker in specific, and we also learned about the advantages of ECS, the architecture, the different components of ECS, and how ECS works when they're all connected together. And we also looked at the companies that use ECS and their use cases, and finally a lab, how we can launch ECS Fargate through the portal. I'm very glad to walk you through this lesson about Route 53. So in this section, we are going to talk about basics of AWS, and then we're going to immediately dive into why we need Amazon Route 53. And then we're going to expand and talk about the details of Amazon Route 53, the benefits it provides over its competitors, and the different types of routing policy it has, and some of Amazon Route 53's key features. And we're going to talk about how to access Route 53 the different ways, the different methods you can access Route 53, and finally we're going to end with a wonderful demo in Route 53. So let's talk about what is AWS. Amazon Web Services, or AWS in short, is a cloud provider that offers a variety of services such as a variety of IT services or infrastructure services such as compute power, database, content delivery, and other resources that helps us to scale and grow our business. And AWS is hot, AWS is picking up, AWS is being adapted by a lot of customers. That's because AWS is easy to use even for a beginner. And talking about safety, the AWS infrastructure is designed to keep the data safe irrespective of the size of the data. Be it small data, be it very minimal data, be it all the data that you have in terabytes and in petabytes, Amazon can keep it safe in their environment. And the wonderful thing and the most important reason why a lot of customers move into the cloud is that the pay-as-you-go pricing. There is no long-term commitment and it's very cost effective. What this means is that you're not paying for a resource that you're not using. In on-premises, you do pay for resources you're not using a lot, meaning you go and buy a server, you do the estimate for the next 5 years, and only after like 3 or 4 years you'll be hitting the peak capacity, but still you would be buying that capacity before 4 years, right? And then you will gradually be, utilizing it from 40%, 60%, 70, 80, and then 100. So what you have done is that even though you're not using the full capacity, you still have bought it and are paying for it from day one. But in the cloud, it's not like that. You only pay for the resources that you use. Anytime you want more, you scale up the resource and you pay for the scaled up resource. And anytime you want less, you scale down the resource and you pay less for that scaled down resource. Let's talk about why Amazon Route 53. Let's take this scenario where Rachel is trying to open her web browser and the URL that she hit isn't working. A lot of reasons behind why the URL isn't working. It could be the server utilization that went high. It could be the memory usage that went high. A lot of reasons. And she starts to think, is there an efficient way to scale resources according to the user requirements? Or is there an efficient way to kind of mask all those failures and kind of divert the traffic to the appropriate active resource or active service that's running our application? You always want to hide the failures, right? In IT, kind of mask the failure and direct the customer to another healthy service that's running, right? None of your customers would want to see a server not available, or none of your customers would want to see your service not working. Not impressive to them. And this is Tom. Tom is an IT guy and he comes up with an idea and he's answering Rachel, yes, we can scale resources efficiently using Amazon Route 53. In a sense, he's saying that yes, we can mask the failure and we can keep the services up and running, meaning we can provide more high availability to our customers with the use of Route 53. And then he goes on and explains Amazon Route 53 is a DNS service that gives developers an efficient way to connect users to internet applications without any downtime. Now, downtime is the key. Amazon Route 53 helps us to avoid any downtime that customers would experience. You still will have downtime in your server, in your application, but your customers will not be made aware of it. And then Rachel is kind of interested and she's like, yeah, that sounds interesting. I want to learn more about it. And Tom goes on and explains the important concepts of Amazon Route 53. That's everything that I'm going to explain it to you as well. All right, so what is Amazon Route 53? Amazon Route 53 is a highly scalable DNS or domain name system web service. This service, this Amazon Route 53, it functions three main things, or it has three main functions. So the first thing is, if a website needs a name, Route 53 registers the name for the website domain. Let's say you want to buy google.com. You want to buy the domain name. Let's say you want to buy that domain name. You buy that through Route 53. Secondly, Route 53 is the service that actually connects your server which is running your application or which is serving your web page. So that's the service that actually Route 53 is the service that connects the user to your server when they hit google.com in the browser or whatever domain name that you have purchased. So you bought a domain name and the user types in your domain name.com, and then Route 53 is a service that helps the user to connect their browser to the application that's running in an EC2 instance or any other server that you are using to serve that content. Now, not only that, Route 53 checks health of the resource by sending automated requests over the internet to a resource. So that's how it identifies if there is any resource that has failed. When I say resource, I'm referring to any infrastructure failure, any application level failure. So it kind of keeps checking. So it understands it first before the customer notices it, and then it does the magic, kind of shifts the connection from one server to the other server. We call it routing. We will talk about that as we progress. So the benefits of using Route 53. It's highly scalable, meaning suddenly, let's say, the number of requests, the number of people trying to access your website through that domain name that you have bought, let's say it has increased. Route 53 is highly scalable, right? It can handle even millions and millions of requests because it's highly scalable and it's managed by Amazon. The same thing, it's reliable, it's highly scalable, it can handle large queries without the users, without you interacting, without the user who bought it interact with it. You don't have to scale up. When you're expecting more requests, it automatically scales. And it is very reliable in a sense that it's very consistent. It has the ability to route the users to the appropriate application through the logic that it has. It's very easy to use. When we do the lab, you're going to see that. It's very easy to use. You buy the domain name and then you simply map it to the application. You simply map it to the server by putting in the IP, or if you can simply map it to another load balancer by putting in the load balancer URL. You can simply map it to another S3 bucket by simply putting the S3 bucket name or the S3 bucket URL. It's pretty straightforward, easy to set up. And it's very cost effective in a way that we only pay for the service that we have used. So no wastage of money here. So the billing is set up in such a way that you are paying only for the amount of requests that you have received, right? The amount of traffic, the amount of requests that you have received, and a couple of other things. The number of hosted zones that you have created, right? And a couple of other things. It's very cost effective in such a way that you only pay for the service that you are using. And it's secure in a way that access to Route 53 is integrated with the Identity and Access Management, IAM. So you only have authorized users gain access to Route 53. The trainee who just joined yesterday won't get access. And the contractor or the consultant, the third-party consultant you have given access or who is using your environment, you can block access to that particular person because he's not the admin or he's not a privileged user in your account. So only privileged users and admin gain access to Route 53 through IAM. Now let's talk about the routing policies. So when you create a record in Route 53, record is nothing but an entry. So when you do that, you choose a routing policy. Right? Routing policy is nothing but it determines how Route 53 responds to your queries, how the DNS queries are being responded. Right? That's a record, or that's a routing policy. So the first one is a simple routing policy. So we use simple routing policy for a single resource. In other words, simple routing allows to configure DNS with no special Route 53 routing. It's kind of one-to-one. You use a single resource that performs a given function to your domain. For example, if you want to simply map an URL to a web server, that's pretty straightforward, simple routing. So it routes traffic to a single resource, example, web server to a website. And with simple routing, multiple records with the same name cannot be created, but multiple values can be created in the same record. The second type of routing policy is failover routing. So we would be using failover routing when we want to configure active, passive failover. If something failed right? You want to fail over to the next resource, which was previously the backup resource, now the active resource, or which was previously the backup server, now it's an active server. So you would be failing over to that particular resource or that particular IP. If you want to do that, we use failover routing. So failover routing routes traffic to a resource when the resource is healthy, or to a different resource when the previous resource is unhealthy. In other words, anytime a resource goes unhealthy, it does all that's needed to shift the traffic from the primary resource to the secondary resource. In other words, from the unhealthy resource to the healthy resource. And this records can route traffic to anything from an Amazon S3 bucket, or you can also configure a complex tree of records. Now, when we configure the records, it will be more clear to you. So as of now, just understand that Route 53 can route, or this routing policy, the failover routing policy, can route traffic to Amazon S3 bucket or to a website that has complex tree of records. Geolocation routing policy. Now, geolocation routing, just like the name says, it takes that routing decision based on the geographic location of the user. Right? In other words, when you want to route traffic based on the location of the user, that's your primary criteria for sending that request to the appropriate server, we would be using geolocation routing. So it localizes the content and presents a part or the entire website in the language of the user. For example, a user from US, you would want to direct them to an English website, and a user from German, if you want to send them to the German website, and a user from France, you want to send those requests, or you want to show content specific to a customer who lives in France, a French website. So this is, if that's your condition, this is the routing policy we would be using. And the geographic locations are specified by either continent or by country or by state in the United States. So only in the United States you can actually split it to state level, and for the rest of the countries you can do it on a country level. On a high level, you can also do it on a continent level. The next type of routing policy would be geo-proximity routing. Geo-proximity routing policy, when we want to route traffic based on the location of our resource and optimally shift traffic from resources in one location to resource in another location, we would be using geo-proximity routing. So geo-proximity routing routes traffic to the resources based on the geographic location of the user and the resources they want to access. And it also has an option to route more traffic or less to a given resource by specifying a value known as a bias. Kind of weight, but we also have weighted routing that's different. So we've chosen different name, bias. You can send more traffic to a particular resource by having a bias on that particular routing condition. And a bias expands or shrinks the size of the geographic region from which traffic is routed to a resource. And then we have latency-based routing. Just like the name says, we use latency-based routing if we have resources in multiple AWS regions, and if you want to route traffic to the region that provides the best latency at any given point of time. So let's say if one single website needs to be installed and hosted on multiple AWS regions, then latency routing policy is what is being used. It improves the performance of the users by serving the request from the AWS region that provides the lowest latency. So at any given point, if performance is your criteria, and at any given point of time, irrespective of what happens in Amazon infrastructure, irrespective of what happens in the internet, if you want to route your users to the best performing website, best performing region, then we would be using latency-based routing. And for using latency-based routing, we should create latency records for the resources in multiple AWS regions. And then the other type of a routing policy is multi-value routing policy, where we can make Route 53 to respond to DNS queries with up to 8 healthy records selected at random. So you're not kind of loading one particular server. We can define 8 records, and on a random basis, Route 53 will respond to queries from these 8 records. So it's not one server that gets all the requests, but 8 servers gets the request in a random fashion. So it's multi-value routing policy, and what we get by this is that we are distributing the traffic to many servers instead of just one server. So multi-value routing configures Route 53 to return multiple values in response to a single or multiple DNS queries. It also checks the health of odd resources and returns the multiple values only for the healthy resources. Let's say out of the 8 servers we have defined, one server is not doing healthy. It will not respond to the query with the details of the unhealthy server, right? So now it's going to treat it as only 7 servers in the list because one server is unhealthy. And it has the ability to return multiple health checkable IP addresses to improve availability and load balancing. The other type of routing policy is weighted routing policy, and in here we use to route traffic, or this is used to route traffic to multiple resources in a proportion that we specify. So this is an weighted routing, and weighted routing routes multiple resources to a single domain name or a subdomain and control the traffic that's routed to each resources. So this is very useful when you're doing load balancing and testing new versions of the software. So when you have a new version of the software, you really don't want to send 100% of the traffic to it. So you want to get customers' feedback about the new software that you've launched, new version or new application that you've launched. So you would kind of send only 20% of the traffic to that application, get customer feedback, and if all is good, then we would move the rest of the traffic to that new application. So any software launches, application launches will be using weighted routing. Now let's talk about the key benefits or key features of Route 53. Some of the key features of Route 53 are traffic flow. It routes end users to the endpoint that should provide the best user experience. That's what we discussed in the routing policies, right? It uses a routing policy, a latency-based routing policy, and geo-based routing policy, and then failover routing policy. So it kind of improves the user experience. And the other key feature of Route 53 is we can buy domain names using Route 53 console. We can buy it from here and use it in Route 53. Previously it was not the case, but now we can buy it directly from Amazon through Route 53, and we can assign it to any resources that we want. So anybody browsing that URL, the connection will be directed to the server in AWS that runs our website. Health checks. It monitors health and performance of the application. So it comes with an health check attached to it. Health check are useful to make sure that the unhealthy resources are retired, right? The unhealthy resources are taken away, or your customers are not kind of hitting the unhealthy resources and they see an service down page or something like that. We can have weighted round robin load balancing. That's helpful in spreading traffic between several services or servers via a round robin algorithm. So no one server is fully hit, or no one server kind of fully absorbs all the traffic. You can split and shift the traffic to different servers based on the weight that you would be configuring. And also weighted routing also helps with a soft launch of your new application or the new version of your website. There are different ways we can access Amazon Route 53. So you can access Amazon Route 53 through AWS console. You can also access Amazon Route 53 using AWS SDKs, and we can access it we can configure it using the APIs. And we can also do it through the command line interface. That's Linux type, Linux flavor, AWS command line interface. We can also do that using Windows command line, Windows PowerShell flavored command line interface as well. Now let's look at some of the companies that are using Route 53. So some of the famous companies that use Route 53 are Medium. Medium is an online publishing platform, and it's more like a social journalism. It's kind of having hybrid collection of professionals, people, and publications, or exclusive blogs or publishers on Medium. It's kind of an blog website, and that uses Route 53 for the DNS service. Reddit is an social news aggregation or web content rating and discussion website that uses Route 53. So these are some websites that are accessed throughout the world, and they are using Route 53, and it's highly scalable. Suddenly if there is a new news, right, their website will be accessed a lot, and they need to keep their service up and running all the time, more availability, otherwise customers will end up in a broken page, and the number of customers who will be using the website will come down. So it's very critical. Now these sites, these companies are very critical, they're being highly available, their page, their site being highly available, and the internet is very critical and crucial for them, and they rely and use Route 53 to meet that particular demand. And Airbnb is another company, Instacart, Coursera is another company, Stripe is another company that uses Route 53 as their DNS provider for their DNS service. They use Route 53 so their customers get best performance. They use Route 53 so their website is highly available. They use Route 53 to kind of shift the traffic between the resources, so their resources are properly used with all the weighted routing. Their resources are properly used. Now let's quickly look at a demo. I'm in my AWS console and I'm in Route 53. So let me click on Route 53. So in this lab, we're actually going to simulate buying a domain name, and then we're going to create an S3 static website, and we're going to map that website to this DNS name, right? So the procedure is the same for mapping load balancer. The procedure is the same for mapping CloudFront. The procedure is the same for mapping EC2 instances as well. We're picking S3 for simplicity, right? But our focus is actually on Route 53. So let's go in here and we'll see if we can, right, we'll buy a domain name here. So let's first check the availability of a domain name called Simplilearn-demo-Route 53. Let's check its availability. It is available for $12, so let me add it to cart and then come back here. And then once you continue, it'll ask for personal information. Once you give the personal information, you finally check out, and then it gets added to your shopping list. Once you pay for it, Amazon takes like 24 to 48 hours to make that DNS name available. So the next stage would be contact details, and then the third stage would be verify and purchase. So once we have bought the domain name, it will become available in our DNS portal. And I do have a domain name which I bought some time back, and it's now available for me to use. So I can go to hosted zone and simply start creating. I can go to hosted zone, and then here it's going to list all the domain names for me. Right, click on the domain name and then click on the record set, and here I can actually map Elastic Load Balancer, S3 website, VPC endpoint, API gateway, and CloudFront, Elastic Beanstalk domain names, right? All that gets mapped through this portal. Quite simple, like 4 or 5 step button clicks, and then it'll be done. So I have an domain name bought, and then I'm going to go to S3, and I'll show you what I've done in S3. So I've created a bucket name called as DNS name. Let me clear the content in them. So I've created a bucket, and then permissions, I've turned off public access blocking, and then I've created a bucket policy. So this bucket is now publicly accessible. And then I went on to properties and created the static website hosting, right? And I've pointed that this is the file, that's my index file that I'm going to put, or name of the file that's going to be my index file that I'm going to put in this S3 bucket. So I've put the index file.html, saved it, and we're going to create a file now. We're going to create an index file. So this is a sample code. It says Amazon Route 53 getting started, routing internet traffic to S3 bucket for your website, and then a couple of other information. So I've saved it as an index.html file in my desktop. So let me upload that from my desktop into this bucket. So that's index.html, and it's in capital I. So let me go to properties and go to static website hosting and make sure that I spell it properly. Right, it's case sensitive, and then save it. So now this means that my website should be running through this URL, and it does. It's running through the static website URL. We're halfway through. So now let me go back to Route 53, go back to Route 53, go back to hosted zones, go into the domain name, and then create a record set. And it's going to be an alias record. And I see my S3 static website endpoint there. Right, so click on it and create. It has now created an record that's pointing my domain name to the S3 endpoint that I have created. And my static website is running from it. So let me test it. Right, so let me go to the browser, put the domain name in there, and sure enough, the domain name, when my browser queried for the domain name, Route 53 returned a response saying this domain name is actually mapped to the S3 bucket, static website hosting enable S3 bucket, and this is the URL for that static website hosting. And then my browser was able to connect to that S3 bucket and download the details and show it in my browser. Right, so it's that simple and pretty straightforward.
Today's session is on AWS Elastic Beanstalk. So what's in it for you today? We'll be discussing about what is AWS, why we require AWS Elastic Beanstalk, what is AWS Elastic Beanstalk, the advantages, disadvantages, the components of Beanstalk, along with that, the architecture and the companies that are primarily using the AWS Beanstalk. So let's get started and first understand what is AWS. AWS stands for Amazon Web Services. It's a cloud provider and that offers a variety of services such as compute power, database storage, content delivery, and many other resources. So we know that AWS is the largest cloud provider in the market, and so many services are available in the AWS where you can apply the business logics and create the solutions using the cloud platforms. Now, why AWS Elastic Beanstalk? Now, what happened earlier and that whenever the developer used to create the software or the modules related to the softwares, it has to be joined together to create a big application. Now, one developer creates a module that has to be shared with another developer. And if the developers are geographically separated, then it has to be shared over a medium, probably an internet. So that is going to take some time. It would be a difficult process, and in return it makes the application or a software development a lengthier process, the building of the software development a lengthier process. So there were challenges which the developers were facing earlier, and to overcome that we have the Beanstalk as a service available in the AWS. So why AWS Elastic Beanstalk is required? AWS Elastic Beanstalk has made the life of the developers quite easy in terms of that they can share the applications across different devices at a shorter time duration. Now let's understand what is AWS Elastic Beanstalk. AWS Elastic Beanstalk is a service which is used to deploy and scale web applications by developers. Not only web application, any application that is being developed by the developers. This is a symbol representation of the AWS Elastic Beanstalk. Now, along with that, the AWS Elastic Beanstalk supports the programming language, the runtime environments that are Java, .NET, PHP, Node.js, Python, RubyGo, and Docker. And in case if you're looking for any other programming language or a runtime environment, then you can make a request with AWS to arrange that for you. Now, what are the advantages associated with the Elastic Beanstalk? First advantage is that it's a highly scalable service. Now, when we talk about a scalability, it means that whenever we require the resources in demand, we can scale up the resources or we can scale down the resources. So that is kind of a flexibility we get in terms of changing the type of resources whenever we need it. And in that case, the Elastic Beanstalk is a highly scalable service. Now that is something which is very difficult to achieve in case of an on-prem environments, because you have to plan for the infrastructure, and in case if you're short of the resources within that infrastructure, then you have to procure it again. The second advantage associated with the Beanstalk is that it's a fast and simple to begin. Now when we say it's fast and simple, that means that you just have to focus on the development of an application, building an application, and then you can just deploy the application directly using the Beanstalk. What the Beanstalk is going to do, that every networking aspect is being taken care by the Beanstalk. It deploys your application in the backend on the servers, and then you can directly access your application using the URL or through the IP address. The third advantage is that it offers the quick deployment. That is what we discussed in the fast and simple to begin as well. So why it offers a quick deployment? You don't have to bother about the networking concepts. You just have to focus on the application development, and then you can just upload your application, deploy that, and then you are good to go. The other advantage is that it supports multi-tenant architecture. When we talk about tenants or multi-tenants, that means we can have a virtual environments for separate organizations or the divisions within the organizations that will be virtually isolated. So likewise, you can have virtually isolated environments created on the Beanstalk, and they can be separated, used as a separate entities or a separate divisions within the organization. And we know that it's a flexible service. Since it's a scalable, then it is a flexible also. Now, coming to the simplifies operations as an advantage. Now, once the application is deployed using the Beanstalk, then it becomes very easy to maintain and support that application using the Beanstalk services itself. And the last advantage that we can have from the Beanstalk is that it's a cost efficient service. The cost efficient, as we know that many of the AWS services are cost effective. The cost optimization can be better managed using the AWS Beanstalk as compared to if you are developing or if you are deploying any kind of an application or a solution on the on-prem servers. Now, there are some components that are associated with the AWS Beanstalk, and it has to be created in the form of a sequence manner. So AWS Elastic Beanstalk consists of few important components which are required while developing an application. Now, what are these components? These are 4 components. One is application, the second is application version, the third is environment, and the fourth one is the environment tier. And we have to progress while deploying our applications or the softwares using the same sequence. Now let's understand what are the different components of the Beanstalk are. The application. It refers to a unique label which is used as a deployable code for a web application. So generally you deploy your web application or you create your application, and that is something which is basically used as a unique label. Then the second component is application versions. So it resembles a folder which stores a collection of components such as environments, versions, and environment configurations. So all these components are being stored using the application version. The third most important component is the environment. In the environment, only the current versions of the applications runs. Now remember that Elastic Beanstalk supports multiple versions as well. And using the environment, you can only run the current version of the application. For if you wanted to have another version of an application to be running, then you have to create another environment for that. Then comes the environment tier. And in the environment tier, it designates the type of application that the environment runs on. Now, generally, there are 2 types of environment tier. One is the web and the other one is the worker node. And that's something which we'll be discussing later as well. Now, let's understand how does Elastic Beanstalk in AWS works. So first we have to create an application, and this is a task that would be done by the developers. And for that, you can actually select any runtime environment or a programming language like Java, Docker, Ruby, Go, Perl, or Python as well. And once you select that environment, you can develop your application using that runtime environments. Now, after that, once the application is created, then you have to upload the version of an application on the AWS. And after that, once the version is uploaded, and then you have to launch your environment. So just have to click on the buttons. That's it. Nothing more you have to do. Once the environment is launched, then you can actually view that environment using a web URL or using the IP address. Now, what happens in that case is when you launch an environment in the backend, the Elastic Beanstalk automatically runs an EC2 instance. And using a metadata, the Beanstalk deploys your application within that EC2 instance. That is something which you can look into the EC2 dashboard as well. So you don't have to take care of the security groups, you don't have to take care of the IP addressing, and even you don't have to log in into the instance and deploy your application. It would be done automatically by the Beanstalk. It's just that you just have to monitor the environment, and the statistics will be available there itself in the Beanstalk dashboard. Otherwise, you can view those statistics in the CloudWatch logs as well. Now, in case if you wanted to update any kind of a version, then you just upload a new version and then just deploy that and then monitor your environment. So these are the essentials to create a local applications for any platform, whether it's a Node.js, Python, etc. These are the things that you have to actually take care, and this is the sequence you have to follow while creating an environment. So you can say that it's a 4 steps creation of or deployment of your application. That's it. Now, after users upload their versions, the configuration is automatically deployed with a load balancer. Yes, and with a load balancer, that means you can access the applications using the load balancer DNS also. And apart from load balancer, if you wanted to put any other feature that includes the auto scaling. For example, if you wanted to create your EC2 instances where the application will be deployed within the virtual private cloud or in a particular subnet within the VPC, all those features that are available, and you can select them using the Beanstalk itself. You don't have to move out to the VPC. You don't have to actually go to the EC2 dashboard and select all those separately. Everything would be available within the Beanstalk dashboard. So that's what it says in the presentation, that after creating an application, the deploy service can be specifically accessed using the URL. So once the environment is created, there will be a URL defined. Now you can put a URL name also. That is something which you wanted to put for your application. You can define that. You can check for the availability of that URL, and then you have to use that URL to access your application over the browser. Now, once it is done, then in the monitor environment, it says the environment is monitored, provided capacity provisioning, load balancing, auto scaling, and monitor features. All those features are available there itself in the Beanstalk. Now let's understand the architecture of AWS Elastic Beanstalk. Now there are two types of environments that you have to select. You can select. One is the web server environment and the other one is the worker environment. So based on the client requirement, Beanstalk gives you two different types of environment that you have to select. Generally, the web server environment is the front end facing. That means the clients would be accessing this environment directly using a URL. So mostly web applications are deployed using that environment. The worker environment is the backend applications or the micro apps, which are basically required to support the running of the web applications. Now it depends on the client requirement what kind of an environment you wanted to select. Now in the web server environment, it only handles the HTTP request from the clients. So that's why we use the web server environment mostly for the web applications or any application which works on the HTTPS requests. So it's not only the HTTP, you can use the HTTPS as well. The worker environment, it processes background tasks and minimizes the consumption of resources. So again, it is just like a kind of a microservice or an application services that are running in the backend to support the web server environment. Now coming to the understanding of the AWS Beanstalk. So this is how the architecture of the AWS Beanstalk is designed, and you can refer to that image also. Now in the web server environment, let's say if we select a web server environment, and it says that if the application receives client requests, the Amazon Route 53 sends these requests to the Elastic Load Balancer. Now obviously we discussed here that the web server environment is primarily an environment which receives the HTTP requests. It's a kind of a client facing environment. Now if the application receives a client request from the Amazon Route 53, this Route 53 is a service which is primarily used for DNS mapping. It's a global service and it may you can route the traffic from the Route 53, matching your domains towards the load balancer. And from the load balancer, you can point that traffic to the web server environment. Obviously, the web server environment is nothing. It's just the EC2 instances that would be running in the backend. Now, here in the diagram, you can see that there are two web server environments and they are created in the auto scaling group. That means there is some kind of scaling options that are defined as well. And these instances are created in an availability zone, or they can be created in a different availability zone also for the redundancy as well. And these web application servers are further connected to your databases, which primarily will be in a different security groups. Probably it can be an RDS database also. So all these functionalities, all these features are basically available on the Elastic Beanstalk dashboard itself. Now what happens in that case is if the application receives client requests, Amazon Route 53 send these requests to the load balancer. Later, the load balancer shares those requests among the EC2 instances. How does that happen? It happens using a predefined algorithm. The equal distribution of a load is distributed to both the EC2 instances or n number of EC2 instances running in the availability zone. Now in the availability zones, every EC2 instance would have its own security group. They can have a common security group also. They can have their own security group as well. Now, after the security group, the load balancer is then connected to the Amazon EC2 instance, which are part of the auto scaling group. So that's something which we have discussed already. Now, this auto scaling group would be defined from the Beanstalk itself, and there will be some scaling options that will be created. It could be a possibility that it might be the minimum number of instances that would be running as of now, and based on the threshold defined, it may increase the number of EC2 instances, and the load balancer will keep on distributing the load to as many instances that will be created inside the availability zones. Obviously, there will be an internal health check that the load balancer will be first doing before distributing the real-time traffic to these instances created by the Beanstalk. Now what does autoscaling group does? It automatically starts the additional EC2 instance to accommodate increasing load on your application. That's something which we know that. And also it monitors and scales instances based on the workload as well. So depends on what kind of a scaling threshold you have defined in the autoscaling groups. And when the load of an application decreases, the EC2 instance will also be decreased. So whenever we talk about the autoscaling, generally it comes in our mind is that we scale up the resources. That means it increases the EC2 instances. In the autoscaling, you might have the scale down option also, scale down policy also created, in which if the load minimizes, it can terminate the additional EC2 instances as well. So that is something which will be automatically managed. All these features can be achievable using the Elastic Beanstalk. And with this feature accommodated, it gives you the better cost optimization in terms of managing your resources. Now it says that Elastic Beanstalk has a default security group, and the security group acts as a firewall for the instances. Now here in this diagram, it says about the security group autoscaling also. You might create it in a default VPC also. You might create it in your custom VPC also, where you can have the additional level of security is also created. You can have the NACLs, NACLs also defined here before the security groups. So that would give you the additional filtering option or the firewall option. Now it says that with these groups, with these security groups, it allows establishing security groups to the database server as well. So every database would also have its own security group, and the connection can be created between the web servers environment that is created by the Beanstalk to the database security groups as well. Now let's discuss about the worker environment. Now understanding the worker environment, what happens is that the client, the web server environment is the client facing. The client sends a request for an access to the web server. And in this diagram, the web server further sends it to the SQS, which is a simple queue service. And the queue service sends it to the worker environment. And then whatever the worker environment is created for doing some kind of a processing or some kind of an application that is running in the backend, that environment initiates and then send back the results to this SQS and vice versa. So let's understand the architecture of a AWS Elastic Beanstalk with the worker environment. So when a worker environment here is launched, AWS Elastic Beanstalk installs a server on every EC2 instance. So that is in the case of a web server environment also. And later the server passes the request to the simple queue service. Now this service is an asynchronous service. Instead of a simple queue service, you can have other services also. It is not necessary that you need to have the SQS also. This is an example that we are discussing about. And the SQS shares those messages via a post request to the HTTP path over the worker environment. And there are many case studies also with respect to this kind of an environment that is being created, that is being done on many customers. And you can search for these kind of a case studies available on the internet. Now the worker environment executes the task given by the SQS with the HTTP response after the operation is completed. Now here what happens is a quick recap. The client requests for an access of an application to a web server using an HTTP request. The web server passes that request to the queue service. The queue service shares the message with a worker. Probably a worker might be the manual worker, and generally it's an automated worker. So it would be shared via the worker environment only. And the worker sends back the response with the HTTP response back to the queue. That response can be viewed directly from the queue service by the client using the web server. So this is one of the examples. Likewise, as I said, that there can be many other examples also where you can have the worker environments defined. Now, what are the companies that are using the Elastic Beanstalk? These are few of the companies that are primarily using. One is Zillow, Jelly Button Games, then you have League of Women Voters, eBury. These are some of the few listed companies, and obviously you search on the AWS site and you'll find many more organizations that are using the Elastic Beanstalk primarily for deploying their applications. Now the next thing is to go with the practicals, that how actually we use the Elastic Beanstalk. So let's look into the demo using the AWS Elastic Beanstalk. Now first you have to log in into the AWS console, and I'm sure that you might be having the accounts created, or you can use the IAM credentials as well. And then you have to select the region also. Now I am in the North Virginia region. Likewise, you can select any of the regions that are listed here. Now click on the services and you have to search for the Elastic Beanstalk. You can find the Elastic Beanstalk under the compute section. So here itself, you'll find the Elastic Beanstalk as a service. Now open this service, and there it will give you an option to create an environment. You have to specifically select an environment, probably a worker environment or a web service environment. So let's wait for the service to open. So we have the dashboard now available with us. This is how the Elastic Beanstalk looks, and this is the symbol representation of a beanstalk. Now, what we have to do is we have to click on Get Started, and that will load, and you have to create a web app. So instead of creating a web app, what we'll do, we'll create a new application. So just click on Create a new application, put an application name. Let's say we put something like XYZ. You can put any description to your application. Let's say it's a demo app, and click on Create. Now it says you have to select an environment. Now the environment, the application name XYZ is created. You just have to select an environment. So click on Create One now, and it is going to ask you that what kind of an environment tier you wanted to select. So as we discussed, that there are two types of environments. One is the web server and the other one is the worker environment. Let's look into it, what is defined by the AWS. AWS says that it has two types of environment tiers to support different types of web applications. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for message on an Amazon SQS queue. Workers application posts those messages to your application by using the HTTP response. So that's what we saw in the case of the Beanstalk slides also. Now the usability of a worker environment can be anything. Now we'll do a demo for creating a web server environment. So just click on Select, and we have the environment name created. Now we can define our own domain. It ends with the region.elasticbeanstalk.com. Let's say I look for a domain which is XYZ only. That's the environment name. Now I'll check for the availability whether that domain name is available with us or not. And it says we don't have that domain name. So probably I'll try to make it with some other name, and let's look for the availability. XYZ ABC, and it says yes, it is available. Now once I deploy my application, I would be able to access the application using this complete DNS. So you can put a description. It's a demo app that we are creating, and then you have to define a platform as well. Now these are the platforms that are supported by the AWS. Let's say I wanted to run a Node.js environment. So I'll just click on the Node.js platform. The application codes is something which is basically developed by the developers, and you can upload the application right now, or you can do that later as well once the environment is ready. Now either you can select to create an environment if you wanted to go with all the default settings. Otherwise, if you wanted to customize it more, you can click on Configure More Options. So let's click on Configure More Options. And here you would be able to define various different features like the type of an instance. For example, what kind of an EC2 instance or a server that should be running so that the Beanstalk can deploy your applications over it. If you wanted to modify, just click on a Modify button. And here you can modify your instances with respect to the storage as well. Now, apart from that, if you wanted to do some modification in the case of monitoring, in the case of databases, in the case of security, or in the case of a capacity, let's look into the capacity. So here you can actually do the modification. So in the capacity, you can select the instance type also. By default, it is t2.micro, but in case if your application requires a larger type of an instance, then you can actually go for the instance type as well. Similarly, you can define your AMI IDs also, because obviously for the application to run, you would require the operating system also. So you can select that particular AMI ID for your operating system as well. Let's cancel that. Likewise, you have many other features that you can actually define here from the dashboard, and you don't have to go to the EC2 dashboard to do the modifications. Now let's go and create an environment. Let's assume that we are going with the default configuration. So this is going to create our environment. The environment is being created, and you can get the environment and the logs defined in the dashboard itself. So you'll see that the Beanstalk environment is being initiated, the environment is being started, and in case if there would be any errors or if it is deployed correctly, you'll get all the logs here itself. Now the environments are basically color coded. So there are different color codings that are defined. If you get the environment in a green color, that means everything is good to go. So here you can see that it has created an Elastic IP. It has checked the health of the environment. Now it has created the security groups, and that would be an auto security groups created by the Beanstalk. and the environment creation has been started. You can see that Elastic Beanstalk as Amazon S3 storage bucket for your environment data as well. This is the URL through which you will be accessing the environment, but right now we cannot do that since the environment is being created. Let's click on the application name, and here you can see that it is in a gray color. That means right now the build is being done. It is being created. Once it will be successfully created, it should change to the green color, and then we will be able to access our environment using the URL. Now, if I move to the EC2 instances and see in the EC2 dashboard, if I see whether the instance is being created by the Beanstalk or not. So let's see, and let's see what are the differences in terms of creating an instance manually and getting it created from the Beanstalk. So click on the EC2. Let's go to the old EC2 experience. That's what we are familiar with. And let's see what's there in the dashboard. So here you can see one running instance. Let's open that. And the XYZ environment, which was created from the Beanstalk, is being initiated. The instance is being initiated. And that is something which is being done by the Beanstalk itself. We have not gone to the dashboard and created it manually. Now, in the security groups, if you see that, here the AWS Beanstalk security groups are defined. It has the Elastic IPs also defined. So everything is being created by the Beanstalk itself. Right. Now let's go back to the Beanstalk and let's look into the status of our environment, whether the color coding has been changed from gray to green or not. And here you can see the environment is successfully created, and we have that environment colored in green. We'll access the environment, and it says it's a web server environment. Its platform is Node.js running on 64-bit Amazon Linux AMI, and it's a sample application. Health status is OK. Now the other thing is that if you do not want to use the web console, the management console, to access the Beanstalk, then the Beanstalk offers you the Elastic Beanstalk CLI as well. So you can install the command line interface, and then you have the command references, CLI command references, that you can actually play with and get your applications deployed using the Beanstalk itself. So this is one of the sample CLI commands that you can actually look into. Now let's look into the environment. Let's click on the environment and we'll be represented with the URL. It says health is OK. These are the logs that you have to follow in case if there are any issues. The platform is Node.js. That is what we selected. Now the next thing is you just have to upload and deploy your applications. So just click on upload and deploy. Select the version label or the name. Select file, and wherever your application is hosted at, just select that, upload it, and deploy your application. You'll see that like your environment is created, similarly your application will be deployed automatically on the instance, and from this URL you will be able to view the output. It is as simple as just like you have to follow these 4 steps. Now let's see whether the Node.js environment is running on our instance before deploying an application. So we'll just click on this URL. Since the Beanstalk has already opened up the security groups or HTTP port 80 for all, we can actually view that output directly from the URL. So we have the Node.js running, that's visible here, and after that you just have to upload and deploy your application, and then from that URL you can get the output. Now this URL you can map it with the Route 53 service. So using the Route 53 DNS services, the domain names can be pointed to the Elastic Beanstalk URL, and from there it can be pointed to the applications that are running on the EC2 instance. Whether you wanted to point it to the URL directly using the Beanstalk, you can do that. Otherwise, as we saw in the slides, you can use the Route 53, point it to the load balancer, and then point it to the instances directly also once it is created by the Beanstalk. So that was the demo, guys, with respect to the Beanstalk and how we can actually run the environments. Apart from that, the operational tasks like system operations, you can manage all these things from the environment dashboard itself. So you have the configurations, you have the logs, you can actually check the health status of your environment, you can do the monitoring, and you can actually get the alarms and the events here. So let's say if I wanted to see the logs, I can request for the logs here itself, and I'll be represented with the full log report, and I can now download that log file and I can view the logs. So it's in the, so we have this bundle logs in the zip file. All right, so if you want to see some kind of logs with respect to Elastic Beanstalk activity, it's in the form of a notepad, and here you can see what all configurations the Beanstalk has done on your environment, on your instance. Similarly, you can go for the health, monitoring, alarms, events, and all those things.
If getting your learning started is half the battle, What if you could do that for free? Visit ScaleUp by Simplilearn. Click on the link in the description to know more.
Hi, this is the 4th lesson of the AWS Solutions Architect course. Migrating to the cloud doesn't mean that resources become completely separated from the local infrastructure. In fact, running applications in the cloud will be completely transparent to your end users. AWS offers a number of services to fully and seamlessly integrate your local resources with the cloud. One such service is the Amazon Virtual Private Cloud. This lesson talks about creating virtual networks that closely resemble the ones that operate in your own data centers, but with the added benefit of being able to take full advantage of AWS. So let's get started.
In this lesson, you'll learn all about virtual private clouds and understand their concept. You'll know the difference between public, private, and elastic IP addresses. You'll learn about what a public and private subnet is. And you'll understand what an internet gateway is and how it's used. You'll learn what route tables are and when they are used. You'll understand what a NAT gateway is. We'll take a look at security groups and their importance. And we'll take a look at network ACLs and how they're used in Amazon VPC. We'll also review the Amazon VPC best practices and also the costs associated with running a VPC in the Amazon cloud. Welcome to the Amazon Virtual Private Cloud and Subnet section. In this section, we're going to have an overview of what Amazon VPC is and how you use it. And we're also going to have a demonstration of how to create your own custom virtual private cloud. We're going to look at IP addresses and the use of elastic IP addresses in AWS. And finally, we'll take a look at subnets, and there'll be a demonstration about how to create your own subnets in an Amazon VPC. And here are some of the terms that are used in VPCs. There's subnets, route tables, elastic IP addresses, internet gateways, NAT gateways, network ACLs, and security groups. And in the next sections, we're going to take a look at each of these and build our own custom VPC that we'll use throughout this course. Amazon defines a VPC as a virtual private cloud that enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center, but with the benefits of using the scalable infrastructure of AWS. A VPC is your own virtual network in the Amazon cloud, which is used as the network layer for your EC2 resources. And this is a diagram of the default VPC. Now there's a lot going on here, so don't worry about that. What we're going to do is break down each of the individual items in this default VPC over the coming lesson. But what you need to know is that a VPC is a critical part of the exam, and you need to know all the concepts and how it differs from your own networks. Throughout this lesson, we're going to create our own VPC from scratch, which you'll need to replicate at the end of this so you can do well in the exam. Each VPC that you create is logically isolated from other virtual networks in the AWS cloud. It's fully customizable. You can select the IP address range, create subnets, configure route tables, set up network gateways, define security settings using security groups, and network access control lists. So each Amazon account comes with a default VPC that's pre-configured for you to start using straight away, so you can launch your EC2 instances without having to think about anything we mentioned in the opening section. A VPC can span multiple availability zones in a region. And here's a very basic diagram of a VPC. It isn't this simple in reality. And as we saw in the first section, here's the default Amazon VPC, which looks kind of complicated. But what we need to know at this stage is that the CIDR block for the default VPC is always a 16 subnet mask. So in this example, it's 172.31.0.0/16. What that means is this VPC will provide up to 65,536 private IP addresses. So in the coming sections, we'll take a look at all of these different items that you can see on this default VPC. But why wouldn't you just use the default VPC? Well, the default VPC is great for launching new instances when you're testing AWS. But creating a custom VPC allows you to make things more secure, and you can customize your virtual network as you can define your own IP address range. You can create your own subnets that are both private and public, and you can tighten down your security settings. By default, instances that you launch into a VPC can't communicate with your own network. So you can connect your VPCs to your existing data center using something called hardware VPN access, so that you can effectively extend your data center into the cloud and create a hybrid environment. Now to do this, you need a virtual private gateway, and this is the VPN concentrator on the Amazon side of the VPN connection. Then on your side, in your data center, you need a customer gateway, which is either a physical device or a software application that sits on your side of the VPN connection. So when you create a VPN connection, a VPN tunnel comes up when traffic is generated from your side of the connection. VPC peering is an important concept to understand. A peering connection could be made between your own VPCs or with a VPC in another AWS account, as long as it's in the same region. So what that means is, if you have instances in VPC A, they wouldn't be able to communicate with instances in VPC B or C unless you set up a peering connection. Peering is a one-to-one relationship. A VPC can have multiple peering connections to other VPCs, but, and this is important, transitive peering is not supported. In other words, VPC A can connect to B and C in this diagram, but C wouldn't be able to communicate with B unless they were directly peered. Also, VPCs with overlapping CIDRs cannot be peered. So in this diagram you can see they all have different IP ranges, which is fine, but if they had the same IP ranges, they wouldn't be able to be peered. And finally for this section, if you delete the default VPC, you have to contact AWS support to get it back again. So be careful with it and only delete it if you have good reason to do so and know what you're doing. This is a demonstration of how to create a custom VPC. So here we are, back at the Amazon Web Services Management Console. And this time we're going to go down to the bottom left where the networking section is. I'm going to click on VPC. And the VPC dashboard will load up. Now there's a couple of ways you can create a custom VPC. There's something called the VPC Wizard, which will build VPCs on your behalf from a selection of different configurations. For example, a VPC with a single public subnet, or a VPC with public and private subnets. Now this is great because you click a button, type in a few details, and it does the work for you. However, you're not going to learn much or pass the exam if this is how you do it. So we'll cancel that and we'll go to your VPCs and we'll click on Create a VPC. And we're presented with the Create a VPC window. So let's give our VPC a name. I'm going to call it Simplilearn_VPC. And this is the kind of naming convention I'll be using throughout this course. Next we need to give it the CIDR block, or the classless interdomain routing block. So we're going to give it a very simple one, 10.0.0.0, and then we need to give it the subnet mask. So you're not allowed to go larger than 15. So if I try to put 15 in, it says no, not going to happen. For a reference, subnet mask of 15 would give you around 131,000 IP addresses, and subnet 16 will give you 65,536, which is probably more than enough for what we're going to do. Next you get to choose the tenancy. There's two options, default and dedicated. If you select dedicated, then your EC2 instances will reside on hardware that's dedicated to you. So your performance is going to be great, but your cost is going to be significantly higher. So I'm going to stick with default. And we just click on yes, create. It'll take a couple of seconds. And then in our VPC dashboard, we can see our Simplilearn VPC has been created.
Now, if we go down to the bottom here to see the information about our new VPC, we can see it has a route table associated with it, which is our default route table. So there it is, and we can see that it's only allowing local traffic at the moment. If we go back to the VPC again, we can see it's been given a default network ACL. And we'll click on that and have a look. And you can see this is very similar to what we looked at in the lesson. So it's allowing all traffic from all sources, inbound and outbound. Now if we go to the subnet section and just widen the VPC area here, you can see there's no subnets associated with the VPC we just created. So that means we won't be able to launch any instances into our VPC. And to prove it, I'll just show you. We'll go to the EC2 section. So this is a glimpse into your future. This is what we'll be looking at in the next lesson. And we'll just quickly try and launch an instance. We'll select any instance, it doesn't matter. Any size, not important. So here, the network section, if I try and select Simplilearn VPC, it's saying no subnets found, this is not going to work. So we basically need to create some subnets in our VPC, and that is what we're going to look at in the next lesson. Now, private IP addresses are IP addresses that are not reachable over the internet, and they're used for communication between instances in the same network. When you launch a new instance, it's given a private IP address and an internal DNS hostname that resolves to the private IP address of the instance. But if you want to connect to this from the internet, it's not going to work. So then you'd need a public IP address, which is reachable from the internet. You can use public IP addresses for communication between your instances and the internet. Each instance that receives a public IP address is also given an external DNS hostname. Public IP addresses are associated with your instances from the Amazon pool of public IP addresses. When you stop or terminate your instance, the public IP address is released and a new one is associated when the instance starts. So if you want your instance to retain its public IP address, you need to use something called an elastic IP address. An elastic IP address is a static or persistent public IP address that's allocated to your account and can be associated to and from your instances as required. An elastic IP address remains in your account until you choose to release it. There is a charge associated with an elastic IP address if it's in your account but not actually allocated to an instance. This is a demonstration of how to create an elastic IP address. So we're back at the Amazon Web Services Management Console. We're going to head back down to the networking VPC section and we'll get to the VPC dashboard. On the left hand side we'll click on Elastic IPs. Now you'll see a list of any elastic IPs that you have associated in your account, and remember, any elastic IP address that you're using that isn't allocated to something you'll be charged for. So I have one available and that is allocated to an instance currently. So we want to allocate a new address, and it reminds you that there's a charge if you're not using it. I'm saying yes, allocate, and it takes a couple of seconds, and there's our new elastic IP address. Now we'll be using this IP address to associate with the NAT gateway when we build that. AWS defines a subnet as a range of IP addresses in your VPC. You can launch AWS resources into a subnet that you select. You can use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. The net mask for the default subnet in your VPC is always 20, which provides up to 4,096 addresses per subnet, and a few of them are reserved for AWS use. A VPC can span multiple availability zones, but a subnet is always mapped to a single availability zone. This is important to know. So here's our basic diagram, which we're now going to start adding to. So we can see the virtual private cloud, and you can see the availability zones. And now inside each availability zone, we've created a subnet. Now you won't be able to launch any instances unless there are subnets in your VPC. So it's good to spread them across availability zones for redundancy and failover purposes. There's two different types of subnet, public and private. You use a public subnet for resources that must be connected to the internet, for example web servers. A public subnet is made public because the main route table sends the subnet's traffic that is destined for the internet to the internet gateway, and we'll touch on internet gateways next. Private subnets are for resources that don't need an internet connection or that you want to protect from the internet, for example database instances. So in this demonstration we're going to create some subnets, a public and a private subnet, and we're going to put them in our custom VPC in different availability zones. So we'll head to Networking and VPC, wait for the VPC dashboard to load up. We'll click on Subnets. We'll go to Create Subnet. And I'm going to give the subnet a name. So it's good to give them meaningful names. So I'm going to call this first one for the public subnet 10.0.1.0, and I'm going to put this one in the US East 1B availability zone, and I'm going to call it Simplilearn Public. So it's quite a long name, I understand, but at least it makes it clear for what's going on in this example. So we need to choose a VPC. So we obviously want to put it in our Simplilearn VPC. And I said I wanted to put it in US East 1B. I'm using the North Virginia region, by the way. So we click on that. Then we need to give it the CIDR block. Now, as I mentioned earlier, when I typed in the name, that's the range I want to use. And then we need to give it the subnet mask. And we're going to go with 24, which should give us 251 addresses in this range, which obviously is going to be more than enough. If I try and put a different value in that's unacceptable to Amazon, it's going to say, it's going to give me an error and tell me not to do that. Let's go back to 24 and click. I'm going to cut and paste this, by the way, just because I need to type something very similar for the next one. Click Create. And it takes a few seconds. Okay, so there's our new subnet, and I just widen this. You can see, so that's the IP range, that's the availability zone, it's for Simplilearn, and it's public. So now we want to create the private. So we put the name in. I'm going to give the private the IP address block of that. I'm going to put this one in US East 1C, and it's going to be the private subnet. Obviously I want it to be in the same VPC, availability zone of US East 1C, and we're going to give it 10.0.2.0/24, and we'll click Yes, Create. And again, it takes a few seconds. Okay, so let me sort by name. So there we are, we can see now we've got our private subnet and our public subnet. In fact, let me just type in Simplilearn, there we are. So now you can see them both there. And you can see they're both in the same VPC, Simplilearn VPC. Now if we go down to the bottom, you can see the route table associated with these VPCs. And you can see that they can communicate with each other internally, but there's no internet access. So that's what we need to do next. In the next lesson, you're going to learn about internet gateways and how we can make these subnets have internet access. Welcome to the networking section. In this section, we're going to take a look at internet gateways, route tables, and NAT devices. And we'll have a demonstration on how to create each of these AWS VPC items. So to allow your VPC the ability to connect to the internet, you need to attach an internet gateway. And you can only attach one internet gateway per VPC. So attaching an internet gateway is the first stage in permitting internet access to instances in your VPC. Now here's our diagram again, and now we've added the internet gateway, which is providing the connection to the internet to your VPC. But before you can configure internet correctly, there's a couple more steps. For an EC2 instance to be internet connected, you have to adhere to the following rules. Firstly, you have to attach an internet gateway to your VPC, which we just discussed. Then you need to ensure that your instances have public IP addresses or elastic IP addresses, so they're able to connect to the internet. Then you need to ensure that your subnet's route table points to the internet gateway, and you need to ensure that your network access control and security group rules allow relevant traffic to flow to and from your instance. So you need to allow the rules to let in the traffic you want, for example HTTP traffic. After the demonstration for this section, we're going to look at how route tables, access control lists and security groups are used. In this demonstration, we're going to create an internet gateway and attach it to our custom VPC. So let's go to Networking VPC, bring up the VPC dashboard, and on the left hand side we click on Internet Gateways. So here's a couple of internet gateways I have already, but I need to create a new one. So create Internet Gateway. I'll give it a name, which is going to be Simplilearn Internet Gateway, IGW, and I'm going to click Create. So this is an internet gateway which will connect a VPC to the internet, because at the moment our custom VPC has no internet access. So there it's created, Simplilearn IGW, but its state is detached because it's not attached to anything. So let me try and attach it to a VPC, and it gives me an option of all the VPCs that have no internet gateway attached to them currently. So I only have one, which is Simplilearn VPC. Yes, attach. Now you can see our VPC has internet attached, and you can see that down here. So let's click on that, and it will take us to our VPC. But before any instances in our VPC can access the internet, we need to ensure that our subnet route table points to the internet gateway. And we don't want to change the main route table, we want to create a custom route table. And that's what you're going to learn about next. A route table determines where network traffic is directed. It does this by defining a set of rules. Every subnet has to be associated with a route table, and a subnet can only be associated with one route table. However, multiple subnets can be associated with the same route table. Every VPC has a default route table, and it's good practice to leave this in its original state and create a new route table to customize the network traffic routes associated with your VPC. So here's our example, and we've added two route tables, the main route table and the custom route table. The new route table, or the custom route table, will tell the internet gateway to direct internet traffic to the public subnet. But the private subnet is still associated to the default route table, the main route table, which does not allow internet traffic to it. All traffic inside the private subnet is just remaining local. In this demonstration, we're going to create a custom route table, associate it with our internet gateway, and associate our public subnet with it. So let's go to networking and VPC. The dashboard will load and we're going to go to route tables. Now our VPC only has its main route table at the moment, the default one it was given at the time it was created. So we want to create a new route table and we want to give it a name. So we're going to call it Simplilearn. I'm going to call it route table, RTB for short. And then we get to pick which VPC we want to put it in. So obviously we want to use Simplilearn VPC. So we click create. It'll take a couple of seconds and here you are. Here's our new route table. So what we need to do now is change its route so that it points to the internet gateway. So if we go down here to routes, at a minute you can see it's just like our main route table. It just has local access. So we want to click on edit and we want to add another route. So the destination is the internet, which is all the zeros, and our target, and we click on this, it gives us the option of our internet gateway, which we want to do. So now we have internet access to this to this route table. And we click on save. Save was successful. So now we can see that as well as local access, we have internet access. Now at the moment, if we click on subnet associations, you do not have any subnet associations. So basically both our subnets, the public and private subnets, are associated with the main route table, which doesn't have internet access. So we want to change this. So we'll click on edit and we want our public subnet to be associated with this route table. So click on save. So it's just saving that. So now we can see that our public subnet is associated with this route table, and this route table is associated with the internet gateway. So now anything we launch into the public subnet will have internet access. But what if we wanted our instances in the private subnet to have internet access? Well, there's a way of doing that with a NAT device, and that's what we're going to look at in the next lecture. You can use a NAT device to enable instances in a private subnet to connect to the internet or other AWS services, but prevent the internet from initiating connections with the instances in the private subnet. So we talked earlier about public and private subnets to protect your assets from being directly connected to the internet. For example, your web server would sit in the public subnet and your database in the private subnet, which has no internet connectivity. However, your private subnet database instance might still need internet access or the ability to connect to other AWS resources. If so, you can use a network address translation device or a NAT device to do this. A NAT device forwards traffic from your private subnet to the internet or other AWS services and then sends the response back to the instances. When traffic goes to the internet, the source IP address of your instance is replaced with the NAT device address, and when the internet traffic comes back again, the NAT device translates the address to your instance's private IP address. So here's our diagram, which is getting ever more complicated, and if you look in the public subnet, you can see we've now added a NAT device, and you have to put NAT devices in the public subnet so that they get internet connectivity. AWS provides two kinds of NAT devices, a NAT gateway and a NAT instance. AWS recommends a NAT gateway as it's a managed service that provides better availability and bandwidth than NAT instances. Each NAT gateway is created in a specific availability zone and is implemented with redundancy in that zone. A NAT instance is launched from a NAT AMI, an Amazon Machine Image, and runs as an instance in your VPC. So it's something else you have to look after, whereas a NAT gateway, being a fully managed service, means once it's installed, you can pretty much forget about it. A NAT gateway must be launched into a public subnet because it needs internet connectivity. It also needs an elastic IP address, which you can select at the time of launch. Once created, you need to update the route table associated with your private subnet to point internet-bound traffic to the NAT gateway. This way, the instances in your private subnets can communicate with the internet.
So if you remember back to the diagram when we had the custom route table, which was pointed to the internet gateway, now we're pointing our main route table to the NAT gateway, so that the private subnet also gets internet access, but in a more secure manner. Welcome to the Create a NAT Gateway demonstration, where we're going to create a NAT gateway so that the instances in our private subnet can get internet access. So we'll start by going to Networking and VPC. And the first thing we're going to do is take a look at our subnets, and you'll see why shortly. So here are our Simplilearn subnets. So this is the private subnet that we want to give internet access. But if you remember from the section, NAT gateways need to be placed in public subnets. So I'm just going to copy the name of this subnet ID for the public subnet, and you'll see why in a moment. So then we go to NAT gateways on the left hand side, and we want to create a new NAT gateway. So we have to put a subnet in there. So we want to choose our public subnet. Now, as you can see, it truncates a lot of the subnet names on this option, so it's a bit confusing. So we know that we want to put it in our Simplilearn VPC in the public subnet, but you can see it's truncated. So it's actually this one at the bottom, but what I'm going to do is just paste in the subnet ID, which I copied earlier, so there's no confusion. Then we need to give it an elastic IP address. Now, if you remember from the earlier demonstration, we created one, so let's select that. But if you hadn't allocated one, you could click on the Create New EIP button. So we'll do that. Okay, so it's telling me my NAT gateway has been created. And in order to use your NAT gateway, ensure that you edit your route table to include a route with a target of, and then our NAT gateway ID. So it's given us the option to click on our edit route tables. So we'll go straight there. Now here's our route tables. Now here's the custom route table that we created earlier, and this is the default, the main route table, which was created when we created our VPC. So we should probably give this a name so that we know what it is. So let me just call this Simplilearn RTB main. So now we know that's our main route table. So if you take a look at the main route table and the subnet associations, you can see that our private subnet is associated with this table. So what we need to do is put a route in here that points to the NAT gateway. So if we click on routes and edit, and we want to add another route, and we want to say that all traffic can either go to the Simplilearn internet gateway, which we don't want to do. We want to point it to our NAT instance, which is this NAT ID here, and we click save. So now any instances launched in our private subnet will be able to get internet access via our NAT gateway.
Welcome to the Using Security Groups and Network ACL section. In this section, we're going to take a look at security groups and network ACLs, and we're going to have a demonstration on how you create both of these items in the Amazon Web Services console.
A security group acts as a virtual firewall that controls the traffic for one or more instances. You add rules to each security group that allow traffic to or from its associated instances. Basically, a security group controls the inbound and outbound traffic for one or more EC2 instances. Security groups can be found on both the EC2 and VPC dashboards in the AWS Web Management Console. We're going to cover them here in this section, and you'll see them crop up again in the EC2 lesson. And here is our diagram, and you can see we've now added security groups to it. And you can see that EC2 instances are sitting inside the security groups, and the security groups will control what traffic flows in and out. So let's take a look at some examples, and we'll start with a security group for a web server. Now obviously a web server needs HTTP and HTTPS traffic as a minimum to be able to access it. So here is an example of the security group table, and you can see we're allowing HTTP and HTTPS, the ports that are associated with those two, and the sources, and we're allowing it from the internet. We're basically allowing all traffic to those ports. And that means any other traffic that comes in on different ports would be unable to reach the security group and the instances inside it. Let's take a look at an example for a database server security group. Now imagine you have a SQL Server database, then you would need to open up the SQL Server port so that people can access it, which is port 1433 by default. So we've added that to the table and we've allowed the source to come from the internet. Now, because it's a Windows machine, you might want RDP access, so you can log on and do some administration. So we've also added RDP access to the security group. Now, you could leave it open to the internet, but that would mean anyone could try and hack their way into your box. So in this example, we've added a source IP address of 10.0.0.0.0. So only IP ranges from that address can RDP to the instance. Now there's a few rules associated with security groups. By default, security groups allow all outbound traffic. So if you want to tighten that down, you can do so in a similar way to you can define the inbound traffic. Security group rules are always permissive. You can't create rules that deny access, so you're allowing access rather than denying it. Security groups are stateful, so if you send a request from your instance, the response traffic for that request is allowed to flow in regardless of the inbound security group rules. And you can modify the rules of a security group at any time, and the rules are applied immediately. Welcome to the Create Security Group demonstration, where we're going to create two security groups, one to host DB servers and one to host web servers. Now, if you remember from the best practices section, it said it was always a good idea to tier your applications into security groups, and that's exactly what we're going to do. So if we go to networking and VPC to bring up the VPC dashboard, on the left hand side under security, we click on security groups. Now you can also get to security groups from the EC2 dashboard as well. So here's a list of my existing security groups, but we want to create a new security group. And we're going to call it Simplilearn Web Server SG Security Group. And we'll give the group name as the same. And our description is going to be Simplilearn Web Servers Security Groups. Okay, and then we need to select our VPC. Now it defaults to the default VPC, but obviously we want to put it in our Simplilearn VPC. So we click Yes, Create. Takes a couple of seconds. And there it is. There's our new security group. Now if we go down to the rules, the inbound rules, you can see there are none. So by default, a new security group has no inbound rules. But what about outbound rules? If you remember from the lesson, a new security group by default allows all traffic to be outbound. And there you are. All traffic has destination of everywhere. So all traffic is allowed. But we want to add some rules. So let's click on inbound rules. Click on edit. Now this is going to be a web server. So if we click on the drop down, we need to give it HTTP. So you can either choose custom TCP rule and type in your own port ranges, or you can just use the ones they have for you. So HTTP. This pre-populates the port range, and then here you can add the source. Now if I click on it, it's giving me the option of saying allow access from different security groups. So you could create a security group and say I only accept traffic from a different security group, which is a nice way of securing things down. You could also put in here just your IP address so that only you could do HTTP requests to the instance. But because it's a web server, we want people to be able to see our website, otherwise it's not going to be much use. So we're going to say all traffic, so all source traffic can access our instance on port HTTP 80. I want to add another rule because we also want to do HTTPS, which is hiding from me. There we are. And again, we want to do the same. And also, because this is going to be a Linux instance, we want to be able to connect to the Linux instance to do some work and configuration. So we need to give it SSH access. And again, it would be good practice to tie it down to your specific IP or an IP range, but we're just going to do all for now. And then we click on save, and there we are, there we have our ranges. So now we want to create our security group for our DB servers. So let's click create security group, and then we'll go through it and give it a similar name, Simplilearn DB servers SG. And the description is going to be Simplilearn DB servers security group. And our VPC is obviously going to be Simplilearn VPC. So let's click yes, create. We'll wait a few seconds. And here's our new security group. As you can see, it has no inbound rules by default, and outbound rules allow all traffic. So this is going to be a SQL Server database server. And so we need to allow SQL Server traffic into the instance. So we need to give it Microsoft SQL port access. Now the default port for Microsoft SQL Server is 1433. Now in reality, I'd probably change the port the SQL Server was running on to make it more secure, but we'll go with this for now. And then the source. So we could choose the IP ranges again, but what we want to do is place the DB server in the private subnet and allow the traffic to come from the web server. So the web server will accept traffic, and the web server will then go to the database to get the information it needs to display on its on the website. Or if people are entering information into the website, we want the information to be stored in our DB server. So basically, we want to say that the DB servers can only accept SQL Server traffic from the web server security group. So we can select the Simplilearn web server security group as the source traffic for Microsoft SQL Server data. So we'll select that. Now our SQL Server is obviously going to be a Windows instance, so from time to time we might need to log in and configure it. So we want to give RDP access. Now again, you would probably put a specific IP range in there. We're just going to do all traffic for now. Then we click save. And there we are. So now we have two security groups, DB servers and web servers. A network ACL is a network access control list, and it's an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets. You might set up network ACLs with rules similar to your security groups in order to add an additional layer of security to your VPC. Here is our network diagram, and we've added network ACLs to the mix. Now you can see they sit somewhere between the root tables and the subnets. This diagram makes it a little bit clearer, and you can see that a network ACL sits in between a root table and a subnet. And also you can see an example of the default network ACL, which is configured to allow all traffic to flow in and out of the subnets to which it's associated. Each network ACL includes a rule, whose rule number is an asterisk. This rule ensures that if a packet doesn't match any of the other numbered rules, it's denied. You can't modify or remove this rule. So if you take a look at this table, you can see on the inbound, some traffic would come in and it would look for the first rule, which is 100. And that's saying I'm allowing all traffic from all sources. So that's fine, the traffic comes in. If that rule 100 wasn't there, it would go to the asterisk rule. And the asterisk rule is saying traffic from all sources is denied. Let's take a look at the network ACL rules. Each subnet in your VPC must be associated with an ACL. If you don't assign it to a custom ACL, it will automatically be associated to your default ACL. A subnet can only be associated with one ACL. However, an ACL can be associated with multiple subnets. An ACL contains a list of numbered rules which are evaluated in order, starting with the lowest. As soon as a rule matches traffic, it's applied regardless of any higher numbered rules that may contradict it. AWS recommends incrementing your rules by a factor of 100, so there's plenty of room to implement new rules at a later date. Unlike security groups, ACLs are stateless. Responses to allowed inbound traffic are subject to the rules for outbound traffic. Welcome to the network ACL demonstration, where we're just going to have an overview of ACLs where they are in the dashboard. Now, you don't need to know a huge amount about them for the exam, you just need to know how they work and where they are. So let's go to networking and VPC. And when the dashboard loads, on the left hand side under security there's network ACLs. So let's click on that. Now you can see some ACLs that are in my AWS account. So we want the one that's associated with our Simplilearn VPC. So if we extend this VPC column, that's our network ACL there, Simplilearn VPC. Now let's give it a name because it's not very clear to see otherwise. Also, I'm kind of an obsessive tagger. So let's call it Simplilearn ACL and click on the tick. So now it's much easier to see. So we click on inbound rules. So this is exactly what we showed you in the lesson. The rule is 100. So that's the first rule that's going to get evaluated, and it's saying allow all traffic from all sources. And the outbound rules are the same. So if you wanted to tighten down the new rule, you could click edit. We'll give it a new rule number, say, which would be 200. So you should always increment them in 100. So that means if you had 99 more rules you needed to put in place, you'd have space to put them in between these two. And then you could do whatever you wanted. You could say, you know, we are allowing HTTP access from all traffic, and we're allowing, or you could say, actually, you know what, we're going to deny it. So this is the way of blacklisting traffic into your VPC. Now I'm not going to save that because we don't need it. But this is where network ACLs sit, and this is where you would make any changes. It's also worth having a look at the subnet associations with your ACL. So we have two subnets in our Simplilearn VPC, so we would expect to see both of them associated with this network ACL because it's the default. And there they are. There's both our public and our private subnets are associated. And you can also see up here on the dashboard, it says default. So this is telling us this is our default ACL. If you did want to create a new network ACL, you would click create network ACL. You'd give it a name, just say new ACL, and then you would associate it with your VPC. So we would say Simplilearn VPC. Takes a few seconds, and there we are. There we have our new one. Now you can see this one says default no, because it obviously isn't the default ACL for our Simplilearn VPC, and it has no subnets associated with it. So let's just delete that because we don't need it. But there you are. There's a very brief overview of network ACLs.
Welcome to the Amazon VPC Best Practices and Costs, where we're going to take a look at the best practices and the costs associated with the Amazon Virtual Private Cloud.
Always use public and private subnets. You should use private subnets to secure resources that don't need to be available to the internet, such as database services. To provide secure internet access to the instances that reside in your private subnets, you should provide a NAT device. When using NAT devices, you should use a NAT gateway over NAT instances because they're a managed service and require less administration effort. You should choose your CIDR blocks carefully. Amazon VPC can contain from 16 to 65,536 IP addresses, so you should choose your CIDR block according to how many instances you think you'll need. You should also create separate Amazon VPCs for development, staging, test and production, or create one Amazon VPC with separate subnets, with a subnet each for production, development, staging and test. You should understand the Amazon VPC limits. There are various limitations on the VPC components. For example, you're allowed 5 VPCs per region, 200 subnets per VPC, 200 route tables per VPC, 500 security groups per VPC, 50 in- and outbound rules per VPC. However, some of these rules can be increased by raising a ticket with AWS support. You should use security groups and network ACLs to secure the traffic coming in and out of your VPC. Amazon advises to use security groups for whitelisting traffic and network ACLs for blacklisting traffic. Amazon recommends tiering your security groups. You should create different security groups for different tiers of your infrastructure architecture inside VPC. If you have web tiers and DB tiers, you should create different security groups for each of them. Creating tier-wise security groups will increase the infrastructure security inside the Amazon VPC. So if you launch all your web servers in the web server security group, that means they'll automatically all have HTTP and HTTPS open. Conversely, the database security group will have SQL Server ports already open. You should also standardize your security group naming conventions. Following a security group naming convention allows Amazon VPC operation and management for large-scale deployments to become much easier. Always span your Amazon VPC across multiple subnets in multiple availability zones inside a region. This helps in architecting high availability inside your VPC. If you choose to create a hardware VPN connection to your VPC using Virtual Private Gateway, you are charged for each VPN connection hour that your VPN connection is provisioned and available. Each partial VPN connection hour consumed is billed as a full hour. You'll also incur standard AWS data transfer charges for all data transferred via the VPN connection. If you choose to create a NAT gateway in your VPC, you are charged for each NAT gateway hour that your NAT gateway is provisioned and available. Data processing charges apply for each gigabyte processed through the NAT gateway. Each partial NAT gateway hour consumed is billed as a full hour. This is the practice assignment for designing a custom VPC, where you'll create a custom VPC using the concepts learnt in this lesson. Using the concepts learnt in this lesson, recreate the custom VPC as shown in the demonstrations. The VPC name should be Simplilearn VPC. The CIDR block should be 10.0.0.0/16. There should be two subnets, one public with a range of 10.0.1.0 and one private with a range of 10.0.2.0, and they should be placed in separate availability zones. There should be one internet gateway and one NAT gateway, and also one custom route table for the public subnet. Also create two security groups, Simplilearn Web Server Security Group and Simplilearn DB Server Security Group.
So let's review the key takeaways from this lesson.
Amazon Virtual Private Cloud, or VPC, enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center, but with the benefits of using scalable infrastructure of AWS. There are three types of IP address in AWS. A private IP address. This is an IP address that's not reachable over the internet, and it's used for communication between instances in the same network. A public IP address is reachable from the internet, which you can use for communication between your instances and the internet. And there's an elastic IP address. This is a static, public, persistent IP address that persists after an instance restarts, whereas a public IP address is reassociated after each restart. Amazon defines a subnet as a range of IP addresses in your VPC. You can launch AWS resources into a subnet that you select, and a subnet is always mapped to a single availability zone. Use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. To allow your VPC the ability to connect to the internet, you need to attach an internet gateway to it, and you can only attach one internet gateway per VPC. A route table determines where network traffic is directed. It does this by defining a set of rules. Every subnet has to be associated with a route table, and a subnet can only have an association with one route table. However, multiple subnets can be associated to the same route table. And you can use a NAT device to enable instances in a private subnet to connect to the internet or other AWS services. but a NAT device will prevent the internet from initiating connections with instances inside your private subnet. A security group acts as a virtual firewall that controls the traffic for one or more instances. You add rules to each security group that allow traffic to or from its associated instances. A network access control list, or network ACL, is an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets.
Today's session is on AWS SageMaker. Let's look into what we have in our today's session. So what's in it for you? We would be covering what is AWS, why do we need AWS SageMaker, what is AWS SageMaker Services, what are the benefits of using the AWS SageMaker, machine learning with AWS SageMaker, how to train a model with AWS SageMaker, how to validate a model with AWS, and the companies that are using AWS SageMaker. Along with that, we will be covering up one live demo on the AWS platform. Now let's understand what is AWS. So what is AWS? It's an Amazon Web Services. It's the largest or most widely used public cloud platform offered by Amazon. It provides services over the internet. AWS services can be used to build, monitor, and deploy any type of application in the cloud. AWS also uses the subscription pricing model. That means you only pay for whatever the services you use for. Now, why do we need AWS SageMaker? Let's look into it. So let's consider an example of one of the company, that is ProQuest. Now, before AWS SageMaker, the ProQuest is a global information content and technology company that provides valuable content such as ebooks, newspapers, etc. to the users. Before AWS SageMaker, the ProQuest requirement was to have a better user experience, maximum relevant search results. Now, after AWS SageMaker, they were able to achieve those results. So they achieved more appealing video user experience. They achieved more relevant search results for the users. Now, what do we mean by AWS SageMaker? Why this service is primarily used? So Amazon SageMaker is a cloud machine learning platform that helps users in building, training, tuning, and deploying machine learning models in a production-ready hosted environment. So it's kind of a machine learning service which is already hosted on the AWS platform. Now, what are the benefits of using AWS SageMaker? The key benefits of using AWS SageMaker are: it reduces machine learning data cost, so you can do the cost optimization while running this particular service on the AWS. All ML components are stored in a particular place in a dashboard, so they can be managed together. Highly scalable, so it can be scalable you can scale this particular service on the fly. It trains the models quite faster, maintains the uptime, so you can be assured that your workloads will be running all the time. It will be available all the time. High data security, so security becomes a major concern on the cloud platforms, and it ensures that you have the high data security. Along with that, you can do a data transfer to different AWS services like S3 bucket and all with the simple data transfer techniques. Now, machine learning with AWS SageMaker, let's look into it. So machine learning with AWS SageMaker is a three-step function. So one is to build, second is to test and tune the model, and third is to deploy the model. Now, with the build, it provides more than 15 widely used ML algorithms for training purpose. Now, to build a model, you can collect and prepare training data, or you can select from the Amazon S3 bucket also. Choose and optimize the required algorithm. So some of the algorithms that you can select are k-means, linear regressions, logistic regression. SageMaker helps developers to customize ML instances with the Jupyter Notebook interface. In the test and tune, you have to set up and manage the environment for training. So you would need some sample data to train the model. So train and tune a model with the Amazon SageMaker. SageMaker implements hyperparameter tuning by adding a suitable combination of algorithm parameters. Also, it divides the training data and stores that in the Amazon S3. S3 is a simple storage service which is primarily used for storing the objects and the data. Hence, it is used for storing and recovering data over the internet. And below you can see that AWS SageMaker uses Amazon S3 to store data as it's safe and secure. Also, it divides the training data and stores in Amazon S3, where the training algorithm code is stored in the ECR. ECR stands for Elastic Container Registry, which is primarily used for containers and Dockers. ECR helps users to save, monitor, and deploy Docker and the containers. Later, SageMaker sets up a cluster for the input data, trains it, and stores it in the Amazon S3 itself. So this is done by the SageMaker itself. After that, you need to deploy it. So suppose you want to predict limited data at a time, you use Amazon SageMaker hosting services for that. Okay. But if you want to get prediction for an entire data set, prefer using Amazon SageMaker batch transform. Now, the last step, that is to deploy the model. So once tuning is done, models can be deployed to SageMaker endpoints. And in the endpoint, real-time prediction is performed. So you would have some data which you would reserve and validate your model whether it is working correctly or not. Now evaluate your model and determine whether you have achieved your business goals. Now the other aspect is how we can train a model with AWS SageMaker. So this is basically a flow diagram which shows you how to train a model with the AWS SageMaker, and here we have used a couple of services of an AWS to get that done. So model training in AWS SageMaker is done on machine learning compute instances, and here we can see there are two machine learning compute instances used as helper code and the training code. Along with that, we are using two S3 buckets and the ECR for the container registry. Now let's look into what are the ways to train the model as per the slides. So below are the following requirements to train a model. So here in the diagram you can see these are the following requirements to train a model. The URL of an Amazon S3 bucket where the training data is stored, that is mentioned. The compute resources on machine learning compute instances. So these are all your machine learning compute instances. Then the URL of an Amazon S3 bucket where the output will be stored, and the path of AWS Elastic Container Registry where the code data is saved. The inference code image lies in the Elastic Container Registry. Now what are these called? These are called as the training jobs. Now when a user trains a model in Amazon SageMaker, he/she creates a training job. So we need to first create a training job, and then the input data is fetched from the specified Amazon S3 bucket. Once the training job is built, Amazon SageMaker launches the ML compute instances. So these compute instances will be launched once the training job is built. Then it trains the model with the training code and the data set, and it shows the output and model artifacts in the AWS S3 bucket. So this is done automatically. Now here the helper code performs a task when the training code fails. The interference code, which is in the Elastic Container Registry, consists of multiple linear sequence containers that process the request for inference on data. The EC2 container registry is a container registry that helps users to save, monitor, and deploy container images, whereas container images are the ready applications. Once the data is trained, the output is stored in the specified Amazon S3 bucket. So here you can see the output will be stored here. To prevent your algorithm being deleted, save the data in Amazon SageMaker critical system, which can process your ML compute instances. Now how to validate a model? Let's look into it. So you can evaluate your model using offline or using the historical data. So first thing is that you can do the offline testing to validate a model. You can do an online testing with the live data. So if you have a live data coming or real-time streams coming, you can validate a model from there itself. You can validate using a holdout set, and also you can validate using the k-fold validation. Now use historical data to send requests to the model through the Jupyter Notebook in Amazon SageMaker for the evaluation. Online testing with live data deploys multiple models into the endpoints of Amazon SageMaker and directs live traffic to the model for validation. Validating using a holdout set is part of the data is set aside, which is called holdout set. So the part of the data is left, which is basically called as the holdout set. This data is not used for the model training. So later when the model is trained, with the remaining input data and generalize the data based on what is learned initially. So whatever the data which is left out will be used for validating a model, because we have not used that data while training a model. The k-fold validation is the input data is split into two parts. One part is called k, which is the validation data for testing the model, and the other part is k-1, which is used as a training data. Now, based on the input data, the machine learning model evaluates the final output. Now, the companies that are using AWS SageMaker, one is the ADP. So you must be knowing about ADP, Zalando, Dow Jones, which is on the stock market, ProQuest, and the Intuit. Now let's look into the demo that how we can actually run the AWS SageMaker. So we'll use the R algorithm and then package the algorithm as a container for building, training, and deploying a model. We are going to use the Jupyter Notebook for that, for model building, for model training, for model deployment, and the code for the demo is in the below link. So you can see here that from this link you can get the code for the demo. Let's try to do a demo on the AWS. Now I would be using a link which is provided by Amazon to build, train, and deploy the machine learning model on the SageMaker, as you can see on my screen. And in this tutorial, you would have some steps where you can put those steps and the code, Python codes, into your AWS SageMaker Jupyter Lab. So in this tutorial, you will learn how to use Amazon SageMaker to build, train, and deploy a machine learning model. And for that, we will use the popular XGBoost ML algorithm for this exercise. So first of all, what you need to do is you have to go to the AWS console, and there you have to create a notebook instance. So in this tutorial, you will be creating a notebook instance. You will prepare the data, train the model to learn from the data, deploy the model, evaluate your ML model's performance, and once all those activities are done, then we'll see how we can actually remove all the resources in order to prevent the extra costing. Now the first step is we have to enter to the Amazon SageMaker console. So here you can see I'm already logged in into the SageMaker console. You can click on the services, search for the SageMaker here, and here you get the Amazon SageMaker service. Now the next step is that we have to create a notebook instance. So we will select the notebook instance from the SageMaker service, and then after the notebook instance is selected, we'll put a name to our instance and we'll create a new IAM role for that. So let's wait for the SageMaker Studio to open. So here you can see the Studio is open, and you just have to click on the notebook instances, and here you have to create a notebook instance. So here you can see a couple of notebook instances have already been created. One of them is in service. So this is the notebook instance that we are going to use for creating the demo model. I'll show you how you can create a notebook instance. You just have to click on Create Notebook Instance button and put your notebook instance name. So you can put something like demo-SageMaker 987, or we can put it as model. We'll go with notebook instance type as default, which is mlt2.media. And in the permission and encryptions under the IAM role, we'll click on Create a new IAM role. Now why we are creating a new IAM role? So that we can allow the SageMaker to access any S3 bucket that has been created on our account. Just click on Create a role, and here you would see that the new IAM role will be created with the set of permissions. Then rest of the things we'll keep it as default, and then you just have to click on Create a notebook instance. The notebook instance creation takes some time, so you just have to wait for a couple of minutes to get that in service. We already have one of the notebook instance that has been created, so we will be using that to create a demo. Now going back to the steps, so these are the steps that we have already performed. Now once the notebook instance is created, then we have to prepare the data. So in this step, we will be using the SageMaker notebook instance to pre-process the data that would require to train the machine learning model. And for that, we would be opening up the Jupyter notebook, and then we have to select an environment, a kernel environment in the Jupyter notebook that would be conda_python 3. So let's follow these steps. go back to the SageMaker, click on the notebook instances, select the running notebook instance, and here you would select the Open Jupyter Lab. Now here you would see that the SageMaker would try to open up the Jupyter notepad, and we would be performing all our inputs into that Jupyter notebook and executing the results there itself. So just wait for the notebook to open. Now here you can see the Jupyter Lab notebook has been opened. So I would be selecting one of the notebook that has been created. So this one. So likewise you can create your own notebook also. How you can do that? First of all, let me select the kernel environment. So I would be selecting conda_python 3 and just click on select. So how you can create your own notebook? Just have to click on file, click on new, and here you can select the notebook. Just name your notebook, select the environment conda_python 3 to run this demo. So I have my notebook open. So in the tabs, I would be putting up the Python codes and I would be executing those codes to get the output directly. So the next step is to prepare the data, train the ML model and deploy it. We will need to import some libraries and define a few environment variables in the Jupyter Notebook environment. So I would be copying this code, which you can see that would try to import NumPy, Pandas. These are all required to run the Python syntax. So just copy this code and paste it into your notebook. Right? So once you do that, execute your code, and here you can see that you get the output, which is that it has imported all the necessary libraries that have been defined in the code. Now the next step is we would create an S3 bucket into the S3 service, and for that you have to copy this Python code, just that you have to edit it. So you have to specify this bucket name that you want to get created. So here I would provide the bucket name, which should be unique, should not overlap. So something like SageMaker -demo is the name that I have selected for the bucket. And now you have to execute that code. It says that the S3 bucket has been created successfully with the name SageMaker-demo 9876. So this is something which you can verify. So you can go to the S3 service and there you can verify whether the bucket has been created or not. Now the next task is that we need to download the data to the AWS SageMaker instance and load it into the data frame. And for that we have to follow this URL. So from this URL, which is build, train, deploy machine learning model, would have a data in the form of bank_clean.csv, and this will be deployed onto our SageMaker instance. We'll copy this code and paste it here and execute the code. So it says that it has successfully downloaded bank_clean.csv, which has the data inside it, and that has been loaded into the SageMaker data frame successfully. Now we have a data to build and train our machine learning model. So what we are going to do, we are going to shuffle the data and we are going to split it, one into the training data set and the other one into test data set. So for the training data set, we are going to use 70% of the customers that are listed in the CSV file, and 30% of the customers in the CSV file data, we will be using it as a test data to train the model. So we will copy the following code into a new code cell, and then we are going to run that code cell. So I'll just copy it for training the data so that we can segregate the data model, 70% for building the model and 30% for testing the data. So click on run the execution, and here you can see that we got the output successfully. Now we have to train the model from that data. So how we are going to train that model? And for that, we'll use SageMaker pre-built XGBoost model, which is an algorithm. So you will need to reformat the header and first column of the training data and load the data from the S3 bucket. So what I'll do is I'll copy this syntax and paste it in the node cell. So it has the train data. It would train the model. Click on run execution. Now it is changing the S3 input class, which will be renamed to training input, because now we are training the model with the training data. So we just have to wait for some time till it gets executed completely. Now the next thing is that we need to set up the Amazon SageMaker session to create an instance of the XGBoost model. So here we are going to create this SageMaker session. We are going to create an instance of the XGBoost model, which is an estimator. So just copy that code and paste it here. Execute it. And here you can see that it will start. It has basically changed the parameter image name to the image underscore URI in the SageMaker Python SDK v2. Now we'll follow the next step, that is with the data loaded in the XGBoost estimator, we'll set up train the model using gradient optimization. And we'll copy the following code, and that would actually start the training of the model. So copy this code, and this would actually start training the model using our input data that we have reserved, 70% of that data that we have reserved for training the model. So just copy that, again initiate the execution, and it will start the training job. Now we'll deploy the model, and for that I would copy the deploy code, put that in the cell, and execute it. So it says parameter image will be renamed to image URI and using already existing model. So XGBoost was deployed already. If you have not done that, if you're doing it the first time, so it will initiate another XGBoost instance. So where you can find your XGBoost endpoints created, you just have to scroll down, and here under the inference, click on the endpoints, and you should find the XGBoost endpoints defined here. So here you can see that today I have created one XGBoost endpoint, and that is now in process of creating. So just refresh it. So it is still created. It is going to take some time to get that in service. Now our endpoint is in service state, so now we can use it. So going forward with the next steps, we'll try to predict whether the customer in the test data enroll for the bank product or not. For that, we are going to copy this code, put that in the Jupyter cell function, and execute it. So here it gives you the output that it has actually evaluated, and the same output we got in the screenshot of the demo as well. Now we are going to evaluate the model performance. So what we are going to do, we are going to get the prediction done. So based on the prediction, we can conclude that you predicted a customer that will enroll for a certificate of deposit accurately for 90% of the customers in the test data, with a precision of 65% for enrolled and 90% which haven't enrolled for it. So for that, we are going to copy this code and execute it here in the cell. So if it is predicted correctly, that means our model is working absolutely fine. So here you can say the overall classification rate is 89.5%, and there is the accurate prediction that has been made by the model. And that's what the output we can see here in the screenshot of a model. So that means our model is absolutely working fine. It has been built, deployed, and trained correctly. Now the next thing is that once you are done with that, you terminate your resources, and for that you just have to copy this code and put that in the cell function so that the additional resources and the endpoints and the buckets that have been created by the Jupyter Notepad should be terminated, so that you would not be incurred with the extra costing. So just execute it, and here you would see that it would try to terminate all the additional resources that we have created from the Jupyter Notebook. Today's tutorial is on AWS CloudFront. Let's look into what we have today in the CloudFront. So what's in it for you? We would be covering up the concept of what is AWS, what was earlier before AWS CloudFront, after AWS CloudFront, what were the services that were introduced, how it benefited. What do we mean by AWS CloudFront, benefits of the using AWS CloudFront, and how AWS CloudFront actually is known as a content delivery service, the name of the companies that are using AWS CloudFront, and we would be covering up one live demo. Now, AWS is the Amazon Web Services. It's a cloud service provider that basically offers a multiple services, variety of services, such as compute power, database storage, networking, and other resources, so that you can create your solutions on the cloud and help the business grow. Now, with AWS, you only pay for whatever the services you use. So for example, if you are using a service for a couple of hours, then you pay for only that many hours that you have used that service. Before AWS CloudFront, so there is an example that we are going to talk, and that is you must be aware of an application called Spotify. So when you used to access Spotify, and when you click on it, it kept on loading, and at the end you used to get the error. And the error was that the connection failed. And why you received that error? Because of a latency issue, probably a network error, right? So how you can solve these kind of a latency issues, and that is also going to, these kind of an issues are also going to impact the performance of an application. So with the introduction of AWS CloudFront, this problem of loading the application got resolved. So after AWS CloudFront, with the help of AWS CloudFront, Spotify gives the facility of updating new features, access to million songs that you can access instantly. So with the use of AWS CloudFront, the latency issues were solved, and successfully you can basically access your application. Now, what we mean by AWS CloudFront? So AWS CloudFront is a globally distributed network that is offered by AWS, Amazon Web Services, which securely delivers content to the end users across any geography with a higher transfer speed and an improved or a low latency. Now, what are the benefits of AWS CloudFront? There are multiple benefits. One is the cost effective. So it helps you to do the cost optimization when you use the CloudFront. It is time saving, so it is implemented easily, and also a lot of issues with respect to accessing the application with respect to latency and all can be resolved. Content privacy, so the content is placed to the end users and also to the CloudFront servers in a secured manner, in a secured way. It is highly programmable, and you can make the changes, amend the changes on the fly, and you can target any location, any geography across the globe. Along with that, it helps you to get the content deliver quickly. Now, how AWS CloudFront delivers the content? Let's look into the architecture. So this is a flow, and the flow is with respect to how the user is going to get a content from the CloudFront. Now, the client first access a website by typing a URL on the browser, and in the step 1 it tries to access the application. Then the client requests, when the website is open, the client requests for an object to download, such as, for example, a particular file. Now at that time, the DNS routes user request to download that file to AWS CloudFront. The AWS CloudFront connects to the nearest edge locations. Edge locations are basically the servers where it caches the files, documents, and the web codes. AWS CloudFront connects to its nearest edge location in order to serve the user the request. At edge location, AWS CloudFront looks for its requested cache file. Once the file is found, let's say if the file is available in the cache of an edge location, AWS CloudFront then sends the file to the user. Otherwise, if the file is not found in the cache memory of an edge location, AWS CloudFront compares the requirement with the specification and share it with a respected server. That means a web server or a server where the file is actually available. The web server responds to the edge location by sending the file back to the CloudFront edge location. And then as soon as the AWS CloudFront receives the file, it shares with the client, also adds the file to the cache of an edge location for a future reference. This is how the flow of a CloudFront is. Now, the name of the companies that are using the AWS CloudFront. So one of them is Geo7 app, which is a very popular app. So it uses Amazon CloudFront to deliver 15 petabytes of audio and video to its subscribers globally, which is a huge data. Sky News, it uses the service in order to unify the content for faster distribution to subscribers. The Discovery Communications also uses the CloudFront. It uses the service for delivering API, static asset, and also the dynamic content. And then the TV1 EU, Streaming Europe, is basically also uses the CloudFront service that helps in improving latency and performance that results in fastest delivery of content. Now let's look into the demo how to use CloudFront to serve private S3 bucket as a website. Now I'm going to run a CloudFront distribution demo on the AWS console, and we'll basically try to deliver the content from a private S3 bucket and then map that with the domain name using the Route 53 service. So what we need for this demo, we would need a domain URL, we would need a Route 53 service, we would need CloudFront, we have to create a CloudFront distribution, and that will be linked with our S3 bucket, the private S3 bucket, right? And in the S3 bucket, we would have one HTML file, the index.html file. So let's move into AWS console. So right now I have opened up the CloudFront distribution, and here you can see that couple of distributions have already been created. So what I'm going to do, I'm going to create a distribution. Now there are two types of delivery method for your content. One is the web distribution and the other one is RTMP. RTMP stands for real-time audio or video distribution. It's basically used for distribution of a media content or a media file which are available in the S3 bucket. Here we are going to select a web distribution because primarily we will be using files which uses protocols HTTP or the HTTPS. So you have to click on Get Started, and in the origin domain name you have to specify the bucket where your code is available. So I have a bucket already created. Here you can do is you have to create a bucket with the URL name or the domain name which you would be mapping with the Route 53 service. So this is a bucket that has already been created. Let me show you in a new tab. So here you have to go to the storage. Under the storage, you have to select the S3 bucket. Let's open the link in the new tab and let's look into how we can create the S3 buckets. Now here are a couple of buckets already created. I have created one bucket with the domain name that I'm going to use and map it with the Route 53 service. So that is basically mapped to a region which is in Ohio. And if you open up this bucket, here you will find an HTML web page. The index.html has been already added, right? So similarly, you have to create a bucket with a domain, and an index.html page needs to be uploaded there. Now again, we'll go to the CloudFront. We'll try to create a distribution. Just have to click on Create Distribution. Select a web delivery method. Select an origin domain, which is sunshinelearning.in. And origin path, you don't have to specify. Origin ID is this one. So basically, when you define an origin domain name, automatically the origin ID appears. You can customize this origin ID as per your requirement also. So rest of the things, primarily we keep it as a default settings only until and unless if we require some customized settings to be done. So let's say if you have to change the cache behavior settings, you can do that. Otherwise, we'll keep it as default. Now in the distribution setting, you can either select use all edge locations for the best performance. So what does AWS basically do here? It uses all the edge locations which are associated with AWS across the globe. Otherwise, you can specify based on the regions also, right? Apart from that, if you want to enable firewalls or the access control list, you can specify here. And then what you need to do is in the default root object, here you have to specify your index.html page, which is in the S3 bucket. The distribution state has to be enabled, and if you want to use IP version 6 as well, you need to enable it. Click on create a distribution. Now you can see here a distribution has been created. It's in progress and it is enabled. And it takes around 15 to 20 minutes to get that distribution completed. The reason is that the web codes, the web pages will be distributed across all the edge locations across the globe, so hence it takes time to get that done, right? Well, let's move on to Route 53 service, and let's create the hosted zones. So we'll type Route 53 here, scalable DNS and domain name registration. And what we are going to do here is we are going to map our URL, the domains pointed to the name servers that will be provided by the Route 53. So we have to create a hosted zone. Let's wait for it. So now the Route 53 dashboard is open, and you can see one hosted zone is already created. So just click on the hosted zone. And in order to point the traffic from the external domains towards the AWS, you have to first point the domains traffic to the hosted zone in the Route 53. So I'll click on create hosted zone, but before that I will first delete the existing one, and then I'll create another record, another hosted zone, right? Put your domain name. Let's say I put as sunshinelearning.in, and it is acting as a public hosted zone. Rest of the things will be default. Click on create hosted zone. Now it gives you 4 name servers, and these 4 name servers has to be updated in the domain. So you have to update these name servers in a platform from where you have purchased the domain, right? So this is half of the work done. Then what you need to do is you have to go and create records. Now in the records, you can select a routing policy. So right now what we are targeting basically that the traffic from the domain should be pointed directly towards the CloudFront distribution. Hence we are going with a simple routing right now. Click on next. Here you have to specify the record sets. So we are going to create the records. Just click on define simple record. Put here as World Wide Web. And you have to select an endpoint. So endpoint we are selecting for the CloudFront distribution. So we have to specify alias for the CloudFront distribution. Now here we are going to put the CloudFront distribution URL, and then we are going to define the simple record set. So what we need is we need a CloudFront distribution URL, which you can find it from the CloudFront service itself, and you can find the domain name here itself. You just have to copy that and then paste it here in the distribution, and then just click on define simple records. Again click on create records, and here you can see the record set has been updated. Now this domain is basically pointed towards these name servers, which are further pointed towards the CloudFront distribution, right? Now the only thing which is left is that Within the domain, from wherever you have purchased the domain, you should update these phone name servers, and then you can see the live traffic coming on this domain will have an output from the CloudFront distribution. Today's topic is on AWS Autoscaling. So this is Akhil. I would be taking up a tutorial on the autoscaling. Let's begin with our tutorial, and let's look into what we have in today's session. So I would be covering up why we require AWS Autoscaling, what is AWS Autoscaling, what are the benefits of using the scaling service, how this autoscaling works, the different scaling plans we have, what is the difference between the snapshot and the AMI, what is the load balancer, and how many types of load balancers we have, and along with that I would be covering up a real live demo on the AWS. Let's begin with why we require AWS Autoscaling. Now, before AWS Cloud Scaling, there was a question in the mind of enterprises that they were spending a lot of money on the purchase of the infrastructure. If they have to set up some kind of a solution, so they have to purchase an infrastructure, and a one-time cost was required. So that was a burden for them in terms of procuring a server, hardware, software, and then having a team of experts to manage all those infrastructure. So they used to think that no longer they require these resources if there was a cost-efficient solution for their project. That was the project manager used to think. Now, after the AWS Cloud Scaling that was introduced, automatically the autoscaling maintains the application performance based on the user requirements at the lowest possible price. So what does the autoscaling does is that whenever there is a scalability required, it manages it automatically. And hence the cost optimization became possible. Now, what is AWS Autoscaling? Let's look into deep. So AWS Autoscaling is a service that helps users to monitor their applications and the servers and automatically adjust the capacity of their infrastructure to maintain the steadiness. So they can increase the capacity, they can even decrease the capacity also for the cost optimization. And also predictable performance at the lowest possible cost. Now, what are the benefits of autoscaling? It gave the better fault tolerance applications. You can get the servers created and you can have a clone copy of the servers so that you don't have to deploy the applications again and again. Better cost management because the scalability is decided by the AWS automatically based on some threshold parameters. It was a reliable service, and whenever the scaling is created or initiated, you can get the notifications onto your mail IDs or to your cell phones. Scalability, as I mentioned, is always there in the autoscaling. It can scale up, it can scale down as well. And it has the flexibility in terms of whenever you want to schedule it, if you want to stop it, if you want to keep the size of the servers at a fixed number, you can always make the changes on the fly. And the better availability. Now, with the use of the autoscaling, we come around with the terminology called snapshot and the AMI. Let's look into the difference between the snapshots and the AMI. Snapshots versus AMI. So in a company, there was one of the employee that was facing an issue with launching the virtual machines. So he asked his colleague a question. Is it possible to launch multiple virtual machines with a minimum amount of time? Because it takes a lot of time in terms of creating the virtual machines. The other colleague said that yes, it is possible to launch multiple EC2 instances, and that can be done at a lesser time and with the same configuration. And this can be done either you use a snapshot or the AMI on the AWS. Then the colleague said that what are the differences between the snapshot and AMI? Let's look into the difference now. The snapshots basically kind of a backup of a single EBS volume, which is just like a virtual hard drive that is attached to the EC2 instance. Whereas the AMI, it is basically used as a backup of an EC2 instance only. The snapshots opts for this when the instance contains multiple static EBS volumes. When you opt for the snapshot, whenever the instance contains multiple static EBS volumes. AMI, this is widely used to replace the failed EC2 instance. In the snapshots, here you pay only for the storage of the modified data, whereas with the AMI, you pay only for the storage that you use. The snapshots are non-bootable images on EBS volume, whereas AMI are bootable images on the EC2 instance. However, creating an AMI image will also create the EBS snapshots. Now, how does AWS Autoscaling work? Let's look into it. So for the AWS Autoscaling to work, you have to configure single unified scaling policy per application resource. And this scaling policy, with that you can explore the applications also. And then select the service you want to scale. Also, for the optimization, select, do you want to optimize the cost or do you want to optimize the performance? And then keep track of scaling by monitoring or getting the notifications. Now, what are the different scaling plans we have? So in the autoscaling, a scaling plan basically helps a user to configure a set of instructions for scaling based on the particular software requirement. The scaling strategy basically guides the service of AWS Autoscaling on how to optimize resources in a particular application. So it's basically kind of the parameters that you set it up so that how the resource optimization can be achieved in the autoscaling. With the scaling strategies, users can create their own strategy based on their required metrics and thresholds, and this can be changed on the fly as well. What are the two types of scaling policies we have? So there are basically dynamic scaling and the predictive scaling. Now, what is dynamic scaling? It basically guides the service of AWS Autoscaling on how to optimize the resources. And it is helpful in optimizing resources for availability and particular price. Now, with scaling strategies, users can create their plan based on the required metrics and thresholds. So a metric can be like, let's say, a network in, network out, or it can be a CPU utilization, memory utilization likewise. Now, in the predictive scaling, its objective is to predict future workload based on daily and weekly trends and regular forecast future network traffic. So it is kind of a forecast that happens based on the previous past experiences. It uses a machine learning technique for analyzing that network traffic, and this scaling is like how weather forecast works, right? It provides schedule scaling actions to ensure the resource capacity is available for application requirement. Now, with the auto scaling, you would need the load balancers also, because if there are multiple instances that are created, then you would need a load balancer to distribute the load to those instances. So let's understand what do we mean by a load balancer. A load balancer basically acts as a reverse proxy, and it is responsible for distributing the network or the application traffic across multiple servers. With the help of a load balancer, you can achieve a reliability, you can achieve a fault tolerance of an application. That is basically, it increases the fault tolerance and the reliability. So for example, when there is a high network traffic that is coming to your application, and if that much traffic comes to your application to the instances, your instances may crash. So how you can avoid that situation? So you need to manage the network traffic that is coming to your instances, and that can be done with the load balancer. So thanks to the AWS load balancers, which helps in distributing network traffic across backend servers in a way that it increases performance of an application. Here in the image, you can see the traffic coming from a different resources landing onto the EC2 instance, and the load balancer is actually distributing that traffic to all the three instances, hence managing the network traffic quite properly. Now, what are the types of load balancers we have? There are three types of load balancers on the AWS. One is the classic load balancer, second is the application load balancer, and the third one is the network load balancer. Let's look into what we have in the classic load balancer. So the classic load balancer is the most basic form of load balancing, and we call it as a primitive load balancer also, and it is widely used for the EC2 instances. It is based on the IP address and the TCP port, and it routes network traffic between end users as well as in between the backend servers. And it does not support host-based routing, and it results in low efficiency of resources. Let's look into what we have in the application load balancer. This is one of the advanced forms of load balancing. It performs a task on the application level in the OSI model. It is used when there are HTTP and HTTPS traffic routing is required, and also it supports the host-based and path-based routing and performs well with the microservices or the backend applications. The network load balancer performs the task at layer 4 of the connection level in the OSI module. The prime role of the network load balancer is to route the TCP traffic, and it can manage a massive amount of traffic and is also suitable to manage the low latencies. Let's look into the demo and see how practically we can create the autoscaling. Hi guys, let's look into the demo for how we can create an autoscaling on the AWS console. So right now I'm logged into the AWS console and I am in the Mumbai region. What you need to do is you have to go to the compute section, and under that click on the EC2 service. Let's wait for the EC2 service to come. Now just scroll down, and under the load balancing there is an option called autoscaling. So there first you have to create a launch configuration, and then after that you have to create the autoscaling groups. So click on launch configuration, and then you have to click on create launch configurations. So click on create launch configuration. Now this launch configuration is basically the set of parameters that you define while launching an autoscaling, so that this uniformity is maintained with all the instances. So that includes, let's say if you select a Windows OS or a Linux OS, that particular type of an operating system will be implemented in all the instances that will be part of an autoscaling. So there are certain set of parameters that we have to specify during the launch configuration so that we can have a uniformity in terms of launching the servers. So here I would select an Amazon Linux AMI, and then I would select the type of a server, which will be t2.micro. Click on configure details, put the name to the launch configuration. Let's say we put it as a demo, and the rest of the things we'll keep it default. Click on add storage. Since it's a Linux AMI, we can go with the 8 GB storage. That should be fine. Click on configure security group. Let's create a new security group which has the SSH port open, and that is open for anywhere, which is basically source IPv4 and IPv6 IPs. Any IP would be able to access that. Click on review. Just review your launch configuration. If you want to make changes, you can do that. Otherwise, click on create a launch configuration. You would need the key pair, and this key pair will be a unique key pair which will be used with all the instances that are part of the autoscaling group. So we can select an existing key pair if you have that. Otherwise, you can create a new key pair. So I have an existing key pair. I'll go with that, acknowledge it, and click on create launch configuration. Now we have successfully launched the configuration of an autoscaling. The next thing is to create an autoscaling group. So click on create an autoscaling group using this launch configuration. Put a group name. Let's say we put something like test, and the group size to start with, it says one instance. So that means at least a single instance will always be running, and it will be initiated and running 24/7 till the autoscaling is available. You can increase the size of the minimum base instances also. Let's say you can change it to 2 also. So you would get at least 2 servers running all the time. So we'll go with the one instance. The network would be the VPC default, and in the VPC particular region, we can select the availability zones. So let's say if I select availability zone 1A and then availability zone 1B. So how the instances will be launched? So one instance will be launched in 1A, the other one in the 1B, the third one in the 1A, fourth one in the 1B. Likewise, it will be equally spread among the availability zones. Next part is to configure the scaling policies. So click on it. If you want to keep this group at its initial size, let's say if you want to go with only a single instance or 2 instances and you don't want the scaling to progress, you can put it, keep this group at its initial size. So this is basically a way to halt the scaling. But we'll use the scaling policies to adjust the capacity of this group. So click on it. And we would scale between, let's say, minimum 1 instance that we have, and we'll scale it between 1 to 4 instances. And what condition, on what basis these instances will be scaled up or scaled down would be defined in the scale group size. So the scaling policies you can implement based on a scale group size or using the simple scaling policies using the steps. So in the scale group size, you have certain metrics. You can use average CPU utilization. You can define a metric related to average network in, average network out, or the load balancer request counts per target. And if you create the simple scaling policies using steps, then you need to create the alarms, and there you can get some more metrics that you can add up as a parameter for the auto scaling. Let's go with the scaling group size. Let's go with the metric type as average CPU utilization, and the target value here you have to specify what would be the threshold that when the instance CPU utilization is crossed, then a new instance should be initiated. So you can put a reasonable threshold for that. Let's say we put something like 85%, and whenever the instance CPU utilization is crossed 85% threshold, you will see that there will be a new instance created. Let's go to the next configure notifications, and here you can add notifications. So let's say if there is a new instance that is initiated and you want to basically be notified, so you can get notifications over your email IDs, or you can get it on the cell phones. So for that, for adding the notification, you would need the SNS service, and that is called as a simple notification service. And you have to create a topic there. You have to subscribe for the topic using your email ID, and then you should get the notifications. Click on configure tags. The tags are not mandatory. You can basically put a tag. Let's say if you want to identify the instance, what purpose it was created. Otherwise, you can leave it blank also. Click on review and review your scaling policies, notification, tags, as well as the scaling group details. Click on create auto scaling group, and here you go. Your scaling has been launched. Click on close, and you should get at least a single instance initiated automatically by the auto scaling. So let's wait for the details to appear. So here you can see our launch configuration name, demo, auto scaling group name, test, minimum instance we want 1, the maximum instances we want 4. We have selected 2 availability zones, AP South 1A, AP South 1B, and the instance 1 has been initiated. And if you want to verify where exactly this instance has been initiated, just click on the instances here, and here you will see that our single instance has been initiated, that is in service, and that has been initiated in AP South 1B. Now once the threshold of this instance crosses 85%, that is what we have defined in the scaling policies, then you should see that another instance will be initiated. So likewise, this is basically I have created steps to initiate a scaling policy, that means to increase the number of servers whenever the threshold crosses. Likewise, here itself you can add another policy to scale down the resources in case if the CPU utilization goes to a normal value.
Hello folks, welcome to yet another exciting video from Simplilearn. Are you ready to unlock the doors to a thriving career in cloud computing? The job market for AWS is booming, and companies are on lookout for talented individuals like you. AWS holds a significant 32% share in cloud computing job listings, making it the go-to choice for many businesses. What makes AWS so appealing? Well, it's known for its cost-effectiveness, scalability, and rock-solid security features. However, to stand out and succeed in the job market, it's essential to be fully prepared to ace those interviews. In this video, we have compiled the top 20 AWS interview questions that will not only sharpen your knowledge, but also boost your confidence when facing those crucial interviews. As a bonus in this video, along with the top 20 frequently asked questions, we will also cover 5 questions based on case studies that you can definitely expect in your AWS interview. So the first question is, what is AWS and what are its key components? AWS, or Amazon Web Services, is a cloud computing platform offered by Amazon. It provides a wide range of services like computing power, storage options, and networking capabilities. Key components include EC2, Elastic Compute Cloud for virtual servers, S3 or Simple Storage Service for scalable storage, RDS, Relational Database Service for managed databases, and IAM, Identity and Access Management for security. You can also imagine AWS like a huge toolbox which has everything you need to build and run your applications without worrying about the infrastructure. You have EC2, which is like the section for renting virtual computers. S3 for storing your files securely, RDS for managing databases, and IAM for controlling who can access what. Now, what is the difference between EC2 and S3? EC2 provides resizable compute capacity in the cloud, allowing you to run applications. S3, a simple storage service on the other hand, is storage for the internet. EC2 is like having a computer in the cloud, while S3 is more like having a hard drive in the cloud where you can store files. Think of EC2 as a rented computer in the cloud. You can install software, run applications, and do pretty much anything you would do on a regular computer. Now, S3 on the other hand is more like a giant external hard drive. You can store all your files there, like images, videos, or backups, and access them from anywhere on the internet. Now, let's move on to the third question. Explain the concept of elastic load balancing, or ELB. Now, ELB automatically distributes incoming application traffic across multiple targets, such as EC2 instances, containers, and IP addresses, to ensure no single resource is overwhelmed. ELB is like having a traffic manager for your website or application. It automatically spreads incoming visitors or requests across multiple servers so that no single server gets overwhelmed. It's like having a multiple cache registers open at a store during rush hour. Let's move on to the next question. What is autoscaling in AWS? Autoscaling automatically adjusts the number of EC2 instances in a group based on demand. It helps maintain application availability and allows you to only pay for the resources you actually need. So autoscaling is like having a magical elastic band around your servers. When there's a sudden spike in traffic to your website or application, autoscaling automatically adds more servers to handle the load. And when the traffic slows down, it removes those extra servers so you don't waste money on unused resources. Now, describe the difference between IAM users, groups, and roles. IAM users are individuals within your AWS account, while groups are collections of users. Roles are similar to users, but they are meant to be assumed by other AWS services or users for specific tasks. Okay, imagine you're the boss of your AWS account. IAM users are like your employees. They can log in and do stuff, but only what you allow them to. Groups are like teams of users with similar permissions, and roles are like special hats that users or even other services can wear to do specific tasks. Now, the sixth question is, what is Amazon RDS? Amazon RDS, or Relational Database Service, is a managed relational database service that makes it easier to set up, operate, and scale a relational database in the cloud. Amazon RDS is like having a personal database expert on the call. It takes care of all the basic details of setting up, operating, and scaling a relational database like MySQL or PostgreSQL, so you can focus on building your app instead of worrying about database management. Now, explain the difference between Amazon RDS and Amazon DynamoDB. RDS is for relational databases and SQL Server, while DynamoDB is a fully managed NoSQL database service provided by AWS. RDS is like a traditional database with tables, rows, and SQL queries, while DynamoDB is more like a super fast, super flexible storage system for all kinds of data, from simple text to complex JSON documents. It's like comparing a filing cabinet to a magic box that can hold anything you throw at it. Now, what is Amazon VPC? Amazon VPC, or Amazon Virtual Private Cloud, is like having your own private corner of the AWS cloud. It's a virtual network that you can set up and customize to keep your resources isolated and secure. Think of it as creating your own little neighborhood within the vast city of AWS. Now, what is the difference between public and private subnets in Amazon VPC? Imagine public subnets are houses with doors facing the street. They're directly accessible from the internet. Private subnets, on the other hand, are like houses with backyard entrances. They're shielded from direct internet access, making them perfect for storing sensitive data or running internal services. Moving on to the 10th question. How does CloudFront work and what are its benefits? CloudFront is like having a network of delivery trucks all around the world, ready to bring your content closer to your users. When someone requests a file from your website or application, CloudFront finds the nearest delivery truck or edge location and serves the file from there, reducing latency and speeding up the overall experience for your users. Now, what is the difference between Amazon S3 and EBS? Amazon S3 is a giant storage locker in the cloud where you can dump all your files and they'll be safe and accessible from anywhere. AWS, on the other hand, is more like renting a hard drive that you can attach to your virtual server. You can install your operating system and applications on it just like you would do on a regular computer. Now the next question. Explain the difference between the stop and terminate actions in EC2. When you stop an EC2 instance, it's like putting your computer to sleep. All the data and settings are saved and you can start it back up later without losing anything. But when you terminate an instance, it's like shutting down your computer and throwing it away. You lose everything and you can't bring it back. Now, what is AWS Lambda and how does it work? AWS Lambda is like having a team of tiny workers waiting in the cloud to execute your code whenever you need them. You just upload your code to Lambda, define when you want it to run, and Lambda takes care of everything else. Scaling, monitoring, and billing you only for the compute time you actually use. So let's move on to the next question. How do you secure your data at rest in AWS? Think of securing your data at rest like locking it in a safe. AWS offers various encryption options to keep your data safe from prying eyes, whether it's stored in S3 buckets, databases like RDS, or even on your EBS volumes. You can use AWS managed encryption keys or bring your own keys for added security. Moving on, what is CloudFormation and how does it work? CloudFormation is like having a blueprint for your entire AWS infrastructure. Instead of manually setting up each resource, you define everything you need in a template file using simple JSON or YAML syntax. Then, with a single click, CloudFormation creates and configures all the resources for you, saving your time and ensuring consistency. Now the next question, explain the differences between Amazon S3, EBS, and EFS. Amazon S3 is a versatile storage solution for the files of all types, accessible from anywhere. EBS or Elastic Block Store is more like a traditional hard drive attached to a single EC2 instance, perfect for storing data that requires low latency access. Now, EFS or Elastic File System, on the other hand, is like a shared network drive that multiple EC2 instances can access simultaneously, making it ideal for shared file storage across multiple instances. Now, what is Amazon SQS and how does it work? Amazon SQS or Amazon Simple Queue Service is like having a virtual queue for your messages in the cloud. When one part of your application sends a message, SQS holds onto it until another part of your application is ready to receive and process it. It helps decouple different components of your system, making them more resilient and scalable. Now the next question is, what is the difference between Amazon S3 and Glacier? Amazon S3 is like having a storage locker where you can quickly access your files whenever you need them. Glacier, on the other hand, is more like putting your files in cold storage. It's cheaper but slower to retrieve. It's perfect for data that you don't need to access frequently, but still want to keep for archival purposes. Now, what is AWS Elastic Beanstalk? You can relate AWS Elastic Beanstalk to a personal chef who takes care of all the cooking and serving while you focus on enjoying your meal. So it automates the deployment and management of your web applications, handling all the heavy lifting of provisioning servers, load balancing, and scaling. So you can just upload your code and let Elastic Beanstalk take care of the rest. Now coming to the last question on our list, how do you monitor AWS resources and services? Monitoring AWS resources can be explained as having a dashboard that shows you how your applications and services are performing in real time. AWS offers various monitoring tools like CloudWatch, which collects and tracks metrics, logs, and events from your resources, and AWS Trusted Advisor, which provides recommendations for optimizing your AWS environment based on best practices and cost efficiency. And that wraps up our rundown of the top 20 AWS interview questions. But wait, let's have a look at those 5 bonus questions now. Number 1, you are setting up a website for a small shop using AWS. How would you choose the right AWS tools to make sure the website stays fast and reliable, whether there are only a few visitors or a lot of people shopping at once during a big sale? Your second question, imagine you are like a tech detective investigating why a website's database is slow for a busy online shop. How would you use AWS tools to find out what's causing the problem and make the database super fast again? Number 3, As the hero for a startup, your mission is to control their AWS costs while still allowing them to grow. How would you do this, making sure they can expand without spending too much money or slowing down their operations? Now, your fourth question. A non-profit organization needs help migrating their data to AWS. What steps would you take to ensure a smooth transition, considering their limited budget and technical expertise? And the last question we have. A startup wants to store their customer data securely on AWS. How would you recommend they do this, considering both cost and security?
As we wrap up the AWS full course by Simplilearn, paving the way for a rewarding career as an AWS solution architect with demand and salaries on the rise in 2024. You are now ready to seize new opportunities and make your mark in the cloud computing world. Thank you.